In today's data-driven landscape, skilled data analysts are in high demand, and this course is your key to unlocking limitless opportunities. Welcome to Simplilearn's YouTube channel, and today we have the Data Analyst Crash Course for you. It's your expressway to an exciting career in the world of data analysis. This intensive crash course is designed to equip you with the essential skills and knowledge in the shortest time possible. This crash course dives deep into the crucial job roles, showcasing the dynamic field of data analysis. Our video series will help you explore vital data analysis tools like Tableau, Power BI, SQL, Excel, Python, and gaining proficiency that employers covet. As you navigate this crash course, you will not only master the technical aspects but also uncover the art of transforming raw data into actionable insights. This immersive video tutorial will empower you to excel in this dynamic profession. Don't miss out on this chance to take the first step towards becoming a highly sought-after data analyst. Embrace the crash course, embrace your future. Let's dive in and seize those promising data analyst career prospects together. That's it. If these are the types of videos you would like to watch, then like, share and hit that subscribe button and the bell to get notified.
Hello everyone, we have an interesting topic for today, and that is data analytics jobs, career and salary. I will run you through the top 6 data analytics job roles. So before I dive deep into the various job roles, let's quickly understand how important a career in data analytics is and what the future holds for professionals in this domain. Let's take a look at the growth of data. So back in the early 2000s, there was relatively less data generated, but with the rapid rise in technologies and with the increase in the number of various social media platforms and multinational companies across the globe, the generation of data has increased by leaps and bounds. Did you know that according to the IDC, the total volume of data is expected to reach 175 zettabytes in 2025? Now that's a lot of data. Let's take a look at how organizations leverage all of this data. As you know, there are zillions of companies across the world. These companies generate loads of data on a daily basis. When I say data here, it simply refers to business information, customer data, customer feedback, product innovations, sales reports, and profit loss reports, to name a few. Companies utilize all of this data in a wise way. They use all of this information to make crucial decisions that can either hamper or boost their businesses. You might have heard of the term data is the new oil. Well, it definitely is, but only if organizations analyze all the available data very well, then this oil is definitely valuable. And for that, we have data analytics. Organizations take the help of data analytics to convert the available raw data into meaningful insights. So what is data analytics? Technically, you can say it is a process wherein data is collected from various sources, then cleaned, which involves removing irrelevant information, and then finally transformed into some meaningful information that can be interpreted by humans. Various technologies, tools, and frameworks are used in the analysis process. As you might have heard of the term data never sleeps. Well, it surely doesn't. Every millisecond, some or the other data is generated, and this is a constant process. This process is only going to increase in the near future with the advent of newer technologies. The data analytics domain holds paramount importance in every sector. Companies want to leverage on all the generated big data and boost their businesses. They need professionals who can play with data and convert them into crucial insights. Organizations are constantly on the lookout for such candidates, and this opportunity will only increase as data is only going to grow every second. So if you want to start your career in this field, or if you want to switch your job role into a role in the data analytics domain, then we have a set of job profiles that you can look at. We will look into 6 job roles in the data analytics field and learn what each job role is all about, the responsibilities of a professional working in that particular role, the skills required to get that particular job, the average annual salary of a professional working in that role, and finally the companies hiring for that role. So let's start off. First, we have the job role of a data analyst. A data analyst is a person who collects, processes, and performs statistical analysis of large data sets. Every business generates and collects data, be it marketing research, sales figures, logistics, or transportation costs. A data analyst will take this data, and figure out a variety of measures, such as how to price new materials, how to reduce transportation costs, or how to deal with issues that cost the company money. They deal with data handling, data modeling, and reporting. Now, talking about their responsibilities, data analysts recognize and understand the organization's goal. They collaborate with different team members such as programmers, business analysts, engineers, and data scientists to identify opportunities for solving business problems. Data analysts write complex SQL queries, scripts, and store procedures to gather and extract information from multiple databases. They filter and clean data using different modern tools and techniques and make it ready for analysis. They also perform data mining from primary and secondary data sources. Data analysts identify, analyze, and interpret trends in complex data sets. This is done using statistical tools such as R and SAS. Another key responsibility of a data analyst is to create summary reports and build various data visualizations for decision making and presenting it to the stakeholders. Next, let us discuss the important skills that you need to know to become a data analyst. Firstly, you should have a bachelor's degree in computer science or information technology. A master's degree in computer applications or statistics is also preferable. You must have a good understanding of programming languages like R, Python, JavaScript, and also understand SQL. In addition to that, it is beneficial if you have hands-on experience with statistical and data analytics tools such as SAS Miner, Microsoft Excel, and SSAS. Basic understanding of machine learning and its algorithms would be an advantage. Acquaint yourself with descriptive, predictive, prescriptive, and inferential statistics. Most importantly, you need to have a good working knowledge of various data visualization software along with presentation skills. This will help you pitch in your ideas and viewpoints to the clients and stakeholders better. Now, talking about their salaries, a data analyst earns nearly 5,23,000 rupees per annum in India, while in the United States they earn around $62,453 per annum. Let's now look at a few of the companies hiring data analysts. So as you can see, we have the American e-commerce giant Amazon, then we have Microsoft, the American online payment company PayPal, then we have Walmart, Bloomberg, and Capital One. So that was all about data analyst. The next job role is of a business analyst. Business analysts help guide businesses in improving products, services, and software through data-driven solutions. They are responsible for bridging the gap between IT and business using data analytics to evaluate processes, determine requirements, and deliver data-driven recommendations and reports to executives and stakeholders. Business analysts are responsible for creating new models that support business decisions and come up with initiatives and strategies to optimize costs. Now let us look at the various responsibilities of a business analyst. Business analysts have a good understanding of the requirements for business. Their vital role is to work in accordance with relevant project stakeholders to understand their requirements and translate them into details which the developers can understand. They frequently interact with developers and come up with a plan to design the layout of a software application. They also run meetings with stakeholders and other authorities. They engage with business leaders and users to understand how data-driven changes to products, services, software, and hardware can improve efficiencies and add value. They ensure that the project is running smoothly as per the requirements and the design planned through user acceptance and validation testing. They make sure all the features are being incorporated into the application. BAs rely on different software to write documentation and design visualization to explain all the findings. It is extremely critical for any BA to effectively document the findings where each requirement of the client is mentioned in detail. Now let us look at the skills required for a BA. A bachelor's degree in the field of science, engineering, or statistics or any related domain will suffice. Knowledge of programming languages such as Python and Java is beneficial. You should be really good at writing complex SQL queries, and you should also have knowledge of various business process models. Along with knowledge of programming languages, ideas about statistical analysis and predictive modeling is necessary. Decision-making, strong analytical and problem-solving skills are necessary to solve software and business issues. You also need to have excellent presentation and communication skills, both oral and written. Moving on to their salary, a business analyst is expected to earn around 7 lakh rupees per annum in India. In the US, they earn nearly $68,346 per annum. IQVIA, Dell, Philips, Honeywell, the famous American messaging platform WhatsApp, the UK-based company Ernst & Young are few of the companies hiring for business analysts. Up next, we have the job role of a database administrator. A database administrator is a specialized computer systems administrator who maintains a successful database environment by directing or performing all related activities to keep the organization's data secure. They are responsible for storing, organizing, and retrieving data from several databases and data warehouses. Their top responsibility is to maintain data integrity. This means that database administrator will ensure that the data is secure from unauthorized access. Moving on to their responsibilities. A database administrator develops, designs, and maintains a database to ensure that the data in it is properly stored, organized, and managed well. They maintain data integrity by avoiding unauthorized access, and they keep databases up to date. They run tests and modify the existing databases to ensure that they operate reliably. They also inform end users of changes in databases and train them to utilize systems. They need to cooperate with programmers, data analysts, and the IT staffs to ensure smooth running and maintenance of databases. Database administrators are responsible for taking system backups in case of power outages and other disasters. So they should have an efficient disaster recovery plan. Now let's have a look at their skills. To become a database administrator, you should have a bachelor's degree in computer science or information technology. Knowledge of programming languages such as Python, Java, and Scala is important. You need to carry at least 3 to 5 years of experience in data management. You need to have an understanding of different databases such as Oracle DB, MongoDB, MySQL Server, and PostgreSQL. Also, they should have an idea about database design and writing SQL queries. Finally, you need to have a good understanding of operating systems such as Windows, Mac OS, and Linux, along with storage technologies. Talking about their salary, a database administrator in India can earn up to 4,97,000 rupees per annum. In the US, they earn around $78,000 per annum. Let's have a look at the companies hiring for database administrators. So as you see, here we have BookMyShow, Oracle, the American MNC Intel, Amazon, Robert Half, and the New York Times, to name a few. Fourth in the list of job roles, we have data engineer. A data engineer is someone who's involved in preparing data for analytical and operational uses. A data engineer transforms data into useful format for analysis. They build and test scalable big data ecosystems for businesses. A data engineer is an intermediary between a data analyst and a data scientist. Now let's jump into their responsibilities. Data engineers develop, test, and maintain architectures. They are responsible for managing, optimizing, and monitoring data retrieval, storage, and distribution throughout the organization. They discover opportunities for data acquisition, find trends in datasets, and develop algorithms to help make raw data more useful to the enterprise. Data engineers build large data warehouses using ETL for storing and retrieving data. They also recommend ways to improve data quality and efficiency, along with building algorithms to help give easier access to raw data. Data engineers often work with big data and submit their reports to data scientists for analysis purpose. They need to recommend and sometimes implement ways to improve data reliability, efficiency, and quality. Moving on to the skills of a data engineer. A data engineer should hold a bachelor's degree in computer science or information technology. They should have good hands-on experience with Python, R, and Java. Also, data engineers should be well-versed with big data technologies such as Hadoop, Apache Spark, Scala, Cassandra, and MongoDB. Data warehousing and ETL experience are essential to this position along with in-depth knowledge of SQL and other database solutions. Basic knowledge of statistical analysis will be an advantage along with idea about operating systems. Here is what a data engineer can earn. So in India, a data engineer can earn up to 8,85,000 rupees per annum, while they can earn around $103,000 a year in the USA. We have Capgemini, Shutterstock, the American provider of stock photography, Spotify, Accenture, Genpact, and Facebook hiring data engineers. The next exciting job role is of a data scientist. A data scientist is a professional who uses statistical methods, data analysis techniques, machine learning, and related concepts in order to understand and analyze data to draw business conclusions. They make sense to messy and unstructured data and bring value out of it. They employ techniques and theories drawn from many fields within the context of mathematics, statistics, computer science, and information science. A data scientist understands the challenges in business and comes up with the best solutions using modern tools and techniques to analyze, visualize, and build prediction models to make business decisions. Let us now look at their responsibilities in the industries. Data scientists clean, process, and manipulate data using several data analytics tools. They perform ad hoc data mining, collect large sets of structured and unstructured data from disparate sources. They design and evaluate advanced statistical models to work on big data. They also create automated anomaly detection systems and keep constant track of their performance. Data scientists interpret the analysis of big data to discover solutions and opportunities. A data scientist takes input from data analysts and engineers to formulate the results. They use visualization packages and tools to create reports and dashboards for relevant stakeholders. They also adopt new business models and approaches. Apart from this, they regularly build predictive models and machine learning algorithms. Now moving on to the skills of a data scientist. A bachelor's degree in computer science or information technology will be fine, but a master's degree in the field of data science will hold a major advantage. You also need to have a good experience in the analytics domain. You should be proficient in programming languages such as Python, Java, and C++. Knowledge of Perl will also be an advantage. Familiarity with Apache Hive, Pig, and Apache Spark is necessary along with the knowledge of Hadoop. In addition to knowing programming languages, you also need to know SQL, machine learning, and deep learning. Data visualization and BI skills are necessary for creating reports and dashboards. You should also be able to communicate and present information and ideas properly. Now talking about their salary, a data scientist in India can expect an annual salary of 10,47,000 rupees per year. Meanwhile, in the US, they can earn up to $113,000 per annum. That's a lot of money. From the many companies hiring for data scientists, here we have a few companies named. They are yet again Amazon, Citibank, Apple, Google, the Japanese electronic commerce and online retailing company Rakuten, and Facebook. And finally, we have machine learning engineer. Machine learning engineers are professionals who develop intelligent machines that can learn from vast amounts of data and apply knowledge without human intervention. They use different algorithms and statistical modeling to make sense of data. They design and develop machine learning and deep learning algorithms. Their main goal is to create self-running software. Let's have a look at the responsibilities of a machine learning engineer. Machine learning engineers research, design, and develop machine learning systems. They use exceptional mathematical skills in order to perform faster computations and work with algorithms to create sophisticated models. They perform A/B testing and use data modeling to fine-tune the results. They use data modeling and evaluation strategy to find hidden patterns and predict unseen instances. Machine learning engineers work closely with data engineers to build data pipelines and interact with stakeholders to get a clarity on the requirements. Most importantly, they analyze complex data sets to verify data quality, perform model tests and experiments, choose to implement the right machine learning algorithm, and select the right training data sets. Moving on to their skills. A machine learning engineer should have a degree in computer science and information technology. They should have an advanced degree in computer science or maths. In addition to this, they should also have experience in the same domain. They should be proficient in programming languages such as Python, R, C++, and Java. Knowledge of statistics, probability, and linear algebra is necessary as all the machine learning algorithms have been derived from mathematics. Also, having an idea of signal processing would be beneficial. Machine learning engineers need to have a good understanding of data manipulation and machine learning libraries such as NumPy, Pandas, scikit-learn, etc. They should have good oral and written communication skills. Let us now have a look at their salary structure. A machine learning engineer earns 8 lakh rupees per annum in India, while in the US they can earn around $114,000 a year. Now that's a whopping amount, isn't it? Let's have a look at the companies hiring machine learning engineers. So as you see, we have Amazon, Microsoft, Oracle, Salesforce, Rapido, and Accenture to name a few. That was all about the job role of a machine learning engineer. Now that we have seen the different job roles in the field of data analytics, let's also go ahead and see how an ideal resume of a data analyst should look like. Seen on your screens is a sample resume of a data analyst. You can grab some ideas from this and incorporate them in your resume. Nowadays, it's quite common to have a professional photograph of yours on the resume. You can go ahead and have that. Then your name in bold, followed by your contact details like email ID and phone number. Then moving on, you would have to write a summary. Briefly explain your current job role and what you're looking for in the future. Having a LinkedIn profile link works well these days. Employers can just go ahead and look at your profile and gauge you well. Make sure to have an active LinkedIn profile. In addition to LinkedIn profile, it's also good to have a GitHub profile link which can show your coding or other technical skills. If it's impressive enough, then a lot of times the rest of your resume is just secondary. As I mentioned, this is a resume of a data analyst. So as you can see in the summary here, we have just spoken about the basic responsibilities of a data analyst. Moving on to the experience part, you have to write the job title and below that you can mention the company and the tenure accordingly. Here you would have to give a brief description of achievements in the organization, any relevant accomplishments related to the job you're applying for, the tools and the various technologies you have worked with. So in this sample, you can see we have spoken about data visualization using R and Tableau. Next, we have spoken about how the candidate has worked with other teams for a better business outcome. Most of the data analysts use SQL and Excel to handle data for reporting and database maintenance, and we have mentioned that here as well. Do make sure that you always specify the tools you use. Then you can also mention if you have worked on improving data delivery. For example, here we have spoken about developing and optimizing SQL queries, data aggregations, and ETL to improve data delivery. Finally, you can speak a bit about your reporting skills and if needed, elaborate on it. Usually, professionals would have worked in a similar domain before becoming a data analyst. Here, we have taken the role of a statistical assistant as the first job, since it's easier for a candidate with this job role to shift into the data analytics field. Nevertheless, y'all can still mention your prior experience here, be it in any domain. Under the responsibilities for this job role, we have given basics such as coding data prior to computer entry, compiling statistics from various reports, computing and analyzing data, and finally some visualization and reporting. Moving to the education, here you can mention the name of your degree and the university name. If you have a post-graduation, well and good, you can list both the degrees here. Also, if you have any certifications, You can mention them here under the education category. Now moving to the skills. Depending on your skills and your choice, you can either shift this part to the beginning of the resume or have it here. As you see on your screens, this is just a different way of displaying your skill sets. You can have all the 5 stars colored if you are excellent in that particular tool or language. As you see, it's crystal clear as to what the candidate's strong areas are. You can have various categories like shown. For example, under software development, you can list the languages that you know and how proficient you are in those particular languages. It's clear that the candidate knows Python better than JavaScript here. So the employer gets a clear idea about the skills you possess and the depth of it. Similarly, you can mention the databases as well. The few mentioned here are more or less a requirement to become a data analyst. At least, SQL is a must. Not to forget, data visualization is also very important when it comes to the job role of a data analyst. Mention the tools you know here and similarly give yourself a rating out of 5. 5 stars shaded being the highest. Here we have mentioned Tableau and Excel, which are more than sufficient to become a data analyst. Moving to the non-technical skills, you can mention the languages you know here. Here we have taken English and German. In addition to the languages, you can also feel free to mention the extracurricular activities that you are good at. So this is how an ideal resume of a data analyst should look like. You can alter it according to your achievements, skills, and experience.
A study from New Vantage Partners suggests 97.2% of companies are now investing in data and its analysis. Nowadays, every company needs a data expert. Do you also want to become a part of this market? If yes, how to become a part of it? What are the essential skills one should have? This video will answer all these questions. But before watching this video, please subscribe to Simplilearn's YouTube channel and press the bell icon to never miss any updates. First of all, we are going to discuss who is a data analyst, working of a data analyst, skills required to become a data analyst, tools required, and companies hiring. And finally, we are going to discuss about salary of a data analyst. Let me tell you how Simplilearn can help you in your journey to become a data analyst. Check out the course on data analytics in collaboration with IBM with real-time project and business case studies. You will learn tools like SciPy, Pandas, and programming languages like Python or R too. Enroll now. Link is in the description box below. Question for you. Which one of the following is not a Python library for visualization? Matplotlib, SciPy, Pandas, Jupyter Notebook. Please leave the answer in the comment section below. Moving on, who is a data analyst? A data analyst collects, analyzes, and interprets data. A data analyst will convert raw data into useful information. Data analysts are in high demand because every industry uses data analysis. Work of a data analyst. As a data analyst, you will work closely with the raw data and generate valuable insights to help companies decide their future goal. If you like thinking out of the box, you are the perfect fit for this domain. Data analysts help maximize output when it comes to generating revenue, working closely with both business and data. Nevertheless, this field boasts handsome salaries for all levels of expertise. Can you become a data analyst without prior experience? Yes, anyone can become a data analyst if they enjoy solving real-world problems, have a strong background in statistics, and have a creative mind. If you feel you don't have it, you can definitely develop it. So let us know the skills in detail. What are the basic skill sets required for a data analyst? Data analyst must know basic mathematics and statistics, programming skills, machine learning, and also data visualization tools. So let us know what are the basics that you need to learn as a data analyst. Mathematics. It is always better to know basic mathematics like linear algebra and probability fundamentals. Linear algebra is used in data pre-processing and transformation, which is the critical process of every data analyst. Statistics, a branch of mathematics that deals with collection, analysis, presentation, and implementation. Probability. We know that probability is the study of how likely something will happen, which is essential for concluding. Both probability and statistics are the backbones of data analysis. It is feasible to become a data analyst with only a basic understanding of these three areas of mathematics. But in order to remain relevant and grow as a data analyst, one mathematical knowledge should not be restricted. Compulsorily use some of the tools as a data analyst. What are that? First is Microsoft Excel. It is the most well-known spreadsheet software in the world. It also has computation and graphing features that are excellent for data analysts. No matter your area of expertise or additional software you might want, Excel is a standard in the industry. Its useful built-in features include form design tools and pivot table. It also generates a wide range of additional features that help simplify data manipulation. As a programming language, every data analyst should know Python. It is easy to learn and has a simple syntax. Python is quite adaptable and includes a vast variety of resource libraries that are appropriate for a wide range of diverse data analytics activities. These libraries help in numerical and data computation. The Pandas and NumPy libraries, for instance, are excellent for supporting standard data processing and streamlining highly computational operations. You can also choose between Python or R. R is a well-known open source programming language much like Python. Data visualization tool. As we previously mentioned, data visualization tool is also necessary to become a data analyst. Power BI is a user-friendly interface, makes building interactive visual reports and dashboards simple. Its most vital selling point is its superb data integration. It works flawlessly with cloud sources like Google and Facebook Analytics, as well as text files, SQL servers, and Excel. Tableau is one of the best commercial data analysis tool available. It handles huge amounts of data better than many other BI tools and is effortless. It has a visual drag and drop interface. However, because it has no scripting layer, there is a limit to what Tableau can do. For example, it could be better for pre-processing data or building more complex calculations. You might have heard about MySQL a lot of time. It is a standard language for interacting with databases, and it is very helpful when working with structured data. SQL creates user-friendly dashboards that may present in various data ways since it is so simple to send complex commands to databases and change data in seconds. It has commands like add, edit, delete data. In addition, SQL is an excellent tool for creating data warehouses because of its simplicity, clarity, and interactivity. Overall, I would suggest that to become a data analyst, you should work on programming languages like Python or R plus MySQL to work on databases, adding to that Excel plus visualization tools like Tableau or Power BI. You now know what are the skills are and how it is used. What are you up to in an organization as a data analyst? To create and evaluate the report using automated tools like Tableau or Power BI. To troubleshoot the reporting database environment and reports. Data analyst, you will use statistical method to analyze data sets and spot any valuable trends that may develop over time. Evaluate companies' functional and non-functional requirements. Data analyst assess data warehousing in inspecting and reporting needs. These are all the responsibility of a data analyst in an organization. Coming to companies hiring a data analyst. IBM, Accenture, Capgemini, TCS, Facebook, Amazon, Flipkart, Meta. These are the top companies hiring a data analyst. But data suggests that every small and medium-sized company needs a data analyst. Therefore, demand of a data analyst is in every company. So, there is no need to worry. Job and salary of a data analyst. This is the final part. The salary of a data analyst is high all over the world. When it comes to the USA, the average salary for a data analyst as a beginner is going as high as $70,000 plus per annum. For experienced professional, it is going as high as $120,000 per annum. In India, for a fresher, it is going as high as 8 lakh per annum, and for experienced professionals, it is 20 lakh plus per annum. Such is the demand for data analyst. Now that we have covered every important skill, it's time for you to start working on it.
Certifications have become an essential benchmark for professional growth and recognition in the dynamic field of data analytics. They not only validate your expertise but also open doors to exciting new career opportunities. And when it comes to top-notch certifications, Simplilearn has established itself as a trusted provider of choice. So let's embark on a journey, discover the best data analyst certifications available for you. Are you eager to step into the exciting world of data analytics? Look no further than Simplilearn's postgraduate program in data analytics. This comprehensive program is designed to equip you with the essential skills and knowledge needed to thrive in this rapidly evolving field. Let's look into the extraordinary features and benefits that make this program truly stand out from the crowd. First and foremost, Simplilearn's Career Services is here to ensure that your talent are noticed by top hiring companies, giving you a competitive edge in the job market. Upon successfully completion of the program, you will receive a prestigious postgraduate program certificate, powerful testament to your commitment and expertise in the field of data analytics. This certificate holds a value that can open several career opportunities. To further enhance your learning experience, we have introduced an exclusive partnership with industry giant IBM. Through this collaboration, we bring you unparalleled opportunities such as exclusive hackathons and Ask Me Anything sessions with IBM experts. This unique expertise allows you to engage directly with industry professionals, gain invaluable insights, and tackle real-world challenges faced by data analysts. This collaboration ensures that you receive cutting-edge knowledge and stay ahead of the curve. At Simplilearn, we believe in the power of interactive learning. That's why our live online classes offer an astonishing 8x higher level of live interaction compared to other programs. Delivered by industry experts, these engaging sessions provide you with a platform to ask questions, participate in discussions, and gain practical insights that will deepen your understanding of the subject matter. One of the defining features of our program is the hands-on approach to the learning. Through our innovative applied learning model, you will have the remarkable opportunity to work on a variety of real-world projects using industry datasets for reputable sources such as Google Play Store and the World Bank. With our 14 data analytics project your belt, you will gain valuable practical experience and develop an impressive portfolio that showcases your skills to potential employers. To enrich your learning journey even further, we present masterclass delivered by esteemed faculty from Purdue and IBM experts. Their immense knowledge and expertise will provide you with the valuable insights and unique perspective, ensuring that you receive a well-rounded in data analytics. Now, you may be wondering if this program is suitable for you. The answer is yes. Our postgraduate program in data analytics is thoughtfully designed to the need of all working professionals. Whether you are an experienced data analyst looking to upskill or someone new to the field, this program is perfect fit. No prior programming knowledge is required as we cover everything from the fundamentals to advanced technologies. Throughout the program, you will acquire a wide range of skills essential for success career in data analytics. These includes data analytics, statistical analytics using Excel, data analysis with Python and R, data visualization using Tableau and Power BI, model on linear and logistic recursion, clustering using K-mean, and supervised learning technologies. Our comprehensive curriculum ensures that you are equipped with the necessary tools to excel in this rapidly growing field. So, why wait any longer? Join Simplilearn's postgraduate program in data analytics and unlock the world of opportunities. Prepare to dive deep into the realm of data analytics, collaborate with industry experts, and gain hands-on experience with real-world projects. Your journey to become a data analytics professional starts right here. So the link of this program will be in the description box below. Do check it out and enroll now. Next, we have Data Analytics Bootcamp. Stay ahead of the data revolution with the Caltech Data Analytics Bootcamp, a collaborative program offered by Caltech designed specifically for working professionals and students of the US. This bootcamp adapts an applied learning approach, providing integrated labs and real-world projects for the business environment. Experience academic excellence with the Caltech Data Analytics Bootcamp while also enjoying the benefits of Caltech Campus Connect. The program offers highly interactive learning, ensuring active participation and engagement. This provides ample hands-on experience to reform your skills. The Caltech Data Analytics Bootcamp caters to individuals from diverse backgrounds, offering substantial benefits to working professionals. Gain assets such as Excel proficiency, data-driven presentation technologies, data manipulation with SQL, data analytics using Python, and data visualization using Tableau. Additionally, you will learn data analytics with the tools like AWS and other industry-relevant technologies. Covering a comprehensive curriculum, the Caltech Data Analytics Bootcamp dive into key concepts including data analytics with Excel, Python-based data analytics, database management with SQL, Tableau for data visualization, and data analytics on AWS. By completing this bootcamp, you will be equipped with the range of tools and technologies. By choosing this bootcamp, you open doors to exciting career opportunities with renowned companies such as Microsoft, Google, Amazon, IBM, Apple, and many more. The Caltech Data Analytics Bootcamp has successfully empowered numerous aspirants data analysts, and their testimonials are available on the course page. We have another professional certification course in data analytics provided by the IIT Kanpur for Indian professionals and students. Are you ready to unlock the secrets hidden within vast amount of data and gain a comprehensive edge in today's cutthroat business world? Simplilearn's Data Analyst course, delivered in collaboration with IIT Kanpur, will provide you with extensive expertise in the booming field of data analytics. This course is designed to provide a deep understanding of the principles, technologies, and applications of data analytics, empowering you to efficiently analyze, interpret, and extract the actionable insights from the data. The course follows a structured learning path that covers various aspects of data analytics, including business analytics using Excel, SQL programming foundation using Python, data analytics with R programming, and Tableau training. Some of the key features of this program includes master classes delivered by distinguished IIT Kanpur faculty, hands-on lab experience to help you master 14 plus tools and frameworks, and industry-ready projects designed to advance your career trajectory. Simplilearn's Job Assistance Services is here to help you get noticed by top hiring companies, increasing your chances to secure a rewarding position with renowned companies like Microsoft, Google, Amazon, IBM, Goldman Sachs, and many more. Upon successful completion of the program, you will receive a professional certificate from IIT Kanpur, adding immense value to your credentials. So, what are you waiting for? Enroll now and embark on this transformative journey with IIT Kanpur's Data Analytics course. Unlock the boundless potential of data. Countless inspiration data analysts have benefited from the data analytics program. You can find their testimonial by following the link in the course page in the description box below.
In today's fast-paced digital landscape, businesses face a daunting challenge: extracting valuable insights from massive amounts of data. Enter the ETL pipeline, the backbone of data processing and analytics. In this tutorial, we will embark on an exhilarating journey unveiling the secrets of building a powerful ETL pipeline. Whether you are a seasoned data engineer or just starting your data-driven adventure, this video is your gateway to unlocking the full potential of your data. Together, we will demystify the ETL process step by step. We'll dive into the extract phase, where we retrieve data from multiple sources, ranging from databases to APIs. And then we'll seamlessly transition into transformation phase, where we clean, validate, and reshape the data into a consistent format. But wait, there's more. We will explore cutting-edge techniques for handling large datasets, leveraging cloud-based technologies, and ensuring quality. We aim to equip you with tools and knowledge to create robust and scalable ETL pipelines to handle any data challenge.
So buckle up and get ready to revolutionize your data workflow. Join us in this exhilarating journey to master the art of ETL pipelines. Having said that, if you're an aspiring data analyst looking for online training and certifications from prestigious universities and in collaboration with leading experts, then search no more. Simplilearn's postgraduate program in data analytics from Purdue University in collaboration with IBM should be a right choice. For more details, use the link in the description box below. With that in mind, over to our training experts.
Hey everyone, so without further ado, let's get started with ETL pipeline. So ETL basically stands for extract, transform and load. So ETL pipelines fall under the umbrella of data pipelines. A data pipeline is simply a medium of data extraction, filtration, transformation, exporting and loading activities through which the data is delivered from producer to consumer. To make it a little simpler, the data is produced in two types. Let's say you run a vehicle showroom and you are being a data producer. So the data that you produce is very less and that could be basically fit into an Excel sheet. This type of data might need update once in 24 hours or based on your audit cycle. Here we call it batch data, and this data is processed using the OLTP model and batch processing tools. But now, let's say you're running an entire vehicle manufacturing plant. Now, the data you're dealing with is voluminous and includes various types of data. It can be structured data, unstructured data, semi-structured data, ranging from space inventory to all the way up to robotic assembly sensors data. Based on requirements, this type of data needs updates maybe every hour, every minute, or even every second. Such type of data is called real-time data and needs real-time data streaming frameworks, and the data is processed using OLAP models. Now, ETL is involved in both these approaches. Now, let's dive in and understand what exactly is an ETL pipeline. ETL stands basically for extract, transform, and load, and representing these three core steps in data integration and transformation process. Let's dive into each phase and explore their significance. Firstly, extract. The first step in ETL pipeline is extracting data from various sources. These sources can range from relational databases, data warehouses, APIs, or even streaming platforms. The goal is to gather raw data and bring it into centralized location for further processing. Tools like Apache Kafka, Apache NiFi, or even custom scripts can be used to perform the extraction efficiently. Next is transform. Once the data is extracted, it often requires significant cleaning, validation, and restructuring. This is transformation phase. The transformation phase ensures that the data is consistent, standardized, and ready for analysis. Transformations can include tasks such as data cleansing, filtering, aggregating, joining, or applying complex business rules. Tools like Apache Spark, Talent, or Python libraries like Pandas are commonly used for these transformations. Lastly, we have the load phase. The final step is loading the transformed data into target systems such as data warehouse, data lake, or database optimized for analysis. This allows business users and analysts to access and query the data easily. Loading can involve batch processing or real-time streaming depending upon the requirements of the business. Technologies like Apache Hadoop, Amazon Redshift, or Google BigQuery are often employed for efficient data loading. Now that we understood the core phases, let's explore some key concepts and best practices for building robust ETL pipelines. Firstly, data quality. Ensuring data quality is crucial for reliable analysis. Implementing data validation checks, handling missing values, and resolving data inconsistencies are vital to maintaining data integrity throughout the pipeline. Next is scalability. As data volumes grow exponentially, scalability becomes essential. Distributed computing frameworks like Apache Spark enable processing large datasets in parallel, allowing the pipelines to handle increasing data loads efficiently. Thirdly, we have error handling and monitoring. Robust error handling mechanisms such as retry, logging, and alerting should be implemented to handle failures gracefully. Additionally, monitoring tools can provide real-time insights into pipeline performance, allowing quick identification and resolution of issues. Next, we have incremental loading. For continuously evolving datasets, incremental loading strategies can significantly improve pipeline efficiency. Rather than processing the entire dataset each time, only the new or modified data is extracted and transformed, reducing processing time and resource consumption. And lastly, we have data governance and security. Incorporating data governance practices and adhering to security protocols is crucial for protecting sensitive data and ensuring compliance with regulations like GDPR or HIPAA. Now that we have covered what exactly is ETL and the ETL stages and also the best practices for ETL pipelines, let's proceeding with understanding the popular ETL tools. So the first one amongst the popular ETL tools is the Apache Airflow. Apache Airflow is an open source platform that allows you to schedule, monitor, and manage complex workflows. Apache Airflow provides a rich set of operators and connectors, enabling seamless integration with various data sources and destinations. Next is Talend, a comprehensive ETL tool that offers a visual interface for designing data integration workflows. Talend provides a vast array of pre-built connectors, transformations, and data quality features, making it ideal choice for enterprises. And lastly, we have Informatica. Informatica is a widely used enterprise-grade ETL tool that supports complex data integration scenarios. PowerCenter offers a robust set of features like metadata management, data profiling, and data lineage, empowering organizations.
So what is data analysis? Data analysis is not just a single step but a set of processes. It is the process of collecting data, then cleaning it. When I say cleaning, it simply means removing the irrelevant data, and then this data is transformed into meaningful information. We can simply relate this process to how you make a jigsaw puzzle. Just like how you gather all the pieces together and fit them accordingly to bring out a beautiful picture. Data analysis also works on almost the same grounds. To achieve the goals of data analysis, we use a number of data analysis tools. Companies rely on these tools to gather and transform their data into meaningful insights. So which tool should you choose to analyze your data? Which tool should you learn if you want to make a career in this field? We will answer that in this session. After extensive research, we have come up with these top 10 data analysis tools. Here, we will look at the features of each of these tools and the companies using them. So let's start off. At number 10, we have Microsoft Excel. All of us would have used Microsoft Excel at some point, right? It is easy to use and one of the best tools for data analysis. Developed by Microsoft, Excel is basically a spreadsheet program. Using Excel, you can create grids of numbers, text, and formulae. It is one of the widely used tools, be it in a small or large setup. The interface of Microsoft Excel looks like this. Let's now move on to the features of Excel. Firstly, Excel works with almost every other piece of software in Office. We can easily add Excel spreadsheets to Word documents and PowerPoint presentations to create more visually appealing reports or presentations. The Windows version of Excel supports programming through Microsoft's Visual Basic for Applications (VBA). Programming with VBA allows spreadsheet manipulation that is difficult with standard spreadsheet techniques. In addition to this, the user can automate tasks such as formatting or data organization in VBA. One of the biggest benefits of Excel is its ability to organize large amounts of data into orderly, logical spreadsheets and charts. By doing so, it's a lot easier to analyze data, especially while creating graphs and other visual data representations. The visualization can be generated from specified group of cells. Those were few of the features of Microsoft Excel. Let's now have a look at the companies using it. Most of the organizations today use Excel. Few of them that use it for analysis are the UK-based company Ernst & Young. Then we have Urban Pro, Wipro, and Amazon. Moving on to our next data analysis tool, at number 9, we have RapidMiner. A data science software platform, RapidMiner provides an integrated environment for data preparation, analysis, machine learning, and deep learning. It is used in almost every business and commercial sector. RapidMiner also supports all the steps of the machine learning process. Seen on your screens is the interface of RapidMiner. Moving on to the features of RapidMiner. Firstly, it offers the ability to drag and drop. It is very convenient to just drag drop some columns as you are exploring a data set and working on some analysis. RapidMiner allows the usage of any data, and it also gives an opportunity to create models which are used as a basis for decision making and formulation of strategies. It has data exploration features such as graphs, descriptive statistics, and visualization, which allows users to get valuable insights. It also has more than 1,500 operators for every data transformation and analysis task. Let's now have a look at the companies using RapidMiner. We have the Caribbean airline Leeward Islands Air Transport. Next, we have the United Health Group, the American online payment company PayPal, and the Austrian telecom company Mobilcom. So that was all about RapidMiner. Now let's see which tool we have at number 8. We have Talent at number 8. Talent is an open source software platform which offers data integration and management. It specializes in big data integration. Talent is available both in open source and premium versions. It is one of the best tools for cloud computing and big data integration. The interface of Talent is as seen on your screens. Moving on to the features of Talent. Firstly, automation is one of the great boons Talent offers. It even maintains the tasks for the users. This helps with quick deployment and development. It also offers open source tools. Talent lets you download these tools for free. The development costs reduce significantly as the processes gradually speed up. Talent provides a unified platform. It allows you to integrate with many databases, SaaS, and other technologies. With the help of the data integration platform, you can build flat files, relational databases, and cloud apps 10 times faster. Those were the features of Talent. The companies using Talent are Air France, L'Oreal, Capgemini, and the American multinational pizza restaurant chain Domino's. Next on the list at 7 we have KNIME. Constance Information Miner on KNIME is a free and open source data analytics, reporting, and integration platform. It can integrate various components for machine learning and data mining through its modular data pipelining concept. KNIME has been used in pharmaceutical research and other areas like CRM customer data analysis, business intelligence, text mining, and financial data analysis. Here is how the interface of KNIME application looks like. Now coming to the KNIME features. KNIME provides an interactive graphical user interface to create visual workflows using the drag and drop feature. Use of JDBC allows assembly of nodes blending different data sources, including pre-processing such as ETL, that is extraction, transformation, loading, for modeling, data analysis, and visualization with minimal programming. It supports multi-threaded in-memory data processing. KNIME allows users to visually create data flows, selectively execute some or all analysis steps, and later inspect the results, models, and interactive views. KNIME Server automates workflow execution and supports team-based collaboration. KNIME integrates various other open source projects such as machine learning algorithms from Becker, H2O, Keras, Spark, and our project. KNIME allows analysis of 300 million custom addresses, 20 million cell images, and 10 million molecular structures. Some of the companies hiring for KNIME are United Health Group, ASML, Fractal Analytics, Atos, and Lego Group. Let's now move on to the next tool. We have SAS at number 6. SAS facilitates analysis, reporting, and predictive modeling with the help of powerful visualizations and dashboards. In SAS, data is extracted and categorized, which helps in identifying and analyzing data patterns. As you can see on your screens, this is how the interface looks like. Moving on to the features of SAS. Using SAS, better analysis of data is achieved by using automatic code generation and SAS SQL. SAS allows you to access through Microsoft Office by letting you create reports using it and by distributing them through it. SAS helps with an easy understanding of complex data and allows you to create interactive dashboards and reports. Let's now have a look at the companies using SAS. We have companies like Genpact, IQVIA, Accenture, and IBM to name a few. That was all about SAS. So for all those who joined in late, let me just quickly repeat our list. At number 10, we have Microsoft Excel. Then at number 9, we have RapidMiner. At number 8, we have Talent. At number 7, we have Nine. And at number 6, we have SAS. So far, do you all agree with this list? Let us know in the comment section below. Let's now move on to the next 5 tools in our list. So at number 5, we have both R and Python. Yes, we have 2 of them in the 5th position. R is a programming language which is used for analysis as well. It has traditionally been used in academics and research. Python is a high-level programming language which has a Python data analysis library. It is used for everything starting from importing data from Excel spreadsheets to processing them for analysis. This is the interface of R. Next up is the interface of the Python Jupyter Notebook. Let's now move on to the features of both R and Python. When it comes to the availability of R and Python, it is very easy. Both R and Python are completely free, hence it can be used without any license. R used to compute everything in memory and hence the computations were limited, but now it has changed. Both R and Python have options for parallel computations and good data handling capabilities. As mentioned earlier, as both R and Python are open in nature, all the latest features are available without any delay. Moving on to the companies using R, we have Uber, Google, Facebook, to name a few. Python is used by many companies. Again, to name a few, we have Amazon, Google, and the American photo and video sharing social networking service, Instagram. That was all about R and Python. At number 4, we have Apache Spark. Apache Spark is an open source engine developed specifically for handling large-scale data processing and analytics. Spark offers the ability to access data in a variety of sources including Hadoop Distributed File System HDFS, OpenStack Swift, Amazon S3, and Cassandra. It allows you to store and process data in real time across various clusters of computers using simple programming constructs. Apache Spark is designed to accelerate analytics on Hadoop while providing a complete suite of complementary tools that include a fully featured machine learning library, a graph processing engine, and stream processing. So this is how the interface of Apache Spark looks like. Now let's look at the important features of Apache Spark. Spark stores data in the RAM, hence it can access the data quickly and accelerate the speed of analytics. Spark helps to run an application in a Hadoop cluster up to 100 times faster in memory and 10 times faster when running on disk. It supports multiple languages and allows the developers to write applications in Java, Scala, R, or Python. Spark comes up with 80 high-level operators for interactive querying. Spark code for batch processing, join stream against historical data, or run ad hoc queries on stream state. Analytics can be performed better as Spark has a rich set of SQL queries, machine learning algorithms, complex analytics, etc. Apache Spark provides fault tolerance through Spark RDD. Spark resilient distributed data sets are designed to handle the failure of any worker node in the cluster. Thus, it ensures that the loss of data reduces to 0. Conviva, Netflix, IQVIA, Lockheed Martin, and eBay are some of the companies that use Apache Spark on a daily basis. At number 3, we have another important growing data analysis tool, that is ClickView. ClickView software is a product of Qlik for business intelligence and data visualization. ClickView is a business discovery platform that provides self-service BI for all business users and organizations. With ClickView, you can analyze data and use your data discoveries to support decision making. ClickView is a leading business intelligence and analytics platform in Gartner Magic Quadrant. On the screen, you can see how the interface of ClickView looks like. Now talking about its features. ClickView provides interactive guided analytics with in-memory storage technology. During the process of data discovery and interpretation of collected data, the ClickView software helps the user by suggesting possible interpretations. ClickView uses a new patent in-memory architecture for data storage. All the data from the different sources is loaded in the RAM of the system and it is ready to be retrieved from there. It has the capability of efficient social and mobile data discovery. Social data discovery offers to share individual data insights within groups or out of it. A user can add annotations as an addition to someone else's insights on a particular data report. ClickView supports mobile data discovery within an HTML5-enabled touch feature which lets the user search the data and conduct data discovery interactively and explore other server-based applications. ClickView performs OLAP and ETL features to perform analytical operations, extract data from multiple sources, transform it for usage, and load it to a data warehouse. The companies that can help you start your career in ClickView are Mercedes-Benz, Capgemini, Citibank, Cognizant, and Accenture, to name a few. At number 2, we have Power BI. Power BI is a business analytics solution that lets you visualize your data and share insights across your organization or embed them in your app or website. It can connect to hundreds of data sources and bring your data to life with live dashboards and reports. Power BI is the collective name for a combination of cloud-based apps and services that help organizations collate, manage, and analyze data from a variety of sources through a user-friendly interface. Power BI is built on the foundation of Microsoft Excel and has several components such as Windows desktop application called Power BI Desktop and online software as a service called Power BI Service, mobile Power BI apps available on Windows phones and tablets, as well as for iOS and Android devices. Here is how the Power BI interface looks like. As you can see, there is a visually interactive sales report with different charts and graphs. Moving on to the features of Power BI. It has an easy drag and drop functionality with features that make data visually appealing. You can create reports without having the knowledge of any programming language. Power BI helps users see not only what's happened in the past and what's happening in the present, but also what might happen in the future. It offers a wide range of detailed and attractive visualizations to create reports and dashboards. You can select several charts and graphs from the visualization pane. Power BI has machine learning capabilities with which it can spot patterns in data and use those patterns to make informed predictions and run what-if scenarios. Power BI supports multiple data sources such as Excel, Text CSV, Oracle, SQL Server PDF, and XML files. The platform integrates with other popular business management tools like SharePoint, Office 365, and Dynamics 365, as well as other non-Microsoft products like Spark, Hadoop, Google Analytics, SAP, Salesforce, and MailChimp. Some of the companies using Power BI are Adobe, AXA, Carlsberg, Capgemini, and Nestle. Moving on to the next tool. So any guesses as to what we have at number 1? You can comment in the chat section below. Finally, on the top of the pyramid, we have Tableau. Gartner's Magic Quadrant of 2020 classified Tableau as a leader in business intelligence and data analysis. Tableau Interactive Data Visualization Software Company was founded in Jan 2003 in Mountain View, California. Tableau is a data visualization software that is used for data science and business intelligence. It can create a wide range of different visualization to interactively present the data and showcase insights. The important products of Tableau are Tableau Desktop, Tableau Public, Tableau Server, Tableau Online, and Tableau Reader. This is how the interface of Tableau Desktop looks like. Now coming to the features of Tableau. Data analysis is very fast with Tableau, and the visualizations created are in the form of dashboards and worksheets. Tableau delivers interactive dashboards that support insights on the fly. It can translate queries to visualizations and import all ranges and sizes of data. Writing simple SQL queries can help join multiple datasets and then build reports out of it. You can create transparent filters, parameters, and highlighters. Tableau allows you to ask questions, spot trends, and identify opportunities. With the help of Tableau Online, you can connect with cloud databases, Amazon Redshift, and Google BigQuery. The companies using Tableau are Deloitte, Adobe, Cisco, LinkedIn, and the American e-commerce giant Amazon, to name a few. And there you go, those are the top 10 data analysis tools. Let's now have a question and answer session. Please feel free to post your queries in the comments section and we'll respond in the chat. Before the question and answer session, let's recap quickly. In the meanwhile, y'all can post your questions in the comment section below. So at number 10, we have Microsoft Excel. Then at number 9, we have RapidMiner. At number 8, we have Talent. At number 7, we have Nime. At number 6, we have SAS. R and Python at number 5, Apache Spark at number 4, ClickView at number 3, Power BI at number 2, and finally we have Tableau topping the list at number 1.
Hi everyone, welcome to this tutorial on Microsoft Excel. So we will learn about functions and formulas, we will learn about conditional formatting, data validation, pivot chart, and pivot table. Now, let's look at a scenario here. So one day in a startup, one professional speaks that their business is growing and they would need an efficient way to work with the data. They would have to find a way to work faster with storing and analyzing data. Now, to that, another colleague responds, well, we can make use of Microsoft Excel to do this job. The question is, will Excel be able to cater to their business needs? Now, the colleague responds, well, we can make use of Excel in several ways, and it also is a cost-efficient option. Now, in that case, the colleague who posed the question says, let's go ahead with Excel and let's train our employees in Excel. And the suggestion is welcomed, which would make the job easier for them. And they would basically decide on using Excel. So they decide on taking a training right away and basically starting to learn Excel. Now, before we move to Excel, one of the questions is, why should we use Excel? So let's look at some of the points here. So Excel proves to be a great platform to perform various mathematical calculation on large data sets, which is one of the biggest requirements of various organizations these days. Various features in Excel like searching, sorting, filtering makes it easier for you to play with the data. And Excel also allows you to beautify your data and present it in the form of charts, tables, and data bars. Now, when it comes to reporting, accounting, and analysis can be performed with the help of Excel. It can help you with your task lists, your calendars, and goal planning worksheets. Excel also provides good security for your data. Excel files have the feature of password protection. This way, your information can be safe. Now, when we talk about what is Excel and how it can be used, So Excel, or you might have heard as spreadsheet, can be basically used for lot of different tasks than just storing the information in so-called tabular format. Now, Microsoft Excel is an application that is used for recording, analyzing, and visualizing data. It is in the form of a spreadsheet. Let's have a look at few of the functions and formulas used in Excel. And before we do that, we can also quickly take a small tour to understand how to work with Excel. Now, to do that, what we can do is we can type in our search, say for example Excel, and just select your Excel app which is installed. And here you see you have a lot of options which says take a tour, drop down list, get started with formulas, make your pivot table, going forward with pie charts, and much more. So we can click on this one which says take a tour, and that basically pops up a window which says welcome to Excel. And if you have always wanted to be better at Excel, you have this which can help you. So let's click on create, and that takes us to the store window. Now that says instructions for screen readers, which basically talks about 10 different steps in which we can learn Excel and using the spreadsheet app. So there are more than 11 sheets which we see here at the bottom end, and each one gives us a simple example which we can work on. So for example, if I click on add, now that takes me to this page which says how do we add numbers. Now you might be provided data which we can upload by loading a file from our machine, or getting data from a web source, or even connecting to a database. So there are various options which we will see in some time. So here we have an option which is called data. You can click on this one, and this basically has options where you can use existing connections. If you have created some, you can always click on from other sources, and you can get your data from SQL Server, from analysis services, from OData data feed. You can get in from XML, from data connection wizard, or also from Microsoft Query. You can be running in different queries here, which shows up in the option which says new query. There are connections which you can use, and that basically will display all the connections for this particular workbook, which we do not have as of now, but we can create them. But let's look at simple examples. Now you can follow these instructions here, which says basically adding up the numbers, and that could be easily done by just placing your cursor here. And what you could do is either you can type in the formula, that is from which row to which row you would want to add the data. So for example, I could just do a sum here, and that shows up all the different functions which are available. Then we can open up a parenthesis, and we can say I would be interested in totaling the amount from column D, and I would select, for example, D4. So I could be doing this, and then I could say D4 onwards till D7. So that's the data which I'm interested in. You can close your parenthesis and hit enter, and that gives you the total. There is also a shortcut for this, which you can always do, is we can first delete this, and you can just place your cursor here and just use your alt and equals. That automatically selects the numericals, which we can anytime expand or basically collapse. So I will basically select this, which says this function needs two numbers, which is number 1 and number 2, and then you can hit on enter, and that gives you the total. So similarly, we can be getting in the data here by selecting all the fields. So here it also says that you can use a shortcut. Now what we can also do is we can add numbers over 50 by selecting the yellow cell here, and then giving a condition such as, so I can basically use something like sum if, and then open a parenthesis. I can select I would be interested in this row, and then I can even drag and drop till here, so that tells me D11 to D15. You can then put in a comma here, and you can give your condition. Say for example, we would say I would be interested in numbers only above 50, and we can select this, close your quotes, and then just close your parenthesis, and that's your formula. So you can do this, and that basically gives me the total is 100. Now similarly, we could do that for the amount here. I could select this. Now there is also an option, I can click on home and I can go for something like auto sum. So that's one more way of doing it, which anyway says sum is alt plus equals. So it automatically adds up your values, and I can try doing a auto sum that automatically selects my rows, and then I can get my total. Now, as per this activity here, it says try adding another sum if formula here, but add amounts that are less than 100, and the result should be 160. So what we can do is we can basically select all the numbers which are lesser than 100. So the way we did earlier here, there can be always a shortcut. So you can always, for example, if you would want to avoid typing in the formula, you can always copy it from here and then just hit on enter. So you are back into this cell, and then I can basically go here and paste the number, and then as per the requirement, we are required to select anything which is lesser than 100. So what I could do is I could select here, I could say, let's say G, and then I can change this value to G15, and that's one more way. Now we see our selected rows have been changed, so I can hit on enter and I can check what is the result. So we would be interested in looking for numbers which are lesser than 100, so I will have to also change this one to a lesser sign, and that basically gives me the total, which is 160. So that's how you can simply add numbers. You can use auto sum, you can type in the formula, you can select the fields, or you can just place your cursor where you would be looking for a sum, and then you can just do a alt equals, and that basically populates the sum. Now let's look at some easy options of filling your cells or automatically populating the values in your cells within your Excel sheet. Now here we have an option which says 100. Now we can click on this, and that basically says it is making a sum of column C4 to D4. So if I click on this one, I can check that this is row number 4, which shows up here, and I also know this is column C. I also have D, so this equals is basically giving me a sum of C4 to D4. Now what we can do is we can always place our cursor here at the right corner, and then we can just drag and drop, and this basically gives me a total of all the numbers for all different rows. So this is one shortcut which we can do to get the total. Excel will automatically give the totals, which we call as filling down. Now what we can do is, in the same way, if we would want to get the totals here, we can first check what is this 200, and this tells me it is C11 to C14 total. So it is totaling the rows from C11, so column C and 11th row, till 14th row, and that's the sum. Now what I can also do is I can similarly, like above, we can do a filling right, which basically means bringing your cursor here and then just dragging and dropping it all the way where you would need the totals, and this basically gives me the total. There is one more quick way to check if this is right. So the easiest option would be to select this cell. Now what I can also do is I can just select all of these fields by just highlighting and selecting all the fields. Once it is selected, press on Control R, and that gives you the total. Now if we would be doing this top down, then I could select all these rows for this particular column, and then I could do a Control D. So that's your filling down, and this one was filling right. So this is an easier option of doing a fill when you would want to have the formula applied to every row as it occurs in the first row or the last row. We could test this by, for example, selecting these fields. I could delete them, and I have here which says 130. I could just place my cursor here and I could drag it all the way up, and that should also do the same magic which we were seeing from top down. So this is a simple way wherein you can fill up your cells, and you can also automatically propagate or move your computation to all the cells. Let's look at the split option, which basically helps us in splitting the data when we have some kind of pattern or when we have some kind of delimiters in our data in, say, one particular column, and we would want to derive the values out of it. So we can always use the splitting option. Now the easiest option would be, so for example, we have our email column which has the email IDs, and which we can clearly see has a first name dot last name. Now I see that there is a last name Smith filled up here, first name is empty. So what I can also do is I can just type in, say, Nancy here. Now that's the first name. I can again start typing the second name, and as soon as you do that, you would see a faded list of numbers, and that's your clue to hit enter. And once you do that, you would see all the first names have been filled in here. If you would want to maintain the case sensitiveness, you can just go ahead and delete these, and let's type in as it occurs. So let's say Nancy as the first name, go down to the next cell and just type in Andy, and there is your grade list. So just hit on enter, and that basically fills up your first name. What we can also do is we can just select this particular field, and either we can type in Control E, which basically fills up all the options. Now I can just do a undo by typing in or clicking Control Z, and that's basically gone. What I can also do is I can select a particular field, and then I can go into home option, and under home you have an option here which says fill. So you can select this, and then you can do a flash fill, which is what we are doing here. So click on flash fill, and that automatically fills up the values. So in this way you can work within your spreadsheet, and you can be filling up the values where a delimiter by default is understood, and we can split the data. Now however, sometimes you might have some data which has a different kind of delimiter, and there is again a smarter way of splitting your data. So you can always scroll down here, and that says splitting a column based on delimiters. So we have some values in the data column, and these values in each row are separated by comma. So select this. Your data is already selected. Text to columns, delimited, comma is selected, and now click on next. So it basically says what is the destination. Let's select this one, and I can choose what would you want to have. So that shows me this would be my data preview. Now I can basically select this one. I can say finish and say okay. And now if you see, our data has been placed in the columns appropriately. So this is how you can split your data based on a delimiter and then organize your data in a better way. Now there are some advanced options which we can learn later, but this basically tells about using a formula. So this is something, if we have some name in one cell, and if you would want to split it into first name, your helper column, your middle name, last name, so that can also be done using formulas. And this basically tells how would you extract characters from your left cell and how would you place them in your right cell. So you can try this activity, which is a little more of advanced option. The benefit is that you can always use this, wherein if you do some kind of transformation using your formulas, if your original data gets updated, then the split data will also get updated. And that's the benefit of using formulas, where you can place values from one cell into multiple cells based on execution of your details in the formulas. How about using the transpose option? Now, you might have heard of situations where you would want to switch or turn your rows into columns and your columns into rows, and that's where transposing comes into picture. It might be useful when you have your data in your x and y axis, or as I would say, in rows and columns, and you would want to switch your rows to become the columns and columns to become your rows. So what we can do is, the simplest way is, you can select all your values. So here we basically have 6 columns and I would say 2 rows. Now I can select all of these and then I can select an empty field. For example, the one which is highlighted here. Well, you can always do a Control Alt V. That's a shortcut. What you can also do is, once you have selected all your fields, you can just copy them. So just do a Control C and then click on an empty cell, and then what you can do is you can do a special paste or paste special. So under your home you have the paste option, and here you can go for paste special. And once you do that, you need to select the transpose option over here and click on OK. And now you will see that the columns and the rows have been transposed. So your row name was item and that has become the column heading. You had row name as amount and that has become the column heading, and all your values have been transposed in this particular format. Now there is another way of doing that, and again that's using your formulas. So what you can do is you can transpose with a formula also, and that basically works when you have similar kind of data. So this has 6 columns and basically 2 rows. So you can basically do this. So you can select this, and earlier we were doing a copy, but now what we would want to do is we would want to just look at the row numbers, which tells me it is C33, C34, and it starts with C and ends in with your H column. So what we can do is, we know that we have 6 columns and 2 rows. So transposing that would actually give me 2 columns and 6 rows. So what we can do is we can select 2 columns and 6 rows in our Excel sheet. I can then basically start typing in the message, or I can just go to the address bar, and here I can say transpose. Let's go for C33, H34. It basically selects my data, and now I can just do a Control Shift and enter, and now if you see, all the values have been populated. Now you can just place your cursor in one of the cells, but if you see the address bar, the formula remains the same. This is because this is an array formula. So we can read more about an array formula here. It's basically something which performs calculations on more than one cell in an array. And in the example here, the array is the original data, that is C33 to H34. So your transpose is just changing the horizontal orientation to the vertical orientation. So this is a very simple way in which you can basically use the Excel's capability to transpose your data and convert your rows into columns and columns into rows. Apart from working on additions, subtractions, filling up your data, sorting the data, or basically splitting your data, transposing your data, one of the other requirements is sorting and filtering your data. Now that can be very handy when you're working on huge data and you would want to sort it in a particular order, say ascending or descending, or might be based on a particular field, or if that field was, or if the cell was highlighted with a particular color, sorting the data. So let's look at how Excel can be used for sorting and filtering. Examples are pretty simple here. So let's check that. So if we go into sort and filter and say this is the data I have, say for example, I would want to sort the values in the department column alphabetically. So what I can do is I can select department column, and I'm already in the home tab. I can straight away go here which says sort and filter. I can then say sort A to Z, and that's basically alphabetically sorting your department column. And once I do this, you would see the data has been sorted. But it's not just this data. We can just do a Control Z and check what are the values we have. So here we have meat, which is beef, and 90,000, 110,000, the values. Then you have bakery, which should ideally be the first row if we sort it in an alphabetical order, which goes with bakery as desserts. You have the values, so we can check this again. So select department and then just do a sort and filter, and let's say sort A to Z. And if you see, the data has changed, but it's not just changing your first column, but then it has taken care of all the data. However, the data has been sorted based on the department column. So you have bakery, which aligns with desserts, which has the values, and now we have all the data which has been filtered. Now what we can also do is we can sort December's amounts from largest to smallest. So what we can do is we can basically click any cell in the December column, let's say 20,000, and then what I can do is I can go into sort filter, and then I can say sort largest to smallest. So if you see, bakery breads is the row which has the smallest data, or might be you have deli sandwiches, so that one looks also smaller. So let's do a larger to smallest, and if I do this, you would see the values have been shifted now. So it is no more based on the department column, because now the data is being sorted based on the values in the December column. And you see bakery, which was alphabetically the first one, has become second last. So either you can sort the data based on a department column, which goes based on the values. These are all string values or words, so it sorts alphabetically. If you have numbers, might be you can give some values and you can sort the data. You could anytime do a custom sort, and you could basically select if you would want to select the data. So I could do a custom sort, and then I could choose which is the column which we would want to use for sorting. What is the sorting needs to be done? Is it cell values? Is it cell color, font color, conditional formatting? And then you can also choose the order. So that's one more way to do that. Now, if you scroll down, that also shows how you can sort by date or a color. So for example, if you would want to sort based on the expense date, so there are different options. So what I can do is I can select this date field. I can just do a right click. I can go into sort, and then I can choose. I would want to sort oldest to newest. So since I selected the date field, it basically has sorted all the data, and it has taken the expense date into consideration. Now there are these filters which you see on the row headings. We could have also used those. So I could have selected this, and that basically says or mentions which are the dates I would be interested in looking at. I also have sort by color here. I can do a sort oldest to newest or newest to oldest. So I could also use these filters which have been applied here. Now we have the data which is in color. So if I would want to basically select the color columns or color cells, I could select this. I can basically do a right click here, and when I go into sort, I could choose put selected color or cell color on the top, and that basically will make sure that my data is sorted, and it has also sorted that in a descending order. So in this way you can sort or basically filter your data. What we can also do is we can add filters. So sometimes we can go for formulas which we would want to use. What we can also do is we can basically select the filter which has been applied here. Now how does the filter come in there? So if I would select a particular row, I could select a particular row, and then I could decide if I would want to just add a filter to this one. And that's how the filter has come in. So we have the filter. What we can do is we can basically click on this drop down, and then you have something like number filters. So we can always go here. We can basically choose one of these. So we can basically choose above average. So I could select this, and then basically it shows me the values. We could also delete the filter by clicking on this one, and we could say, well, I'm not interested in this filter anymore. So I could clear the filter, and that shows me all the values. Or I could say that let's click on some other field, for example, food. I can go in here, I can go into number filters, and then I could say, well, I'm interested in values which are below average, above average, might be greater than, and then I can choose what is the value. So for example, if we say I'm interested in food which is greater than $25, I could give a value here. I could say okay, and now I have applied the filter. Similarly, you can select this, and then you can just clear your filter and your data is back. So remember, no data is lost. It is just hidden, or basically based on the filter not shown. So that's good enough for us. And in this way, you can sort and filter the data. So for more details, obviously in all these sheets, you have the links which point to more information on the web, and you can always refer to these. So this is simple way in which you can sort and filter any amount of data which has been stored within your Excel within a particular sheet. Now that we have learned about add, fill, split, transpose, sorting, and filtering, it will also be good to learn how to work with tables, or basically converting your data into a tabular format and then doing some easy computations. So click on this tables option here. Now here we see there is some data which is in 5 columns and n number of rows. So I can basically select this data, and then what I can do is I can insert, choose the table option, and then it says my table has headers, and we'll be okay with that. I'll say okay, and now if you see, this is the table created. It basically has different filters which we have learned earlier how to use, and this is basically my table, which is a collection of cells which has some special features. So we can easily add rows to this table, we can add columns to this table, and we can even do some calculations. So for example, here I can click on this one. I can basically enter some field, and then I can hit on enter, and we see that this row has been inserted, wherein we can easily fill in values. For example, I would say chocolates. I could give some value here, say 25,000, might be 35,000, and then basically I can give in some values here. Now what you can also do is you can continue adding rows in this way, and say for example you would want more columns, so you can select this option here in the top bottom right corner. You can just drag it towards the right, and that basically has automatically created columns for my next months, wherein I can feed in the data. So this is a simpler way wherein you can keep adding more rows and columns to your data if that has been converted in a tabular format. Now let me just do a Control Z, that basically deletes the columns. Again, Control Z deletes the last row which we added, and I can stop here, or I can even remove my values by doing multiple Control Z and removing my rows. So this is how I converted my data into a table, and then I can easily work on this. What I can also do is I can do some calculations. So what we can do, we have a table here, we have a total field, and what we can do is we can just select one cell here. Now as we have learned earlier, we can do a alt and then equals, and that basically says what is this doing. So it says it is calculating the sum of the last 3 months, and if that's what you would want to do, just hit on enter, and it has automatically calculated the totals for all your rows for these 3 columns. So the sum formula is getting filled up. Now I can select any particular cell and I can look in my address bar. So it has already given me the formula where it has started calculating the sum from the October column till the December column and has given me the calculated values of the columns. What we can also do is we can get total rows in the table. Now that's a simpler option. So what we can do is we can select any cell in this particular table, and then we see that there is a table tools design option showing up here. Now I can select this, and then it says, well, let's get a total row. So let's select this, and it automatically populates the total here. And if you would want the average, then we could select this, and from the drop down I can select what I'm interested in. So for example, I would want the average values and not the total. I could just select this, and that gives me the average of these values. So we can always do simpler computations here by converting our data into table format. Let's learn about one more efficient way of working with the data, and that's using your drop downs. So let's see how drop downs work here. Now, say for example, you have this data which has the values in the food column and department is empty. And say for example, you would want to enter the values in department. However, you would want to select the department should either have produce or meat and bakery, and these are the only 3 options which should be available for any user to fill in the values. How do we do that? So we can basically create a table by pressing Control D. So what I can do is under my department here, I can select one of the cells, and then I can do a Control T that basically converts this into a table. I can say OK, and my table is created. Now what I can do is once this part is done, we can select all the blank fields here where we would want this drop down to be applicable. Now under your data tab, you can go in and select data validation, and this has an option called data validation. Click on this, which basically says allow any value. So here I will select I would want to give a list of values, and then I can type in my values here, which I can say produce, say for example meat, and then say bakery. Now these are the values, so we can click on OK. And once we have done that, we basically have a drop down here next to apples, which will only show us the values which we can feed in under the department column. So I can go into every cell, and then I can basically choose what is the department which handles this, and then basically I can select one of these from the drop down. So this is an easier option of creating your drop down and then feeding in the values from the set of values which you have defined here on the right. So this is a simple example of using your drop downs, working with your tables, working with your sort and filter, transpose, split, filling up your data, adding in some data here. And similarly, you can use Excel for more than one use case using its inbuilt features to easily work with your data. Let's see how we can import data or bring in data into our Excel from your local machine or from an external web source. So what we can do is we can open up a blank Excel sheet and say, for example, you have been provided a text file or a CSV file and you would want to import that data into your Excel sheet. That can be easily done. So right now I've opened an Excel sheet. Now I can click on data, and here I have an option which says existing connections from other data sources. So, or you can click on connections if you have already created some. So we can click on from other sources. So this is one option where you can connect to your different data sources and you can get the data from one of these. What we can also do is I can click on connections. Now it says there is none. I can click on add. It says, well, show the connections where connection files on network, connection files on this computer. So I can say, let's get some files from this computer. Now, if that does not show up something, so say browse for more, and that basically shows you different options. So let's basically select a folder where I have some data sets. I'll click in here, and this is basically a folder where I have some data sets. Now let me select this particular file, and I know it is a CSV file. So let's click on open. Now if you would want to verify this, you could have gone and looked into the properties of the file, and it says it is a .csv file, which is what we are interested in. So I'll take this file, I'll say open. Now this basically shows me the text import wizard option, which says, is the file delimited? I'll say yes, click on next. So I will select comma as my delimiter. I can say text qualifier is none. Now this is my data. So my data preview is already showing me the data is what is the data in the CSV file. You can click on next, and then you have an option which says data format is general. You can go for date format, you can go for advanced options. So I'll just say finish, and basically now this has been created here. So we basically have this, and now I can click on close. Now once you have done that, you can click on existing connections. It shows me the data which we have here, the connection which we have created, say open, and then it says, do you want to import this data or bring this data into existing worksheet? You can also say add this to a data model if you're doing some data modeling. So click on OK. And now this data is automatically inserted in my Excel file. I can basically save it into this particular sheet. Now what we can also do is we can also start a new sheet, and that does not have a data, and we can get some other data from web. So what I can do is I can go into my GitHub, and let's say I would be interested in this CSV file. So I can select this, and this is my GitHub path, a path on web. So I can click on raw, and that basically gives me the raw path where this particular file is. Now you can select this, copy this particular path, and here you can come back to your Excel sheet. We would be interested in getting the data from web, might be from a text file where we will have to specify the delimiters, or let's go to web, and here I can give in the web path from where I would be interested in getting the file. Let's give the GitHub path, which is publicly available, and then click on import. Now once you click on import, it tells me there are two fields, data and value. These are within double quotes, separated by comma. So first let's click on import. Now once we do this, it will basically get the data from web and put in here. It says existing worksheet, so we had already created a new worksheet. So let's click on OK, and now you have the data coming in, but then this basically shows me in one particular field. So what we can also do is we can just do a Control A, that selects all my columns here, and that's my data. So we can then basically filter this out. So we can say text to columns. It's a delimited file. Click on next. We can select comma and let the text qualifier be quotes. It shows me data preview. Click on next. So you have the general format. It shows the destination, that's the column. Click on finish, and now your data has been split, and you have the data which you have imported from web. So this is the data which is coming in from web. This is the data which came in from my local machine. And similarly, we can even create connection with an existing database. So I can basically click on connections if I would want to do that. So I have an option called connection here, and it says where the selected connections are used. I can basically click on add. I can basically choose if I would want to get the files from network or from computer like we did earlier. I can click on browse for more, which should show me different other options to create connections. Say you would want to create a new SQL server connection. You can connect to a new data source coming in from different place. You could basically choose what kind of connection would you want. So these are all the different options which we can go for. And we can basically connect to a database. For example, if I have some database and say for example access database, I can see if there are some files with that particular database and I can import it. So similarly, we can also click in here which says new query, and that also gives you an option of getting the data from your files, from all these folders, from databases. So you can basically click here and then you can import data from a MySQL database, provided that is set up on your local machine or on a particular server. You can go from cloud, you can get it from online services, you can get it from other sources which says from web, from your Hadoop file system, from Active Directory, from a blank query, and you can even combine queries wherein you can run a Power Query editor. You can get the data from different sources and then you can bring it into your Excel. So in this way, you can get your data from different sources into your Excel, into your spreadsheet, and then you can continue working on those data sets. We have already learned some basic operations which you can do in Excel, and let's implement our knowledge by working on this particular data which is coming in from housing data set. Now here, if we see some fields, we have agent, date listed, area, list price, and this is basically the data which has been sorted in newest to oldest order of date listed. So how do we arrive at this? So what I can do is I can just click on data listed, and then I can either go in here, I can select sort, I can get into custom sort, and then I can choose the column based on which I would want to sort the data. So I would look for the newest data to the oldest data. That means that would be in a descending order of dates, or you could say the oldest date or the earliest month will be towards the lower side of your sheet. So here we can select date listed. Now I can say let it sort based on cell values and the order what we have here. So we have newest to oldest. So let's select this. I can say okay, and now if you see, the date has been sorted. So we have your 10/18/2007 on the top, so that seems to be the latest date. And as we go down, we will see an earlier month or an earlier month than that in this date listed. So we have sorted our data into newest to oldest order, and that's based on your date column. So the result shows up here. Now what we can also do is we can have different questions which we would want to answer. So for example, I would want to sort the data in ascending order of area and descending order of agent name. How do we do that? So let's look into this. So this is here. I already have the result here. And how did I get this? So I'm looking for ascending order of area and descending order of agent name. So we can start with any particular column, that does not matter. So for example, if I look into this Excel sheet, I have my agent name, select this, which we want in a descending order. So we could either do a sort and then go for descending sort Z to A. We could also use the filter option here on the top right and we could do it, or I could just say sort Z to A, and then it has arranged the data based on the agent column being in descending order. Now I can go into area, and then I can again do a sort, and I wanted my area column to be used for sorting the data in ascending to descending. And that basically not only changes the order of this particular column, but for my complete data. So let's do that. And now if you see, we have the data which has been sorted. So we can see how many values we have here and the area values which we see, and this is how you get your result. So I'll just do a Control Z and again, and I'm back to my original data, and this is the sorted result which we are seeing at. Similarly, we can answer other questions. For example, sort the data according to the following order of area. That is, we are saying county, central, and then your county. So we can basically choose in which particular way we would want to do it. So it is county, central, and then again county. So if I look into my sheet 3, so here I basically have my data which is having some South County, then you have your central, and then you have your North County. So we would want to sort the data to solve our problem, which is according to the following order. So first we go for area, then we go for South County, Central, and North County. So what we can do is we can basically have area field selected, and I would want to sort this particular data. So I have South County, Central, and North County. So I can basically go for custom sort, and then I can choose which is the value or column which I'm interested in. Let's go for area. We will go for something like cell values. Well, you can also try to explore conditional formatting icon if this is what you would want to use, or we can basically go for just cell values. And here we can say if I would be interested in first getting my values for South County. So for example, I can say custom list, and then I can basically give in the new list here. So I can say S dot county, and then I would want central, and then I would want North County. So let's select this as it exists. We can basically say add, and that's basically the order which we want. Say okay, and then say okay here. And now what we would want is we would want our data, so we can compare that with the values which we see here. It starts with Kelly. You have in the 12th row something like Lang, and that's what we are doing. So we can basically arrange the data in a particular order by choosing a custom list and then sorting your data. So that's one more simpler task what we have done, where we have sorted the data in the order where under our area column, we first wanted South County, then we wanted central data, and then we wanted North County. So this is how you can do it. Now, let's look into one more problem. So it says find all the houses in the central area, and we would want to basically apply a regular filter. Let's see how do we do that. So we can click on this, and here we have the data. So the problem statement is we would want to find all the houses in central area. Now how do we do that? We can do a sorting, but we would want to use the filter which you see here is implemented. So how do you do it? So you can select this area, and say for example I would want to apply filter. I can just go in here and I can say let's get a filter on my first row, and now I have filters applied. So we are interested in looking into the central area houses. Let's go in here. It says all these fields are selected. That means it shows everything wherein your area has all these values. Let's unselect this, and then I will only be interested in the central. So let's say okay, and then say okay. So now you see the area filter has been applied, and we are looking at the central column. So what we have done is we have applied a simple filter and we are looking at our data. At any point of time, if you do not want the filter, then what I can do is I can select this and I can say, well, I'm interested in all the data. So I could do this, or you can clear the filters from area and you get your data back. So that's in one way you can filter out your data. So let's look at an example of sort and filter where we might have to filter the data based on two columns or multiple columns with different kind of values, where it could be and an or condition. Now say for example, this is the data I have and this is the question which we need to answer, such as find the list of all houses in the central region with pool and South County without pool. Now, if it was a simple filter based on one cell, I could have just selected my header row. I could have then applied the filter, and once I have the filter, I can look in area where I have three regions. So I'm only interested in Central and South County. So I can get rid of North County, and that's fine. But then we have two different conditions here. So we need the data in Central region to have the value for pool being true, and for South County the value has to be without pool. Now how do we do that? So what we can do is we can first create a copy of these headers here. So let me do that. Now the area has to be South County. So basically I can either just select this and I can choose this value, and then I can select this and then I can choose central. So that's the criteria which I have, and the pool value has to be, so central region should be with pool. So then this one basically has to be true, and this one has to be basically false. So South County is without pool. So let's select one of the values here, and this is my criteria. Now to get my result, we can always place your cursor here and you can check this is M column and 8th row. Okay, so we would want the result here. So let's go ahead and now click on data, and then in filter you have an option called advanced, and here what I can do is I can say I would want to filter the list in the place, but that's not what I would want to do. So I'll say copy to another location, and here if you see the list range will tell me that this is the data. So A1 to J126, so A to J column selected and all the rows. Criteria range is basically based on what I've given here. So that is M from 1 to V, which is 3. So I'm selecting these columns and then I'm saying all the way whatever criteria I've given, and copy to, I'm saying M8 to V8. So that basically will give me my filtered result. So you could basically just say okay, and now I have my data which has been filtered, and I have my area which is South County, that is without pool, Central with pool, again South County without pool, and then if you look at your central value, that's pool. So this is an advanced filter which we have applied, where simply we have filtered the data based on two columns and then we have our result. So in this way you can have your customized filter applied on two different columns and get your data, which can be either replacing the existing content, or in the same sheet in different set of columns and rows you can have your result. Let's look at one more example of filtering where you are trying to filter the data based on an AND condition being met in two different columns, and then you would want to filter out the data for only specific columns. So the situation is the agents with a house in North County, that should be county, area having two and a single type family. So we are talking about 2 bedrooms, and we would basically have a single type family, and here the criteria is that we would want to only populate these columns, which is agent, area, bedroom, and type. Now what you can do is, as I explained earlier, that you can get your result in the same sheet in a different location. So here I have created these headers which says agent, area, bedrooms, and type. Now this is basically a copy of all the columns what we have here: agent, data listed, area, list price, bedrooms, bath, square feet, and so on. So you can basically create a copy of the headers here, and this is where we will give our advanced criteria to filter the data. So the conditions which need to be met is we need to look at North County. So for example, here in area, I can basically go ahead and select one of the values, North County. Now the criteria is having 2 bedrooms only. So let's say bedrooms, and let's say the value should be 2. And then basically I am saying a single type family. So when you would want the single type family, so here under type, I can give the criteria single type. So this is my AND condition. So we are saying North County area having 2 bedrooms and the type is single family. Now this is the criteria, which basically means if I select this one tells me that this is M1 row onwards till V2. So this is what we have, and we would want to filter based on this. So let's go ahead and then go for data filter advanced. And here in advanced, it says filter the list in place. Now that's not what we would want to do. So I'll say copy to another location. This basically selects the list range. So which is telling me A1 to J126. So that's the columns and rows selected. Criteria range is based on M1 V2, which we have given here, and copy to, I would say, for example, from M7 to P7. Now this is the area where this is the place where I want the result. Let's say OK. And now I get my data, which is based on the question which has been asked, that you would want the agents with a house in North County area having 2 bedrooms and single type family. So in this way, you can basically do advanced filtering, get your data and get it stored in the sheet anywhere at a different location. Well, I could have also done filtering in place, and that would have replaced the data which we have, but that's not what we want. We would want the filtered result in a different place. So this is how you can do some advanced filtering. We can also use Excel to filter out the data in one particular column, which might be conditional or say using some numerical filters. Now here, say for example, the problem statement is that you would want to display all the houses whose list price is between 45,000 to 600,000. Or say for example, we would want to filter out the data to something else. Say for example, let's say I would want to filter out the data between 300,000 and 400,000. So we can basically update this. Say for example, I'm saying I'm interested in 300,000 to 400,000, and that's the criteria to filter out the data. Now there are two different ways, or there are two easier ways to do it. One is I would want to look at the list price. So I can select this, I can go ahead and do a filter here, and in the list price, now this is where we would want to do the filtering. So it's pretty easy. You can click on this one and then you can go into number filters and you can choose between. Now that's one easier way of doing it. So I could basically select this. I could say I'm looking for value which is greater than or equal to 300,000 and then is less than or equal to 400,000. So if I just do this, I have applied my filter and I have my data which is filtered based on my criteria, right? So that's one easier way of doing it. or let me do a control Z. Now let the filter be there, which you can anyways use. But what we can also do is, as we have seen earlier methods, so get a set or get your column headers here, and then you are giving two columns here. Now the only difference between my this set of columns, which I have 1 2 3 4, and then you have 7 and 10 columns, and if you see here we have 4 5 6 7 8 9 10 11, right? So whenever you want a AND condition, you will basically add the columns where I can give add condition if it is the same column. If it was a different column, then it would be same number of columns, but AND conditions will lie in the same line and OR condition would lie in a different line. Now here I can give this value, so I am looking for listed price being between 300,000, so I am saying it should be greater than or equal to 300,000, and then I can say less than or equal to 400,000. Now that's my criteria, and then I need my result here, which is in M7. So what I can do is, once I've given my criteria, which I'll be using to filter, I can get into data, I can get into advanced, and then I can say copy to another location. So it is selecting my A1 to J126. Criteria range is based on M1 to W2, and then I would want my result from this particular column. So let's say OK, and now you have your data filtered out in a different location in the sheet, which has been filtered based on your AND condition. So you can filter out the data in this way, or you could just apply a filter on a column and give the conditions. Now let's solve one more interesting problem, and here we would want to use Excel, where we would have an AND and OR condition. So say for example, this is the data given to you, and the question is that you would want to find all the houses in North County. Again, that's a spelling mistake, but then they are North County area with a list price greater than 300,000 and having 3 or 4 bedrooms. So the bedroom has conditional, so it has or 3 and 4, and then basically you have list price which is greater than 300,000. Now I could have obviously selected the columns and then basically gone for a filter. So I can just do a filtering here, and then I'm looking for list price being greater than 300,000, so which we can always give a number filter, and I can say greater than, and then I can say greater than or equal. So I can say greater than, and then I can give 3,000, 30, 300,000, and that's basically the filter which we would want. And here I would want to select the bedrooms, which should be just either 3 or 4. So if for example here I go in here and I unselect this and then I say 3 and 4, right? So I am getting my data which is greater than 300,000, and it should have the bedroom values which will be either 3 or 4 selected. Now that's one way of doing it. Let's do a control Z and get it back to as we were, or you can even just say clear filter, so you get your data back as it was. So what we can do is we can here give the criteria. So for example, I have my list price. Now this is what I would want as a condition. So let's say greater than 300,000, and bedrooms should be 3, and then I can say greater than 300,000, and then I can say 4. So this one basically gives me a situation where your list price has to be greater than 300,000 and bedroom should be either 3 or 4. So we have given our filtering criteria. Now to get the result, what we can do is we can go into data, we can go into advanced, and we can say copy to another location. So our list range is selected, which is columns A to J, row number 1 to 126. Your criteria range is given in M1 to V3, where we have specified, and we are saying the result would be in M7 to V7. So if I do this, now I have got the same data which we were seeing earlier, and here the bedroom values are 3 or 4, and basically the list price is greater than 300,000. So this is a simpler way in which you can create your filters. And all this advanced filtering, what we are seeing, it will be saved with your sheet. You can always go back and change this value, or you could do filtering where one person has to look into the filter to see what values have been selected. Now that we have looked into some operations which we can perform in Excel using filter or sorting the data, creating your tables, let's also quickly look at functions and formulas which can be used for doing some easy calculations or computations. Now, Excel can be used in different kind of data analysis. So for example, you have different inbuilt functions which can be used, and we can always check for a particular function. So for example, if I wanted to look at a particular function, I could just type in here something, for example is, and then it shows me all the possible functions, and you can always have a look at the detail of the function. For example, you have is even, which will return true if the number is even. If we would say is logical, so I could search for is logical, and that tells me whether a value is logical value, true or false, and returns your value true and false. Now we can obviously say subtotal, so you can search for any of these useful functions, and that tells me what this function can be used for. So returns a subtotal in a list or a database. You have many other such functions such as integer, sum, average. You may be interested in working on truncating some data, getting the absolute value, getting the square root, basically getting a count or getting a max value. You can look for any particular functions within your Excel sheet. Now you also have other functions such as now or time. For example, let's look at now function. So I can search for now, and here it is. So this is returns the current date and time formatted as a date and time. So this is the function which we would want to use, and if I just give the function, it tells me what is the current time. Let's first look at the description of time here. So say for example, I would want time. It says converts hours, minutes and seconds given as numbers to an Excel serial number formatted with a time format. So for example, if I would say 2 hours and then 30 minutes and 30 seconds, and if I do this, it has basically converted this into your time format. So you can always use different inbuilt functions for your work. Now we will also look at some advanced functions like SUMIF or some ifs. You have COUNTIF and COUNTIFs, and you can be working on various functionalities of Excel to easily help you in doing some calculations, computations, working with your data, working with your different cell values. So let's look at some example of using functions like sum or SUMIF. So for that, let's go to this sheet, and here we have some data. Now I have already applied a filter which can allow me to filter out the data. So it says find the total units that were sold in the East region. Now we know that in region we have East, and I have multiple regions. I could basically be saying unselect all and select only East and say OK, and that basically gives me the units which were sold. And if I placed my cursor here, and then if I did a auto sum, So it would basically give me the function which is being used, so something like subtotal, and it is basically working on your rows, which is E2 to E44. And here we can just do this, so that gives me the total. But this is fine, you could do that, but it would be good if we know how do we use a function like SUMIF to do that. So here I'm seeing this is the subtotal where I'm looking at the values, and basically what I have done is I have filtered out the region, and then basically I'm getting a count. But this does not give me clearly how a sum was calculated from all the values which were listed. What we can also do is let's do a control Z and let's get it back. So now we have our data, and we would want to get the total units that were sold in the East region. So what I can do is I can start typing in my formula, and for that I'll use an inbuilt function. So for example, I would be interested in going for SUMIF. Now it says SUMIF adds the cells specified by a given condition or criteria. When you talk about SUMIFs, this is when you could give set of conditions or multiple criteria. So let's look at SUMIF. Let's do this. Now obviously this gives me an error because the formula is not right. So we have to basically come in here, and let's start with SUMIF. Now when I say SUMIF, it shows me there is a function with SUMIF which we would want to use. And here, once I open up the bracket, it tells me, okay, what is the range of data which you are interested in. So I'm interested in all the units that were sold in the East region. So we are interested in the region which is here. So I can basically be selecting this, and this tells me you are interested in the data here. So let's not take the header value. So let's say B2, and then we can go all the way to the end. So we can basically select this way. That's the data we have. Select this and hit enter. So now here it has selected B2 to B4, but we need to basically now give the criteria. So the criteria is either a value, or you can point it to a cell which has that particular value. So as per our problem statement, we are looking for the units which are sold in East region. So I can select the value East here, and then my SUMIF needs the range on which you want to calculate a sum. So let's select this, and now we are interested in finding out the sum of units. So that's basically this column, E column. So I can basically type in instead of selecting. So I can say E, and I'm interested in E2 to E44. So that basically selects the area or all the values. And now let's do this. So that basically gives me the sum is 691. Right now, this is the criteria where I have pointed it to a cell, and whatever value that cell has, well, I could have done something like this. So I could have selected East, giving the value, and then doing it. It still does the same thing, and in this way you have more clarity that you are using SUMIF. You are filtering the data, so you have given the rows, you are given the criteria, and then you have given the range on which you would want to sum up the values. Now similarly, if the question was what was the total revenue generated from binder, now we would want to find out what is the total revenue generated from binders. That means my filtering criteria will be binder, and then I want to find out the total revenue generated. So we have the revenue generated field also here, and we don't have any region to be filtered. We are just looking for binder. So let's again start doing the same thing. So we can go for SUMIF. We can open the bracket. Now it needs the range. So we are interested in revenue generated. Now that's the summation we want. and we would want to get the range of data. So here we can basically select D2 to D44. So that's the data selected. Now I would want to give the filtering criteria. So let's say binder, and then we need to give the range on which the sum needs to be calculated. So that's my revenue column. So that's G. So I can say G2 to G44, and that basically selects the column, and then you get your sum. So it tells me what is the total revenue generated from binder. Now I could be doing this for other things also. So say for example, if you would want to filter out something else, you could basically just drag and drop here, and then I could come here and change this to, say, instead of binder, I would be interested in, say, pencil, if that's the criteria you are interested in. Remember to change this so that you take all the values, and here we will change it to select the relevant rows, and then this is the data I'm getting. So I know that this is the revenue generated from pencil. This is the revenue generated from binder. Now this is a simple use case where we are using some if. What if we would want to use some ifs? So some ifs, let's have a look at how we get to some ifs. So some ifs is where you would want to work on doing some calculation, but then you would want multiple criterias to be met. So let's see how we get this. So here what I can do is, let's work on this problem statement which says what is the total revenue generated from central region where the item is a pencil. So that's something which I would want to check. Now when we are answering this question, we can also look at the order in which things have been asked in the question. So it says what is the total revenue generated from central region. So we need the total revenue generated. We know there is a revenue column. We are interested in getting the total revenue generated. We are saying the filtering criteria is central region, and we say in that we would be interested only in the item if it is pencil. How do I do it? So I can use some ifs where you can pass in multiple criteria. So let's start with some ifs, and when I start with some ifs, let's open up the bracket. So it says sum range, it says criteria range, then it gives one criteria, and you can give in any number of criterias. So for example, we are interested in total revenue generated. Now that's my G column. So let's follow in the same order. So let's say G2. So that's my first value. And then I know there are 44 rows here. So I can say G44. And you can obviously check if that has selected all the rows. Now that's my total revenue generated. So I would want the total revenue generated. So I'm saying setting this sum range. Then I need to give the criteria range. So it says from central region. So central region comes into column 2, that's B. So let's say B2 to B44. So that's my criteria range. Then you have to give your criteria, but we need to filter out the region being central. So let's select this. Now either I could point to a value in the cell, or I can just give the exact value here. We can also give a wildcard or matching pattern, so that also works. Now this one is fine. We are now also interested in finding the total revenue generated when the region is central and the item is pencil. How do we do that? So for item, we know the column is D2. So let's select D2 to D44. So that basically selects all the rows in the D column, and we need to give the filtering criteria. So let's do a comma and then just given our value. So let's say pencil, and then let's close your bracket, and that basically gives you the result. So we need to just follow the order of our question, which says what is the total revenue generated. So we are looking at the revenue column, we are selecting all the rows. Then it says from the central region. So we need to select the region column and give the filtering criteria as central, or point to a cell which contains that value. And then it says we would be interested only in item being pencil. So then you select the column which has all the items and provide your filtering criteria, that is pencil. So that's your easy calculation of using sum if, which we compare with sum if here. So sum if here was just having your criteria. So basically you are selecting your rows, giving your filtering criteria, and then your sum range. In sum ifs, we are giving multiple condition. Now same thing can be done here. It says how many units were sold by sales representative Jones, where the cost of each item was greater than 4. So how many units were sold by sales representative? So when we talk about how many units, that's your E column. So let's start with that. So let's say sum ifs, I would be interested in E column, and let's give the range. So it says sum range. So those are the number of units on which we would want to find the sum. Then it says you need to give the criteria range. So we say sales representative, where the name is Jones. So sales representative is in sales rep column C. So let's say C2 to C44. Now then we need to give our filtering criteria. So let's say Jones is the sales representative where we are interested, about whom we are interested in. And then the question says where the cost of each item. So cost of each item is what we are interested in. You have unit cost. So that's what we are interested in. So that would be F, and then say F2 to F44. And then you need to give your cost. So it says where each item is greater than 4. So let's select this and let's do this. So this tells me 301. Now, similarly, let's answer our third question, which says how many units did Jones sell excluding pencil item? So we would want to find out what was the total number of units that were sold, and that units or that should not include the pencil item. How do we start doing this? So let's start with sum ifs. Now we know that you start with sum ifs, you need to give the sum range. So we are interested in the number of units. So let's basically go in and select our number of units which were sold. So that's your column E. So I can say E2 to E44. That's where I would want to perform the sum. Now I'm saying how many units that were sold, where we are talking about sales rep being Jones. So let's see, let's select the columns C and then give the range. After that, we need to give our filtering criteria, which is Jones, and then we are interested in the items, but excluding pencil. So items is in column D. So let's say D to D44, and then we have to give our criteria. So we can say, well, that should exclude pencil. So I can basically say pencil, and let's close this. and let's check. So that's my formula, which says that these are the number of units which the sales representative, whose name is Jones, had sold, and that does not include pencil as an item. Let's also look at an example of using COUNTIF or COUNTIFs. Now, both of these can be very useful when you would want to calculate certain values. So for example, if I would want to work on COUNTIF, let's try solving this problem. Now, remember, you can answer these questions using filters, and that can be an easier way, but then sometimes you may want to get the formulas so that you can make your spreadsheet and your calculation more dynamic in nature, and that will basically depend on the values in the columns or rows. So for example, if I have find the total number of times Gil has made a sale. Now if I look at my data here, it tells me that for every sales representative there is some value in the sale, and it says sales has greater than 3. So for example, Jones, you have sales greater than 3, or you have Jardine, which is sales greater than 3, and so on. So what we are interested in is doing a quick count and finding out the total number of times Gil has made a sale. How do we do that? So we can use this COUNTIF function, and if I go into COUNTIF, it says counts the number of cells within a range that meet the given condition. Now what's our condition? Our condition is Gil, and we would want to find out how many times the name, say, Gil appears or Gil has made a sale. Now I could just say COUNTIF and then open up a bracket. I need to give a range. So let's say we are interested in looking at the range. So let's say we will choose sales rep. So I can say C, and then I can say C2 to C44. Now that's my range. Let's not give that in quotes. So you have to give a range. So let's do a COUNTIF that selects the data, and then we need to give the condition. So for example, let's here give the name, which is Gil, and then close this. So that basically tells me it is 5 times Gil appears here. We can check this. So I can go in here, I can add a filter, and then might be I would be interested in looking at only Gil, and that basically gives me 5, right? So we can always do that, and we can be using formulas like this. Now what about this question? So which basically says which sales representative made a sale more than 3 times. Now it might be looking little confusing when I say, for example, let me clear out this filter. Now we have sales greater than 3, and we would want to find out which sales representative made a sale more than 3 times. Now I could basically check for every sales representative here if they have made a sale more than 3 times, and what I can do is I can just say equals, I can start with COUNTIF, then I need my filtering criteria. So that's your range. So first thing is we will choose, for example, let's choose C2 to C44, and then we need to give an criteria. What is the criteria? We need basically a sales representative. So I can choose the value here in C2, and then I can close this, and then I can say the sale has to be greater than 3, and let's check. So it tells me the Boolean value that yes, this guy has made sales more than 3 times. And what we can do is we can just drag and drop, which basically gives me the value for other sales rep. You can always check the value is automatically changing to this value in cell. And for example, let's go in here. So this is obviously 2, so it says me false, right? And you can basically get the values for all your values. So that basically tells me which sales representative has made a sale more than 3 times. Now, like some ifs, we also have count ifs where you can give multiple criterias. So for example, the question is how many orders were placed from the East region after this particular date. So we have a date criteria, we also have the region criteria, and we need to basically get the count of number of orders which were placed. Now I can in this case use count ifs, and this basically says that you can start with a criteria. So it says how many orders were placed from East region after particular date. So date is in my first column. So for example, I could say A, start with 2, and say for example, let's go A44. That should have selected all the rows. And then I need to, once I've given the criteria range, I need to give the criteria. So we are saying the date has to be greater than 10th Feb. So let's give it 2/10/2019. And then you need to say how many orders were placed. So you need to give the criteria, second criteria range. So we are looking at the number of orders which were placed from the East region. So when I would want to look at the region, that's your column B. So I can basically say B2 to B44. And here I would basically give my criteria. So the criteria is East. Let's give that. And once you have done this, you would want to find out the total number of orders. So let's select this. And if I do this, it tells me 13. Now, is that right? So we are looking for your date, your region being East, and then getting the total number of orders. So here I can just do a count if I'm saying A2 to A44, wherein I have given the date criteria that it should be greater than 10th Feb, because I do not want to count 10th Feb. It says after 10th February. And then you're saying the region has to be East. So we would want to find out the total number of orders. So my region is East, and that gives me the result. Now, similarly, you can also find out how many times Gill sold pencils. So here we will have to give the range. So let's start with count ifs. Now here I would want that item is pencils, so we can as well select column D to D44. Then you have to give your criteria, so that's your pencil. And then we are looking for sales rep, which is Gill. So that is my column C. So let's say C2 to C44, and the value should be just Gill. So it tells me it's twice where Gill has sold pencils. So we can obviously check this by going in here, choosing my filter, and then let's search for rep being just Gill. Okay, and now we are interested only in the item being pencil. So I can say, well, let's get to pencil only, and that tells me twice. So you can obviously re-verify using filters, but using functions or using formulas, it is always good to calculate, and that can be making your computation and calculation more dynamic. Let's look at one more interesting feature of Excel, and that's your conditional formatting. Now, as you see on the screen, conditional formatting has different rules which can be applied on your data, and that allows you to basically differentiate or easily identify data values which are based on certain criteria or rules. So when you talk about conditional formatting, you have different options, such as you can highlight cell rules, you can get top and bottom values, you can apply different rules, apply different color scales, and you can easily manage these rules. So conditional formatting is very useful for people who would want to work on huge amount of data and easily perform some data analysis. It's easy to use as it is shown here, and with your conditional formatting you can format cells based on a preset condition. You can perform conditional formatting to identify cells. You can highlight a few significant cells, and you can easily perform conditional formatting as shown on the left side. Now, how do we work with conditional formatting? Let's have a quick look. So say for example, we have our Excel sheet, and if you see here, I am highlighting the salesperson who have generated revenue greater than 10,000. So we can be looking at the values where the revenue generated by a particular salesperson is greater than 10,000. It has a particular color. And how do we get here? So for example, let's select this data. And what I could do is I could go into conditional formatting. Now I could basically highlight cell rules, and we could just say greater than. That's an easier way. I could also go ahead and create a new rule, but then I can use one of this option. I can say greater than, and let's give some value. Might be we would be interested in looking at any value greater than 12,000. So let's choose 12,000. And here it says what color would you want to select. So for example, I would say something like yellow filled with dark yellow text, and let's say okay. So right now what I'm doing is I have all the values where the revenue generated was greater than 10,000, but then I have also selected all the sales people who have made or who have generated revenue greater than 12,000. So I can just do a control Z to see the previous result. Now here I had the values which were greater than 10,000, and the one which we did just now basically highlighted the values which are greater than 12,000. So this is one simple example. Now we can look at some other examples. Say for example, you want to format cells using 3-color scale. So if you look at the values here, I have a 3-color scale mainly in green, yellow, and red. And how do you do this? So for example, I can go in here and I can go to conditional formatting. So I would want to go for color scales, and here you can create different rules. So we can set up a 2-color scale. So we can say format only values that are above and below average. I can format only cells that contain something. I can get the top and bottom value. So these are different ways in which I can have a 3-color based scale. Now what I will do is I will select this, and let me show you the rule which I have. So for example, I can go into manage rules, and if you see here, there are certain rules which have been specified. Now what does that mean? So you would want to specify a 3-grade scale. So for example, if I would want to look at my first rule, it tells me that I'm choosing 3-color scale. I can choose lowest value, percentile, and highest value, and that basically will select the cells based on their values. So what we could have done is I can basically use one of these values. I can delete these rules which I have created. So for example, I have all these rules, but you should always carefully remember that the rules will be applied in the order shown. So for example, if I just delete these rules and then say apply and say okay, my data is back. Now it does not have any highlighting. Now I can go in here, I can say conditional formatting. I could go for color scales, or I could basically go into new rule. So I would want the cells to be using 3-color scale. So let's choose 3-color scale. Now when you say 3-color scale, it says what will be the color of lowest value, and we could choose, might be any one of this. Let's choose red. I can say midpoint is percentile 50, and then the highest value is green. And if that looks good, let's say okay. And now if you see, the lowest values have been highlighted as red. You have mid values, and then you have the positive value. So this is a 3-color scale, and that easily helps me in identifying the data based on the cell values. Now in conditional formatting, what you can also do is you can basically color the cells based on their values. So what we are seeing here is if the revenue generated is greater than average, then that shows in green. And if the revenue generated is lesser than average, that shows in orange. Now how do we do that? So we can basically again manage some rules. So I can basically create a new rule. Now here I can select one of the options which says format only values that are above or below average, and that's the option I would want to select. Now I can select this, and it says format values that are above average. So in our case, we had it in green. So for example, I'll say above average, and then here I can go for a particular color. So you can go for a particular size. So let's go and look into the formatting. So for example, let's choose yellow. Say okay. Now I'm saying wherever the cell values are above average, it would be yellow instead of green. And let's go in here. Let's go and look into manage rules. So this is basically the rule which we are applying. Now we can also add a new rule, and I need to select the values. So for example, I will say here, so we had gone for above, now we'll go for below. We'll go for format, we will choose red, we'll say okay, we'll say now these are basically the rules which we have created, and here it says applies to your data. So right now it has not been applied. So for example, if I select this, and then I could basically choose my area, just hit on enter. And similarly, you can go in here and then select your area, hit on enter, and say apply, say okay. And now if you see, I have really chosen bright colors, but then I have said wherever my revenue generated is above average, it should be in yellow, and below average should be in red. So we wanted above average to be in green and below average to be in orange. So that's what we have here, right? So you can always color code your cell values based on some rules which you are setting up. Now similarly, you can also find the top 10 and bottom 10 values, and that's pretty easy. So you can just select this, and then you can go into conditional formatting. You can go for top and bottom values, top 10 items, bottom 10 items, or you can go in for more rules. So you can say format only top or bottom ranked values. So you have top 10. Now you can choose the color, and for example, I'll go for blue, and I'll say okay. So now if you see, my top 10 values are blue. Now similarly, I can add one more rule. So I can say new rule, and I can say let's go for top or bottom. Let's go for bottom. Let's go for format. Let's say orange. Say OK. Say OK, and that's it. So now you have your values which are top or bottom 10 values. So you are using conditional formatting where you are basically highlighting your cell values based on different colors, and here easy conditional formatting based on different rules helps us to do that. Now similarly, you can also have the values which is basically showing you how the values are increasing. So what we can do is we can select our columns. Either you could apply this to all the columns. Now here I have applied this only to Jan and April. Now I could apply this for June. So let's say June. So you can go for gradient fill, you can go for solid fill, you can obviously just select the color, and that takes care of the things. You can say, for example, select this, and now this is selected, but I would want to might be format this. So I can go in here, I can go into manage rules. Now that will tell me what rule has been applied in the order. So I can just do a edit rule, and that basically says this is a solid fill, which is color. You have no border. This is basically color is black. Now I can go for something like gradient fill, and I can say OK. And now if I say apply and OK, so this basically is like your first column. So you can use conditional formatting for various use cases, and you can highlight the values. So anyone who would look at the value would automatically notice which are the higher values, which are lower values. Might be here the revenue is getting generated or was getting generated but did not grow beyond a particular value, and so on. Now similarly, you can also go in for different options. Say for example, here we would want to see if the revenue was dropping, or if the revenue decreased, or say for example if the revenue was going up for this particular salesperson. So here we are looking at Carol. So in Jan the revenue generation by sales was very high, then in Feb it was falling down, in March it was kind of stable, then in April it went way below. So we can obviously work on this, wherein we can grade our cell values. So what we can do is we can go in for highlighting the cell values. Now you can go for color scales, you can go for icon sets, and this is where you can choose your different shapes. So you could choose one of these shapes. So for example, I would be interested in looking at the indicators like directional. I could go using this 3 arrows. I can go in for this color. I can choose directional, and then my values are automatically using directional. Now what we can also do is we can then go into manage rules, and that basically tells me what rules have been applied. So for example, the latest one is the icon set, which I have chosen. It shows the selected columns. I can obviously do a edit rule, and then I can choose. So I'm saying the format style is icon sets. I'm not using a data bar. I'm not using color scale. Now here I have chosen the style of icons, and then here you can basically give some values. So you have icon which is green when the value is greater than or equal to 67%. When I say hyphen or minus, it is less than 67. It's way below 33%, then you give this value. So you can obviously edit and easily highlight your cell values based on this icon set. So I can apply this, and that's how I use conditional formatting. So conditional formatting can be very useful if you would want to use icon set, if you want to use your data bars, if you would want to highlight particular values. if you would want to color code based on some calculation, if you would want to use a 3-color or a 2-color scale, or if you would want to just find out values based on some simple calculation. So conditional formatting is used extensively by data analysts or people who are working in business intelligence teams, or people who would want to use Excel to easily identify the data, easily identify the cells which contain particular value, or finding out less significant or more significant cells to then pull out values and carry out your computations, calculations, or analysis.
So far, we have understood the important fundamentals of data analytics. Moving further, we will discuss the important tools and frameworks you need to become a professional data analyst. But before that, let's hear from our learners about their personal experience and their success story after graduating from the Simplilearn's postgraduate program in data analytics that is offered by Purdue University.
Upskilling is extremely essential for any working professional nowadays. After completing the professional certificate program in data analytics from Simplilearn in partnership with Purdue University, my career took a significant turn. I was able to change my career domain from teaching kids to providing supportive services to adults at the Department of Rehabilitation in San Francisco. The experience that I have with Simplilearn was amazing. The faculty was very encouraging. I'm excited about my future, and I encourage all professionals.
Feeling inspired already? Not one, but we have multiple success stories to share if you are inspired. Consider checking the Simplilearn's postgraduate program in data analytics offered by Purdue University. For more details, use the link in the description box below. The link should redirect you to the official course landing page that will give you a complete overview of the course being offered. Also, if you are a complete beginner and an aspiring data analyst looking for online training and certifications in collaboration with leading experts, then search no more. Simplilearn's Data Analysis Master's program should be your right choice. For more details, use the link in the description box below.
Applications of data analytics. Now, the sky's the limit on this. In today's world, almost every business, act of life, your music on your Spotify are driven by data analytics. But some of the big players, when you go in there job hunting, are going to be your fraud analysis. If you want to go make a lot of money and you're good at it and you like dealing with numbers, go join the banks and track down the criminals who are stealing money. It's a lot of, it's a big thing to protect credit cards, protect sales purchases, bad checks, any of those things. When you can track them down is huge. Healthcare, exploding. There is everything from trying to find cures for the COVID virus or any of the viruses out there, using your cell phone to diagnose different ailments. That way you don't have to go in and see the doctor. You can actually just go in there and take a picture of the funky growth on your arm. Hopefully it's not too big. And then they send it in there and the data analytics goes in there and looks at it and says, oh, this is what this is. This is a professional you need to go see or don't need to see. And that's just one aspect of healthcare. The databases being generated by healthcare and getting the right doctors and helping the doctors analyze whether something is benign or malignant, if it's cancerous. All those things are now part of the ongoing healthcare growth in data analytics. Inventory management. Think one of those huge warehouses where they're shipping out all the goods. How do you inventory that in such a way so that you maximize the stuff that's being purchased the most near the entrance and all the other stuff towards the back, or even pre-ship it? So it's huge to be able to manage your inventory. And pretty soon they'll just have a drone come in there and start picking up some of those boxes and move them around also. Delivery logistics. Again, this goes from getting from point A to point B. You can combine it with our inventory, so you pre-ship stuff if you know a certain area is more likely to purchase it. How do you get the delivery to the most destinations the quickest in the short amount of time? And then they even pre-stack the trucks going out, and that's all done with data analytics. How do we stack all that stuff so it comes out in the right order? Targeted marketing, huge industry. Any kind of marketing, whether you're generating the right content for the marketing, who are you targeting with that marketing, researching the people, what they want, so you know what products to market out there, all those things are huge. And these are just a few examples. You can probably go way beyond this, from tracking forest fires to astrology and studying the stars. All of this is part of data analytics now and plays a huge role in all these different areas. City planning is another one. You can see a nice organized city like this one where you can get in and out of the neighborhoods if you're a fire truck. Police officers need to be able to get in and out. You want your tourists to be able to come in, yet you still want the place to look nice, and you have the right commercial development, the right industrial development, like enough residents for people to stay. All those things are part of your city planning. Again, huge in data analytics. So, sky's the limit on what you use it for. Let's take a look at types of data analytics. And this can be broken up in so many ways, but we're going to start with looking at the most basic questions that you're going to be asking in data analytics. And the first one is you want descriptive analytics. What has happened? Hindsight. How many sales per call ratio coming out of the call center? If we have 500 tourists in a forest and you have a certain temperature, how many fires were started? How many times did the police have to show up to certain houses? All that's descriptive. The next one is predictive. Predictive analytics is what will happen next. We want to predict. This is great if you have an ice cream store and you want to predict how many people to work at the ice cream store on a certain day based on the temperature coming up in the time of the year. And then one of the biggest growing and most important parts of the industry is now prescriptive analytics. And you can think of that as combining the first two. We have descriptive and we have predictive. Then you get prescriptive analytics. How can we make it happen? Foresight. What can we change to make this work better? In all the industries we looked at before, we can start asking questions, especially in city development. There's a good one. If we want to have our city generate more income, and we want that income to be commercial based, what kind of commercial buildings do we need to build in that area that are going to bring people over? Do we need huge warehouse cells, Costco sales buildings, or do we need little mom and pop joints that are going to bring in people from the country to come shop there? Or do you want an industrial setup? What do you need to bring that industry in there? Is there a car industry available in that area? If it's not a car industry, what other industries are in that area? All those things are prescriptive. We're guessing. We're guessing what can we do to fix it? What can we do to fix crime in an area with education? What kind of education are we going to use to help people understand what's going on so that we lower the rate of crime and we help our communities grow better? That's all prescriptive. It's all guessing. We want foresight into how can we make it happen? How can we make this better? And we really can't not go into enough detail on these three because a lot of people stumble on this when they come in and are doing analytics, whether you're the manager, shareholder, or the data scientist coming in. You really need to understand the descriptive analytics where you're studying the total units of furniture sold and the profit that was made in the past. Here we go into predictive analytics, predicting the total units that would sell and the profit we can expect in the future, gear up for how many employees we need, how much money we're going to make, and prescriptive analytics, finding ways to improve the sales and the profit so we can sell maybe a different kind of furniture. We're going to guess at what the area is looking for and how that marketing is going to change. Data analytics process steps. So let's take a look at some of the basic processing and what that looks like when you're working with this data. So there's 5 basic steps. The 5 steps of processing, and this changes, and then there's a lot of things that go on when they talk about agile programming. The whole concept of agile is you take some kind of framework like this and then you build on it depending on what your business needs. So the first step is data collection. And usually with a large company you might have somebody who is responsible for the database management. You might have another one where they're pulling APIs and they're pulling data off of maybe the Census Bureau, maybe something very, very specific, domain specific. So if you're analyzing cancerous growths and how to understand them, then the data collection is going to be those measurements they take from the MRI, or it might be even the MRI images. They've used those also. So there's a lot of things with data collection and how to control that and make sure it has what you need and is clean and you don't have misinformation coming in. Once you have the data collected, there's a data preparation. So stage 2 is we take that data and we format it into something we can use. Probably one of the biggest formats that you see is when you're processing text. How do you process text? Well, you use what they call a one-hot encoder, and each word is represented by a yes-no kind of setup. So it'd be like a long array of bits. That's one way to prepare it. And so, bit number 1 is the. Bit number 2 is has, or whatever it is. Other preparations might be, if you're using neural networks, you might be taking integers or float numbers and converting them to a value between 0 and 1. That way you don't have one of them creating a bias in there. So there's a lot of different things that go into data preparation. That is 80% of data science. So when we talk about the data analytics, which is a little bit more on the math side, and they usually talk about a data scientist kind of being the overall preparer of this stuff, you're going to spend 80% of your data preparation. Data exploration, that's the fun part. This is where you're exploring things. And it is maybe 10 to 15% of what you do with the data you spend with the data exploration. It is probably the most important step, because this is where you got to start asking questions. If you ask your questions wrong, you're going to get some wrong information. If you're working with a company and they want to know the marketing values, then you really got to focus on, hey, how do we generate money for this company? Or fraud, how do we lower the fraud rate while still generating a profit? 4, data modeling. This is where we start actually getting into the data code, which model to use that predicts what's going to happen. And then result interpretation. We want to be able to interpret those results. You usually see that in your Matplot library, where you create nice, beautiful images so that it shows up on their dashboard for the marketing manager or for the CEO, so they can take a quick look and say, hey, I can see what's going on there. You want to reduce it to something they can easily read. They don't want to hear the scientific terms. They want to see something they can use. And we'll talk about that a little bit more when we start looking at some of this in a demo. Since this is data analysis with Python, we got to ask the question, why Python for data analytics? I mean, there's C++, there's Java, there's .NET from Microsoft. Why do people go to Python for it? So the number of reasons. 1, it's easy to learn with simple syntax. You don't have a very high typeset like you do in Java and other coding, so it allows you to kind of be a little lazy in your programming. That doesn't mean that it can't be set that way and that you don't have to be careful. It just means you can spin up a code much quicker in Python. The same amount of code to do something in Python a lot of times is 1, 2, or 3, or 4 lines, where when I did the same thing, say in Java, I found myself with 10, 12, 13, 20 lines, depending on what it was. It's very scalable and flexible. So there's our flexibility, because you can do a lot with it, and you can easily scale it up. You can go from something on your machine to using PySpark under the Spark environment and spread that across hundreds, if not thousands, of servers across terabytes of data or petabytes of data. So it's very scalable. There's a huge collection of libraries. This one's always interesting because Java has a huge collection of libraries. C has a huge collection of libraries. .NET does, and they're always in competition to get those libraries out. Scala for your Spark. All those have huge collections of libraries. This is always changing, but because Python's open source, you almost always have easy to access libraries that anybody can use. You don't have to go check your licensing and have special licensing like you do in some packages. Graphics and visualization, they have a really powerful package for that, so it makes it easy to create nice displays for people to read. And community support. Because Python is open source, it has a huge community that supports it. You can do a quick Google and probably find a solution for almost anything you're working on. Python libraries. Let's bring it together. We have data analytics and we have Python. So when we're talking data analytics, we're talking Python libraries for data analytics. And the big 5 players are NumPy, Pandas, Matplot library, SciPy, which is going to be in the background, so we're not going to talk too much about the scientific formulas in SciPy, and scikit. So NumPy supports n-dimensional arrays, provides numerical computing tools useful for linear algebra and Fourier transform. And you can think of this as just a grid of numbers. And you can even have a grid inside a grid, or data. It's not even numbers, because you can also put words and characters and just about anything into that array. But you can think of a grid, and then you can have a grid inside a grid, and you end up with a nice three-dimensional array. If you want to talk three-dimensional array, you can think of images. You have your 3 channels of color, 4 if you have an alpha, and then you have your XY coordinates for the image we're looking at. So you can go X, Y, and then what are the 3 channels to generate that color. And NumPy isn't restricted to 3 dimensions. You could imagine watching a movie. Well, now you have your movie clips, and they each have their X number of frames, and each of those frames have X number of XY coordinates for the pictures in each frame, and then you have your 3 dimensions for the colors. So NumPy is just a great way to work with n-dimensional arrays. Now closely with NumPy is pandas. Useful for handling missing data, perform mathematical operations, provides functions to manipulate data. Pandas is becoming huge because it is basically a data frame. And if you're working with big data and you're working in Spark or any of the other major packages out there, you realize that the data frame is very central to a lot of that. And you can look at it as a Excel spreadsheet. You have your columns, you have your rows or indexes, and you can do all kinds of different manipulations of the data within, including filling in missing data, which is a big thing when you're dealing with large pools or lakes of data where they might be collected differently from different locations. And Matplot library. We did kick over the SciPy, which is a lot of mathematical computations, which usually runs in the background of NumPy and Pandas. Although you do use them, they're useful for a lot of other things in there. But the Matplot library, that's the final part. That's what you want to show people. And this is your plotting library in Python. Several toolkits extend Matplot library functionality. There's like 100 different toolkits to extend Matplot library, which range from how to properly display star constellations from astronomy. There's a very specific one built just for that, all the way to some very generic ones. We'll actually add Seaborn in when we do the labs in a minute. Several toolkits extend Matplot library functionality, and it creates interactive visualization. So there's all kinds of cool things you can do as far as just displaying graphs, and there's even some that you can create interactive graphs. We won't do the interactive graphs, but you'll see, you'll get a pretty good grasp of some of the different things you can do in Matplot library. Let's jump over to the demo, which is my favorite. Roll up our sleeves, get our hands in on what we're doing. Now, there's a lot of options when we're dealing with Python. You can use PyCharm as a really popular one. And you'll see this all over the place. So it's one of the main ones that's out there, and there's a lot of other ones. I used to use NetBeans, which has kind of lost favor. Don't even have it installed on my new computer. But the most popular one right now for data science. Now, PyCharm is really popular for Python general development. For data science, we usually go to Jupyter Notebook or Anaconda. And we're going to jump into Anaconda because that's my favorite one to go to because it has a lot of external tools for us. We're not going to dig into those, but we will pop in there so you can see what it looks like. So with Anaconda, we have our Jupyter Lab, we have our Notebook. These are identical. Jupyter Lab is an upgrade to the Notebooks with multiple tabs. That's all it is. And we'll be using the Notebook. And you can see that PyCharm is so popular with Python that we even have it highlighted here in Anaconda as part of the setup. Jupyter Notebook can also be a standalone. So we're actually going to be running Jupyter Notebook. And then you have your different environments. We're going to be under main Py36. There's a root one. And I usually label it Py36. The reason is currently as of writing this, TensorFlow only works in 3.6 and not in 3.7 or 3.8 for doing neural networks. But you can actually have multiple environments, which is nice. They separate the kernels, so it helps protect your computer when you're doing development. And this is just a great way to do a display or a demo, especially if you're looking for that job. Pull up your laptop, open it up. Or if you're doing a meeting, get it broadcast up to the big screen so that the CEO can see what you're looking at. And when we launch the Notebook, it actually opens up a file browser in whatever web browser you have. This happens to be Chrome. And then you can just go under New. There's a lot of different options depending on what you have installed. Python 3. And this just creates an untitled version of this. And you can see here I'm actually in a Simplilearn folder for other work I've done for Simplilearn. And that's where I save all my stuff and I can browse through other folders, making it real easy to jump from one project to another. And under here, we'll go ahead and change the name of this, and we'll go ahead and rename it Data Analytics. Data Analytics. Just so I can remember what I was doing. Which is probably about 50 of the folders in here, or files in here right now. So let's go ahead and jump in there and take a look at some of these different tools that we were looking at. And as we go through the demo, let's start with the NumPy, the least visually exciting. And I'm going to zoom in here so you can see what we're doing. And the first thing we want to do is import NumPy. And we'll import it as NP. That is the most common NumPy terminology. And let's go ahead and change the view so we also have the line numbers. I don't know why, we probably won't need them, but I like it for easy reference. And then we'll create a one-dimensional array. We'll just call this array1, and it equals np.array, and you put your array information in here. In this case, we'll spell it out. You can actually do like a range and other ways. There's lots of ways to generate these arrays. But we'll just do 1, 2, 3, so 3 integers. And if we print our array1, we can go ahead and run this, and you can see right here it prints 1, 2, 3. You can see why this is a really nice interface to show other people what you're doing with the Jupyter Notebook. So this is the basic. We've created an array. This is a one-dimensional array, and then the array is 1, 2, 3. One of the nice things about the Jupyter Notebook is whatever ran in this first setup is still running, is still in the kernel. So it still has the NumPy imported as NP, and it still has our variable ARR1 for array1 equal to NP array of 1, 2, 3. So when we go to the next cell, we can check the type of the array. We're just going to print. We say, hey, what is this setup in here? And we want type, and then we want what is the type of array1. And let's go ahead and run that. And it says class NumPy ND array. So it's its own class. That's all we're doing is checking to see what that class is. And if you're going to look at the array class, probably the biggest thing you do, I don't know how many times I find myself doing this because I forget what I'm working on, and I forget I'm working with a 3-dimensional or 4-dimensional array. And I have to reformat somehow so it works with whatever other things I have. And so we do the array shape. The array shape is just 3 because it has 3 members and it's a one-dimensional array. That's all that is. And with the NumPy array, we can easily access, stick with the print statement. If you actually put a variable in Jupyter Notebook and it's the last one in the cell, it will be the same as a print statement. So if I do this, where array1 of 2, it's the same as doing print array of 2. Those are identical statements in our Jupyter Notebook. We'll go and stick with the print on this one. And it's 3. So there's our print space 2, and we have 0, 1, 2, 2 equals 3. We can easily change that. So we have array 1 of place 2 equals 5. And then if we print our array 1, you can see right down here when it comes out, it's 1, 2, and 5. And there I left the print statement off because it's the last variable in the list. It'll always print the variable if you just put it in like that. That's a Jupyter Notebook thing. Don't do that in PyCharm. I've forgotten before doing a demo. And we talked about multiple dimensions, so we'll do an array, 2-dimensional array. And this is again a NumPy array. And in the NumPy array, we need our first dimension. We'll do 1, 2, 3, and our second dimension 3, 4, 5. And you can see right here that when we hit the, we'll do this. We'll just do array 2. And we can run that, and there's our array 2, 1, 2, 3, 3, 4, 5. We can also do array 2 of 1. And then we can do, let's do 0. Doesn't really matter which one. Actually, let's do 2. There we go. And if I run this, it'll print out 5. Because here we are. This is 0. 0, 1, 2, 3 is on our 0 row. 3, 4, 5 is on our 1 row. I always start with 0. And then the 2, 0, 1, 2 goes to the 5. And then maybe we forgot what we were working with, so we'll go do array2.shape. And if we do array2 of shape, we'll go and run that. We'll see we have 2 rows, and each row has 3 elements. Two-dimensional array, 2, 3. If you looked up here when we did it before, it just had 3 comma nothing. When you have a single entity, it always saves it as a tuple with a blank space. But you can see right here we have 2 comma 3. And if you remember from up here, we just did this array2 of, let's go, what is it, 1 comma 2. We run that, we get the 5. You can also count backwards. This is kind of fun. And you'll see I just kind of switched something on you, because you can also do 1 comma 2 to get to the same spot. Now 2 is the last one, 0, 1, 2. It's the last one in there. We can count backwards and do -1. And if we run this, we get the same answer. Whether we count it as, let's go back up here, whether we count this as 0, 1, 2, or we count backwards as -1, -2, -3. And you can see that if I change this -1 to a -2 and run that, I get 4, which is going backwards, -1, -2. So there's a lot of different ways to reference what we're working on inside the NumPy array. It's really a cool tool. It's got a lot of things you can do with it. And we talked about the fact that it can also hold things that are not values, and we'll call this array ask for strings equals np.array. Put our setup in there, our brackets, and let's go China, India, USA, Mexico. It doesn't matter, we can make whatever we want on here. And if we print that out, we run this, you can see that we get our NumPy array, China, India, USA, Mexico. It even gives us our D type of a U6. And a lot of times when you're messing with data, we'll call this array R for range, just to kind of keep it uniform. np.arange. So this is a command inside NumPy to create a range of numbers. And if you're testing data, maybe you want, maybe you have equal time increments that are spaced a certain point apart. But in this case, we're just going to do integers. And we're going to do a setup from 0, 20, skipping every other one. And we'll print it out and see what that looks like. And you can see here we have 0, 2, 4, 6, 8, 10, 12, 14, 16, 18. Like you expected, it skips every one. And just a quick note, there's no 20 on here. Why? Well, this starts at 0 and counts up to 20. So if you're used to another language where it explicitly says less than or less than equal to 20, like for x equals 0, x plus plus, x is less than 20. That's what this is. It just assumes x is less than 20 on here. And if we want to create a very uniform set, 0, 2, 4, 6, what happens if I want to create numbers from 0 to 10, but I need 20 increments in there? We can do that with line space. So we can create an R, we'll call this L, equals, I don't think we'll actually use any of this again, so I don't know why I'm creating unique identifiers for it. But we'll do np lin space, and we're going to do 0 to 10, or 0 to 9. Remember, it goes up to 10. And then we want to, let's say we have 20 different increments in there. So we're creating we have a data set, and we know it's over a certain time period, and we need to divide that time period by 20. And it happens to just have 10 pieces in it. And here we go. You can see right here, we have 20, or it has 20 pieces in it, but it's over 10 years. And we got to divide it in the middle. And you can see it goes 0.52. Remember, yeah, there's our 10 on the end, so it goes up to 10. And then we can also do random. There's np.random. If you're doing neural networks, usually you start it by seeding it with random numbers. And we'll just do np.random, and we'll just call this array. We'll stop giving it unique numbers. We'll print that one out and run it. And you can see we have random numbers. they are 0 to 1. So you'll see that all these numbers are under 1, and you can easily alter that by multiplying them out or something like that if you want to do like 0 to 100. You can also round them up if it's integer 0 to 100. There's all kinds of things you can do, but it generates a random float between 0 and 1. And you have a couple options. You could reshape that, or you can just generate them in whatever shape you want. And so we can see here, we did 3 and 4, and so you can see 3 rows by 4 variables. Same thing as doing a reshape of 12 variables to 3 and 4. And if you're going to do that, you might need an empty data set. I have had this come up many times where I need to start off with 0, and I don't know, because I'm going to be adding stuff in there, or it might be 0 and 1, where 1 is, if you're removing the background of an image, you might want the background is 0, and then you figure out where the image is, and you set all those boxes to 1, and you create a mask. So creating masks over images is really big, and doing that with a numpy array of 0. And we can also give it a space. And we'll just do this all in one shot this time. And we'll do the same thing like we did before, zeros. And in this case, we'll do 2, 3. And so when we run this, forgot the asterisks around it. I knew I was forgetting something. There we go. So when we run this, you can see here we have our 10 zeros in a row, and maybe this is a mask for an image, and so it has 2 rows of 3 digits in it. So it's a very small image, little tiny pixel. And maybe you're looking to do something the opposite way. Instead of creating a mask of zeros and filling in with ones, maybe you want to create a mask of 1s and fill them in with zeros. And we'll just do, just like we did before, we'll do 3, 4. And when we run this, you'll see it's all 1s. And we could even do this even, we'll do it this way. Let's do 10 by 10 icon, and then you have your 3 colors. And you can, so it creates quite a large array there for doing pictures and stuff like that when you add that 3rd dimension in. If we take that off, it's a little bit easier to see. We'll do 10 again. And you can easily see how we have 10 rows of 10 ones. And you can also do something like create an array. And we'll do 0, 1, 2. And then in this array, we actually, we'll print it right out. We want a repeat. And so you can actually do a repeat of the array, and maybe you need this array, let's repeat it 3 times. So there's our repeat of an array, repeat 3 times. And if we run this, you'll see we have 0, 0, 0, 1, 1, 1, 2, 2, 2. And whenever I think of a repeat, I don't really think of repeating being the first digit 3 times, the second digit. I really always think of it as 0, 1, 2, 0, 1, 2, 0, 1, 2. It catches me every time. But the actual code for that one is going to be tile. And again, if we do arrange 3 and we run this, you can see how you can generate 0, 1, 2, 0, 1, 2, 0, 1, 2. And if you're dealing with an identity matrix, we can do that also if you're big on doing your matrices. And we'll just identity. I guess we'll go ahead and spell it out today. Matrix. And the command we're looking for is EYE. And we'll do 3. And then we'll just go ahead and print this out. There we go. There's our identity matrix. And it comes out by a 3 by 3 array, because there's our matrix. And then it puts the 1s down the middle and for doing your different matrix math. And we can manipulate that a little bit too. We talk about matrices. We might not want 1s across the middle, in which case we now have the diagonal. So we can do an np.diagonal. And we do a diagonal. Let's put in the diagonal 1, 2, 3, 4, 5. And when we run this, Again, this generates a value, and by just putting that value in, there's the same as putting print around it, or putting array equals and then print array. And you can see it generates a diagonal 1, 2, 3, 4, 5, and there's your beginning of your matrix array for working with matrices. And we can actually go in reverse. Let's create an array equals, remember our random random.random, and we'll do a 5 by 5 array. Oops, there we go. 5 by 5. And just so you can see what that looks like. Helps if I don't mistype the numbers, which in this case I just need to take out the brackets. And there you go, you have your 5 by 5 array set up in there. And we can now, because we're working with matrices, we might want to do this in reverse and extract the diagonals, which would be the 0.79, the 0.678, and so on. And we simply type in np.diagonal. We put our array in there. And this will of course print it out because it returns it as a variable. And you can see here's our diagonal going across from our matrix. And we did talk about shape earlier. If you remember, you can do print the shape out. You can also do the dimensions. So in dimensions, very similar to shape, it comes out and just has 2 dimensions. We can also look at the size. So if we do size on here, we can run that, and you can see it has a size of 25, 2 dimensions, and of course 5 by 5. And that was from the shape from earlier that we looked at. There's our 5 by 5 shape. And if you remember earlier we did random, well, you can also do random. I talked a little bit about manipulating 0 to 1 and how you can get different answers. You can also do straight for the integer part, and we'll do minus 10 to 10, 4. And so we're going to generate random integers between minus 10 to 10. We're going to generate 4 of those. And so when we run that, we have 7, minus 3, minus 6, minus 3. They're all between minus 10 and 10, and there's 4 of them. And now we jump into some of the functionality of arrays, which is really great, because this is where they come in. Here's your array, and you can add 10 to it. And if I run this, there it takes my original array from up here with the integers and adds 10 to all of those values. So now we have, oh, this is the decimal, that's right. This is a random decimal I had stored in an array. But this takes a random decimal, the random numbers I had from 0 to 1 and adds 10 to them. And we can just as easily do minus 10. We could even do times 2. And we could do divide by 2. And it'll take that random number we generated and cut it in half. So now all these numbers are under 0.5. Another way you can change the numbers to what you need on there. And as you dig deeper into NumPy, we can also do exponential. So as an exponential function, which would generate some interesting numbers off of the random. So we're taking them to the power, I don't even remember what the original numbers in the array were, because we did the random numbers up there. Here's our original numbers, and if you build an exponential on there, this is where you get e to the x on this. And just like you can do e to the x, you can also do the log. So if you're doing logarithmic functions, that reinforced learning, you might be doing some kind of log setup on there, and you can see the logarithmic of these different array numbers. And if you're working with log base 2, you can just change it in there, np log 2. You have to look it up, because this is not log 1, 2, 3, 4, 5. It is log and log 2. So just a quick note, that's not a variable going in. That is an actual command. There's a number of them in there, and you'll have to go look and see what the documentation is. But you can also do log 10. So here's log value 10. Some other really cool functions you can do with this is your sign. So we can take a sign value of all of our different values in there. And if you have sine, you of course have cosine. We can run that. So here's a cosine of those. And if you're doing activations in your NumPy array and you're doing a tangent activation, there's your tangent for that. And the tangent activation is actually from neural networks. That's one of the ways you can activate it, because it forms a nice curve between from whether you're generating 1 to -1 with some discrepancy in the middle. Just jumping a little bit in there into neural networks. And then we get into, let me just put the array back out there so that we can see it while we're doing this. As we're getting into this, you can also sum the values. So we have np sum, and you can do a summation of all the values in this array. And you'll see that if you added all these together, they'd equal 12.519, and so on. I don't know what the whole setup is in there. But you can see right here the summation of this. One of the things you can also do is by axes. So we could do axes equals 0. And if we run the summation of the axes equals 0, and you can think of that in NumPy as the rows. So that would be, or you can think of that in NumPy as being the columns. We're summing these columns going across. And you can also change this to 1, and now we're summing the rows. And so that is the summation of this row, and so forth going down. And maybe you don't need to know the summation. Maybe what you're looking for is the minimum. So here's our minimal. You're looking for, and this comes up a lot because you have like your errors. We want to find the minimal error inside of this array. And just like the other one, we can do axes equals 0. And you can see here 0.0645 is the smallest number in this first column is 0.0645, and so on. And if you have a minimum, well, you might also want to know the max. Maybe we're looking for the maximum profit. And here we go. You can see maximum 0.79 is the maximum on this first column. And just like we did before, you can change this to a 1 on axes. You can take the axes out of here and just find the max value for the whole array. And the max value in here was 0.8344, so on and so on. And since we're talking data analytics, we want to go ahead and look at the mean. Pretty much the same as the average. This is the mean across the whole thing. And just like we did before, we could also do axes equals 0. And then you'll see this is the mean of this axis, and so on. And we have mean. We might want to know the median. And there's our median, our most common numbers. If we have median, we might want to know the standard deviation. Or if we have the average, a lot of times you do the means and the standard deviation. We can run that, and there's our standard deviations along the axes. We can also do it across the whole array. If we're going to do standard deviations, there's also variance, which is your VAR. And there's our variance across the different levels. And so if we looked at that, we looked at variance, we looked at standard deviation, the median, and the means. There's more, but those are the most common ones used with data analytics. And then going through your data and figuring out what you're going to present to the shareholders. And some other things we can do is we can actually take slices. You'll hear that terminology. And a slice might be, like we have a 5 by 5 array, but maybe we don't want the whole array. Maybe we want from 1 on, we don't want the 0 in there. So we got up to 4. And maybe on the second part, we just want 2 to row 3. And so this notation right here says 1 to the end. And if we run this, you can see how that generates a single row to the end, and then row 2 and 3. Now remember, it doesn't include 3. That's why we only get the 1 column. So if you wanted 2 and 3, you would need to go ahead and go 2 to 4. So it goes up to 4. We could also do this in reverse. Just like we learned earlier, we can go -1. Whoops. And when we go to -1, it's the same thing because we have 0, 1, 2, 3, 4. This is the same thing as 2 to 4. It goes 2 to the last one. Also very common with arrays is you're going to want to sort them. So we still have our array up here that we randomly generated, and we might want to sort it, and we'll go and throw an axis back in there. Axis equals 1. If we run this, you can see from the axes that it sorts it the 0.2 being the lowest value to the highest value by the row. We can also change this, of course, to axis 0 if you're sorting it by columns. So maybe your values are based on columns. And then, of course, you can do the whole array, and we can sort that. Don't usually do that, but I guess sometimes that might come up. And so you can see right here we have a nice sorted array. Something else, let's just go ahead and reprint our array so we can look at it again. Starting to get too many boxes up there. Something else you can do with an array is we can take and transpose it. This comes up more than you would think. When you transpose it, you'll see that the rows in the column are transposed. So where 0.79, 0.57, 0.064 is a column, now we've switched it and we have 0.79, 0.42 as the index. You can see this really more dramatic if we take a slice, and we'll just do a slice of the first couple, and then we'll just do all the other, the full rows, and if we run this, you can see how it comes up a little bit different. And we'll just do the same slice up here so you can see how those two look next to each other. There we go, there's our slice, run. And so you can see the slice comes up and it has 1, 2, 3, 4, 5 columns. Now we have 1, 2, 3, 4, 5 rows and 3 columns versus 3 rows. And the original version, when they first started putting this together, was a function. So the original version was transpose, and this still works. You can still see it generates the same value as just a capital T. So many times we flip this data because we'll have an XY value or we'll have an image or something like that, and it's being read one way into the next process, and the next one needs it the opposite. So this actually happens a lot. You need to know how to transpose the data really quick. And we can go ahead, let's just take, here's our transpose. We'll just stick with the transpose on here. And instead of doing it this way, we might need to do something called flattening. Why would you flatten your data? If this is an array going into a neural network, you might want to send it in as one set of values instead of 2 rows. And you can see here is all the values as a single array. It just flattens it down into one array. So we covered our scientific means, transpose, median, some different variations on here. Some of the other things we want to do is what happens if we want to append to our array. So let's create a new array. I'm getting tired of looking at the same set of random numbers we generated earlier. So we'll go ahead and create a new array here, something a little simpler so it's easier to see what we're doing. And 4, 5, 6, 7, 8. That's good enough. We'll just do 4, 5, 6, 7, 8. And if we print this array, there it is, 4, 5, 6, 7, 8. And we might want to append something to the array. So we have our array, we need to extend it. You got to be very careful about appending things to your array, and there's a number of reasons for that. One is runtime. Because of the way the NumPy array is set up, a lot of times you build your data and then push it into the NumPy array instead of continually adding on to the array. And then it also it automatically generates a copy for protecting your data. So there's a lot of reasons to be careful about appending this way. But you can certainly do it. And we can just take our array, we're going to create a new array, array 1. And if we print array 1 and we append 8 to it, you'll see 4, 5, 6, 7, and then there's our 8 appended onto the end. And if you want to append something to an array, you'd probably also want to, whoops, array 1. Let's try that again. There we go. Now we have the 8 appended onto the end. So you can see 4, 5, 6, 7, 8, and then we appended another 8 on there. And if you're going to append something, you might want to go ahead and insert. Instead of appending, it might be you need to keep a certain order. And we can do the same thing. We can do our array, and we're going to append or insert at the beginning. And let's go ahead and insert 1, 2, 3. 1, 2, 3. And we go ahead and print our array 2. We run it, and you can see 1, 2, 3 is inserted at the beginning. Insert's a lot more powerful in that you can put it anywhere in the array. We can move it to the 1 spot, and there we go, 1, 2, 3. We can do a -1 just for fun, and you'll see it comes up 1, 2, 3, and we're counting backwards by 1. I imagine you can do a -0 and run this, and it turns out that -0 puts it back at the beginning, because that's how it registers as 0, it just takes a minus sign off. And just like we add numbers on, we might want to delete numbers. And so let's do an np.delete. Well, let's keep it a little bit, make it a little easy here to watch. We'll go ahead and create an array 3, and we'll do np delete. We were just working with array 2, and what we want to do is delete 0 space. So if you look at this, here's our array 2. Array 2 starts with 1, and when we delete the space on here and print that out, we deleted the 1 right out of there. And we can also do something like this, where we can do it as a slice, and we can do, let's do 1, 3, and if we run 1, 3, you'll see we've deleted the 1 space and the 3 space out, which deleted our 2 and 4. Now keep in mind, when you're messing with adding lines and deleting lines, you have to be really careful, because there's a time element involved as far as where the data is coming from, and it's really easy to delete the wrong data and corrupt what you're working on, or to insert stuff where you don't want it. So there's always a warning when we talk about manipulating NumPy arrays. And just like anything else we're doing, we'll create an array C, which equals, we'll just do our NumPy array that we just created, our NumPy array 3, and we can do copy. So you can make a copy of it. Maybe you want to protect your original data, or maybe you're making a mask, and so you copy the array, and then the new array make all these alterations and change it from values to 0 to 1 to mask over the first one. And of course, if we do array C, since it equals a copy of array 3, it's the same thing, 1, 3, 5, 6, 7, 8. And now we're getting into combine and split arrays. I end up doing a lot of this, and I don't know how many times I end up fiddling with this and having a mess. So, but you do it a lot. You know, you combine your arrays, you split them. You might need one set of data for one thing, another set of data for the other. So let's go ahead and create 2 arrays, array 1, array 2. And I want you to note, and the terminology we're going to look for is concatenate. And what that means is we're going to take, we'll call this array cat. I like array cat. There we go. Our array cat, our concatenated array, we're taking array 1 and 2, and it's very important to really pay attention to your axes and your counts. I can't merge 2 arrays that have, like, if their axes are messed up and I'm merging on axis 0, it's going to give me an error and I'll have to reshape them. So you got to make sure that whatever you're concatenating together works. And what that means, as you can see here, we have 1, 2, 3, 4, 1, 2, 3, 4, and then 5, 6, 7, 8, 5, 6, 7, 8 along the 0 axis. These each are 4 values. So it's a 2 by 4 value. And if we go ahead and switch this to 1, you can see how that flips it a little bit. So now we have 1, 2, 3, 4, 5, 6, 7, 8. It's interesting that we chose that one. If I did something like this, where this is now, there we go, and we concatenate it, run this, and it gives me an answer okay, because I have 2 by 2, and I'm using axis 1. But if I switch this to axis 0, where now it's got 3 and 5, it gives me an error. So you got to be really careful on that to make sure that whatever axes you are putting together, that they match. So like I said, this one, oops, axis 1. Axis 1 has 2 entities, and since we're going on axis 1, or by row, you can see that it lets it merge it right onto the end there. And you could imagine this if this was a XY plot of value, or the X value going in and the predicted Y value coming out, and then you have another prediction and you want to combine them. This works really easy for that. And we'll go back and let's just put this back to where we had it. Oops, I forgot how many changes I made. There we go. We'll just put it, whoops, I messed up on my concatenation order here. There we go. Okay, so you can see that we went through the different concatenation. Axes is really important when you're doing your concatenation values on here. And we'll switch this back to 1 just because I like the looks of that better. There we go. 2 rows. Now, there are other commands in here. So we can do cat v equals np v stack. This is nothing more than your concatenation, but instead we don't have to put the axes in there because v stands for vertical. And so if we print out cat v and we run this, you can see we get the 1, 2, 3, 4, 1, 2, 3, 4, and that would be the same as making this axis 0 for vertical stack. And if you're going to have a vertical stack, you can also have an H stack. So if we change this from V stack to, oops, here we go, H stack, and we'll just change this from cat to cat, and I run this, it's the same as doing axis 0. The process is identical in the background. This is like a legacy setup, your V stack and your H stack. Most people just use concatenate and then put the axes in there because it's much has a lot more clarity and is more commonly used nowadays. The last section in NumPy we're going to cover is kind of data exploration, and that'll make a little bit more sense in just a moment. Sometimes they call them set operations. But let's say we have an array, 1, 2, 3, 4, 5, 6, 3, whatever it is. You can see we generate a nice little array here. And what I want to go ahead and do is find the unique values in that array. So maybe I'm generating what they call a one-hot encoder. And so these values then all become, I need to know how long my bit array is going to be. So each word, each word is represented by a number, and then I want to know just how many of those words are in there. If we're doing word count, very popular thing to do. And you can see here when we do unique, we have 1, 2, 3, 4, 5, 6. Those are our unique values. Some of the things we can do with the unique values is we can also, instead of doing just unique, we can do uniques, our unique values, and counts of each unique value. And this is very similar to what we just did up here, where we're doing np unique, but we're going to add a little bit more into there. And it's just part of the arguments in this. And we want to do return counts equals true. So instead of just returning the unique values, we want to know how many of those unique values are in each one. And we'll go ahead and print our uniques and print our counts. When we run that, you can see here we have our unique value 1, 2, 3, 4, 5, 6, just like we had before. And then there's two of the first of 2 1s, 2 2s, 2 3s, 2 4s, 1 5, 2 6s, and so on. And you can go through and actually look at that if you want to count them. But a quick way to find out your distribution of different values. So you might want to know how often the word the is used versus the word and, if each word is represented as a unique number. And along the set variables, we might want to know, let me just put a note up here. We're going to start looking at intersection, and we might want to also know differentiation, and neither. So when we're, neighbor, neither. So when we're looking at now is we want to know, hey, where do these two arrays intersect? And we have 1, 2, 3, 4, 5, 3, 4, 5, 6, 7. We might want to know what is common between the two arrays. And so when we do that, we have np intersect, and it's a 1D array, one-dimensional array. And then we need to go ahead and put array 1, array 2. And if we run this, we can see they intersect at 3, 4, 5. That's what they have common. And because we're going to go ahead and go through these and look at a couple different options, let's change this from intersect 1D. And we'll do the same thing. We'll go ahead and print this. So we might want to know the intersection where they have commonalities. Another unique word is union of 1D. So instead of intersect, we want to know all the values that are in both of them. So here's our union of 1D. When we run that, you can see we have 1, 2, 3, 4, 5, 6, 7. So it's all the different values in there. And the last, one of the last words, we have 2 more to go, is we want to know what the set difference is. And so that's where you'll see that, if you remember set, we talked about that being what they call these things. So the set difference of a 1D array, when we run that, you can see that 1 is only in one array and 2 is only in one array. And if we want to know what's in array 1 but not in array 2, we might want to know what is in array 1 but not 2 and what's in 2 but not 1. And this would be the set XOR 1D on here. So we have the 4 different options here where we can do an intersection. What do they both have in common? We can do a union. What are all the unique values in both arrays? We can see the difference, what's in array 1 but not array 2, so set diff 1D. And then set XOR, what is not in 1 but is in 2, and what is not in 2 but in 1. So we dug a lot in NumPy because we were talking, there's a lot of different little mathematical things going on in NumPy. A lot of this can also be done in pandas, although usually the heavy lifting is left for NumPy because that's what it's designed for. Let's go ahead and open up another Python 3 setup in here. And so we want to explore what happens when you want to display this. This is where it starts getting, in my opinion, a little fun because you're actually playing with it and you have something to show people. And we'll go ahead and rename this. We're going to call this pandas and pyplot. So pandas pyplot, just so I can remember for next time. And we want to go ahead and import the necessary libraries. We're going to import pandas as PD. Now remember, this is a data frame, so we're talking rows and columns, and you'll see how pandas work so nicely when you're actually showing data to people. And then we're going to have NumPy in the background. NumPy works with pandas, so a lot of times you just import them by default. Seaborn sits on top of the matplot library. So sometimes we use the Seaborn because it kind of extends, it's one of the 100 packages that extends the matplot library. Probably the most common used because it has a lot of built-in functionality. Almost by default, I usually just put Seaborn in there in case I need it. And of course we have matplot library as pyplot, as PLT. And note we have as PD, as NP, as SNS, as PLT. Those are pretty standard. So when you're doing your imports, I would probably keep those just so other people can read your code and it makes sense to them. That's pretty much a standard nowadays. And then we have the strange line here. It says ampersand matplot library inline. That is for Jupyter Notebook only. So if you're running this in a different package, it'll have a pop-up when it goes to display the matplot library. You can, with the most current version of Jupyter, usually leave that out and it will still display it right on the page as we go. And we'll see what that looks like. And then we're going to go ahead and just do the Seaborn, the sns.set, and we're going to set the color codes equals true. Let them just keep the default one so we don't have to think about it too much. And we of course have to run this. The reason we run this is because these values are all set. If we don't run this and I access one of these afterward, it'll crash. The cool thing about Jupyter Notebooks is if you forgot to import one of these, you forgot to install it, because you do have to install this under your Anaconda setup or whatever setup you're in, you can flip over to Anaconda and run your install for these. And then just come back and run it. You don't have to close anything out. And we'll go ahead and paste this one in here real quick where we have car equals pd.read_CSV. And then we have the actual path. This path, of course, will vary depending on what you are working with. So it's wherever you save the file at. And you can see here I have like my OneDrive documents, Simplilearn, Python, data analytics, using Python, / car CSV. It's quite a long file. When we open that up, what we get is we get a CSV file, and we have the make, the model, the year, the engine, fuel type, engine horsepower, cylinders, and so on. And this is just a comma separated file. So each row is like a row of data. Think of it as a spreadsheet. and then each one is a column of data on here. And as you can see right here, it has the make model, so it has columns for a header on here. Now, your Pandas just does an excellent job of automatically pulling a lot of this in. So when you start seeing the Pandas on here, you realize that you are already like halfway done with getting your data in. I just love Pandas for that reason. NumPy also has it. You can load a CSV directly into NumPy, but we're working with Pandas, and this is where it really gets cool, is I can come down here and I can print, you remember our print statement, we can actually get rid of it, and we're just going to do car head because it's going to print that out. The head is going to print the top values of that data file we just ran in. And so you can see right here, it does a nice printout. It's all nice and in line because we're in Jupyter Notebook. I can scroll back and forth and look at the different data. And just like we expected, we have our column, and it brought the header right in. One thing to note is the index. It automatically created an index 0, 1, 2, 3, 4, and so on. And we're just looking at the head. So we got 0, 1, 2, 3, 4. You can change this. You might want to just look at the top two. We can run that. There's our top two BMWs. Another thing we can do is instead of head, we can do tail. And look at the last three values that are in that data file. And you can see right here, it numbered them all the way up to 11,913. Oh my goodness, they put a lot of data in this file. I didn't even look to see how big the file was. So you can really easily get through and view the different data in here. When you're talking about big data, you almost never just print out car. In fact, let's see what happens when we do. If we run this and we just run the car, it's huge. In fact, it's so big that the Pandas automatically truncates it and just does head plus tail, so you can see the two. So we really don't want to look at the whole thing. We'll go and go back to, let's stick with the head, displaying our data. There we go. So there's the head of our data. It gives us a quick look to see what's actually in there. I can zoom out if we want so you can actually get a better view. Although we'll keep it zoomed in so you can see the code I'm working on. And then from the data standpoint, we of course want to look at data types. What's going on with our data? What does it look like? Now this, you show when you're talking to your shareholders, they like to see these nice, easy to read charts. They look like a spreadsheet. So it's a nice way of displaying pieces of the chart. When we talk about the data types, now we're getting into the data science side of it. What are we working with? Well, we have make model, we have an integer 64 for the year. Engine fuel type is an object. If we go up here, you can see that most of them are it's a set manual, rear wheel drive. So they might be very limited number of types in there. And so forth. And it's either going to be a float 64, an integer, or an object is the way it's going to read it on here. And the next thing you're going to know is like your columns. And since it loaded the columns automatically, we have here the make, the model, the year, the engine, the size, all the way up to the MSRP. And just out of something you'll see come up a lot is whenever you're in Pandas and you type in .values, it converts it from a Pandas list to a NumPy array. And that's true of any of these. So then you end up in a NumPy array. So you'll see a little switch in there in the way that the data is actually stored. And that's true of any of these. In this case, we want car.columns. You have a total list of your car columns. And like any good data scientist, we want to start looking at analytical summary of the data set. What's going on with our data? So we can start trying to piecemeal it together. So we can do car, describe, and then what we'll do include equals all. So a nice Panda command is to describe your data. If you're working with R, this should start looking familiar. And we come down here and you can see count. There's the make, the model, the year, how many of each one, how many unique values of each one, the top value of each one, what's most common, the frequency, the mean. Clearly on some of these it's an object, so it really can't tell you what the average is. It'd just be the top one's the average, I guess. The year, what's the average year on there? All this stuff comes down here. Your standard deviation, your minimum value, your maximum value, what's in the lower quarter, 50% mark, where's that line at, and what's in the upper 75%, the top 25% going into the max. Now, this next part is just cool. This is what we always wanted computers to be back like in the 90s, instead of 5,000 lines of code to do this. Maybe not 5,000. All right, I built my own plot library back in 95, and the amount of code for doing a simple plot was, I don't know, probably about 100 lines of code. This is being done in one line of code. We have our car, which is our pandas. We generated that. It's our data frame. And we have .hist for histogram. That is the power of Seaborn. Now, it's still going to generate a NumPy graph, but Seaborn sits on top, and then we can do the figure size. This is just so it fits nicely on the paper on here. And we do something simple like this, and you can see here where it comes up, and it does say matplot library and does subplots and everything. But we're looking at a histogram of all the different pieces in our database. And we have our engine cylinders. That's always a good one, because you can see like they have some that they had a null on there, so they came out as 0. Maybe one of them had a 2-cylinder engine way back when. 4 is a common, 6 a little less common, and then you see the 8-cylinder, 12-cylinder engines. Boy, that's got to be a speedster or something. But you can see right here, it just breaks it down. So now you have how many cars with how many, whatever it is, cylinders, horsepower, and so on. And it does a nice job displaying it. You can see if you're working with your, you're going into your demo, it's really nice just to be able to type that in and boom, there it is. They can see it all the way across. And we might want to zero in and use like a box plot. And this time we'll go ahead and call the Seaborn, SNS, box plot. And we're going to go ahead and do vehicle size versus engine horsepower XY plot. And the data comes from the car. So if we run this, we end up with a nice box plot. You see our mid-size, compact, and large. You can see the variation. There's our outlier showing up there on the compact. That must be a high-end sports car. Large car might have a couple engines, and again we have all these outliers and then your deviation on them. Very powerful and quick way to zero in on one small piece of data and display it for people who need to have it reduced to something they can see and look at and understand. And that's our Seaborn box plot, or our SNS.boxplot. And then if we're going to back out and we want a quick look at what they call pair plotting, we can run that, and you can see with the Seaborn it just does all the work for you. It takes it just a moment for it to pull the data in and compile it. And once it does, it creates a nice grid. And this grid, if you look at this one space here, which is, you might not be able to see the small number, it says engine horsepower. This is engine horsepower to the year it was built, and it's just flipped. So everything to the right of the middle diagonal is just the rotation of what's on the left. And as you expect, the engine horsepower gets bigger and bigger and bigger as time goes on. So the year it was built, the further up in the year, the more likely you are to have a heavy horsepower engine. And you can quickly look at trends with our pair plot coming up. And look how fast that was. It took it a moment to process. But right away I get a nice view of all these different information, which I can look at visually and kind of see how things group and look. Now, if I was doing a meeting, I probably wouldn't show all the data. One of the things I've learned over the years is people, myself included, love to show all our work. We were taught in school, show all your work, prove what you know. The CEO doesn't want to see a huge grid of graphs, I guarantee it. So what we want to do is we want to go ahead and drop the stuff that might not be interested in. And I'm not really a car person. Our guy in the back is, obviously. So you have your engine fuel type. We're going to drop that. We're going to drop market category, vehicle style, popularity, number of doors, vehicle size. And we have the axes in here. If you remember from NumPy, We have to include that axis to make it clear what we're working on. That's also true with pandas. And then we'll look at just what it looks like from the head. And you can see that we dropped out those categories, and now we have the make, model, year, and so forth. And we took out the engine, fuel type, market category, etc. And this should look familiar to you now. When you start working with pandas, I just love pandas for this reason. Look how easy it is. It just displays it as a nice spreadsheet for you. You can just look at it and view it very easily. It's also the same kind of view you're going to get if you're working in Spark or PySpark, which is Python for Spark across big data. This is the kind of thing that they come up with, and this is why pandas is so powerful. And we may look at this and decide we don't like these columns. And so you can go in here and we can actually rename the columns. Simple command, car equals car, rename. Columns equals engine horsepower equals horsepower. This is just your standard Python dictionary. So it just maps them out. And instead of having like the lengthy, if here we had engine horsepower, we just want horsepower. We don't need to know it's the engine horsepower. Engine cylinders, we don't need to know that it's for the engine, because there's only one thing we're describing if we're talking about cars, and that's cylinders. And we'll go ahead and just run this. And again, here's our car head, and you can see how that changed. We have model year and horsepower versus model year, engine horsepower, engine cylinders, and just cylinders. Again, we want to keep reducing this so it's more and more readable. The more readable you get it, the better. And of course, we can also adjust the size a little bit so that when it prints out, instead of splitting it on two lines, we get like a single line. We can do that also. That's just your control mouse up or plus sign you use in Chrome. That's a Chrome command. And if you remember from NumPy, we had shape. Well, pandas works the same way. We can look at the shape of the data. So we now have 11,914 rows and 10 columns. So you see some similarities because pandas is built on NumPy. And questions that come up just like you did in NumPy, we might want to know duplicate rows. And so we can do car. And look at this switch here. We're doing a selection. This is a pandas selection with the brackets. But we want to select it based on car.duplicated. So how many duplicates on there? So it's starting to look a little bit different as far as how we access some of the data on here. This can be a logical statement. And we get the number of duplicate rows. We have 989 rows by 10 columns again. And this is one of those troubleshooting things that we end up doing a lot, more than we really feel like we should. We might go ahead and do like a car count just to see how many rows we're dealing with. And then right after that, we might want to go ahead and say, hey, let's drop duplicates. So remember we did all the duplicates on there. So car equals car dot drop duplicates. And then we can print the head again. We'll just do car head here. And you can see the data on there looks the same as before. And just note that we did car equals car dot duplicates. There are commands in here where you can do, where it changes the actual value. And it works on some of them and not on others depending on what you're doing. But by default, it always returns a copy. So when we do this, we're reassigning it to car. And you can see it's the same header, but we want to go ahead and do count and see how the count changes. Let's go ahead and run this. And you can see here, instead of 11,914, we have 10,925. So we removed about 100 cars that were duplicated, just slightly under 100 there. And then as we're prepping our data, we might want to know car is null. So it's going to count the values of null, and then we want to sum that up. And when we do that, we do the car is null function dot sum. We end up with HP, the horsepower is 69 have null values, and 30 have cylinders have null values. Now, if you don't put the sum at the end, it's just going to return a mask with the true false of is it null or is it not, by 0 and 1. So you're summing up the ones underneath each column. And this, of course, then you have to decide what you're going to do with the null values. There's a lot of different options. It might be that you need to put in the average or means. Maybe you want to put in the median value. There's a lot of different ways to fill it. Usually when you first start out with the data, a lot of them you just drop your null values. And you can see here car.drop NA, which is equal to all, and then we're going to go ahead and count it, and you can see that we've dropped almost another 100 values. So from 10,925 to 10,827. Maybe 75 or so values. So we've cleaned this is really a big part of cleaning data. You need to know how to get rid of your null values, or at least count them, and what to do with them. And of course, if we go back to counting our null values, we should now have null values. There we go. And you'll see there's 0 null values. I don't know how many times I've been running a model that doesn't take null values and it crashes, and I just sit there and look at it trying to get, why did that crash? It should have worked. It's because I forgot to remove the null values. So we've been jumping around a lot. We're going to go back to finding outliers, and let's go ahead and bring that back into our Seaborn. And if you remember, we did a box plot earlier. This time we're going to do a box plot just on the price. And you can see here our price value, and we have the deviation with the 2 thinner bars on each side of the main value. And then as we get up here, we have all these outliers. In fact, we have one way out here that's probably a really expensive high-end car is what we're looking at. If you were doing fraud analysis, you would be jumping on all over these outliers. Why are these deviation from the standard? What are these people doing? Again, this is probably, like I said, a really high-end expensive car out here. That's what we're looking at. And we can also look at the box plot for the horsepower. And we'll put that in down here and run that. And you can see again, here's our horsepower, and it just jumps, and there's these really odd, huge muscle cars out here that are outliers. And we're going to jump into making this a little bit more, as you start displaying your data or your information to your shareholders. We're going to look at plotting a histogram for the number of cars per brand. And the first thing we want to go ahead and do is we have with our car, go back over here, here we go. We have our make value counts, largest plot, and we want to do a kind equals bar, figure size 10.5. And right off the bat, we jump up here and we see Chevrolet, it's going against, what was it? It's figure ratio, the value counts, and we want the largest value. So here's our value counts and compared to what the different cars are. Chevrolet puts out a lot of different kinds of cars. I didn't realize that they made that many cars or different types. And then for readability, let's go ahead and add a title, number of cars by make, number of cars, and make. If you had looked at this the first time, you would have been like, well, what the heck am I looking at? Well, we're looking at the number of cars by make. And then you can see here, now we're talking about the type of cars and the different ones that are put out. Lotus, I guess, only had a few different kinds of cars over there. Very high-end cars. And then as doing data analytics and as a data scientist, one of the things I am most interested in is the relationship between the variables. So this is always a place to start. We want to know what's going on with our variables and how they connect with each other. So the first thing we're going to do is we're going to go ahead and set a figure size because we want to make sure it fits our graph. We'll just go ahead and set this one plot figure set to figure size 2010. If you never used the matplot library, which is sitting behind Seaborn, whatever is in the PLT, this is what's loaded. It's like a canvas you're painting on. So the second you load that PyPlot as PLT, anything you do to that is affecting everything on it. And then we want to go ahead, since we're using Seaborn, we'll go ahead and create a variable C for relationships or correspondence, and car.corr. That's a correlation in Seaborn on top of pandas. Again, one line and you get the whole correlation on there. And because we're working with Seaborn, let's put it into a nice heat map. If you're not familiar with heat maps, that means we're just using color as part of our setup. So we have a nice visual. And we can see here that the Seaborn connected to the pandas prints out a nice chart. We'll talk a little bit about the color here in a second. It prints out a nice chart. This is a chart I look at. As a data scientist, these are the numbers I want to look at. And we'll just highlight one of them. Here's cylinders versus horsepower. The closer to 1, the higher the correlation. So 0.788 pretty high correlation between the number of cylinders and how heavy the horsepower is. I'm betting if you looked at the year versus horsepower, we can just look at that one. Here's year and horsepower. 0.314, not as so much, but if you combine them, you don't actually add them. But if you combine them, you'll start to see an increase in horsepower per year and cylinders. You could probably get a correlation there. And just like 0.78 is a positive correlation, you might notice if we look at cylinders, or let's look at horsepower and mileage. So if we go here to horsepower to mileage, you get a nice negative. We'll do cylinders, that's a bigger number. With cylinders to the miles per gallon, it's a minus 0.6. So it's a negative correlation. The closer to -1, the more the negative correlation is. And then the chart you would actually show people is a nice heat map. This is all our colors, and it's just those numbers put into a heat map. The darker the color, the higher the correlation. You can see straight down the middle, obviously the year correlates directly with the year, horsepower with horsepower, and so on. That's why it's a 1. The closer to the 1, the higher the correlation between the two pieces of data. Now, this is a good introduction. Pandas goes way beyond this. Most of the functionality in NumPy, since Pandas sits on it, is also in Pandas, and then it even has additional features in it. And we use Seaborn pretty extensively sitting on top over our PyPlot. So keep in mind that our PyPlot has a ton of other features in it that we didn't even touch on in here. We couldn't, even if you had a sole course in it, there's just so many things hidden in there depending on what your domain you're working on. But you can see here, here's our Seaborn and here's our Matplot library. That's all our graphics that we did. And then the Seaborn works really nicely with the Pandas. We really like that.
Feeling inspired already? Not one, but we have multiple success stories to share if you are inspired. Consider checking the Simplilearn's postgraduate program in data analytics offered by Purdue University. For more details, use the link in the description box below. The link should redirect you to the official course landing page that will give you a complete overview of the course being offered. Also, if you are a complete beginner and an aspiring data analyst looking for online training and certifications in collaboration with leading experts, then search no more. Simplilearn's Data Analysis Master's program should be your right choice. For more details, use the link in the description box below.
So currently I am on my MySQL workbench. Let me connect to the local instance. So I'll give my password. I'll click on OK. Alright. So this is my MySQL workbench query editor. So first we are going to learn subqueries. Let me give a comment and write subqueries. Alright. So first of all, let's understand what a subquery is. So a subquery is a query within another SQL query that is embedded within the where clause, from clause, or having clause. So we'll explore a few scenarios where we can use subqueries. So for that, I'll be using my database, that is SQL_intro. So I'll write my command use SQL_intro. Now this database has a lot of tables. I'll be using the employees table that is present inside SQL_intro. Let me just expand this, and you can see here we have an employees table. So let me first show you the contents within this table. I'll write select star from employees. Let me execute it. Okay, you can see here we have the employee ID, employee name, age, gender, there's date of join, department, city and salary, and we have information for 20 employees. If I scroll down, you can see there are 20 employees present in our table. So let's say you want to find the employees whose salary is greater than the average salary. In such a scenario, you can use a subquery. So let me show you how to write a subquery. I'll write the select statement. In the select statement, I'll pass my column names that I want to display. So the column names I want are the employee name. Then I want the department of the employee and the salary of the employee. From my table name, that is employees. Next, I'll use a where condition where my salary should be greater than the average salary of all the employees. So I'll write salary greater than. After this, I'm going to write my subquery. So I'll give select average of salary from my table name, that is employees, and I'll close the bracket and give a semicolon. So what it does is, first it is going to find the average salary of all the employees that are present in our table. Once we get the average salary number, we'll use this where condition where salary is greater than the average salary number. So the inside subquery, let me run it first. If I run this gives you the average salary of all the employees, which is $75,350. Now I want to display all the employees who have salary greater than $75,350. So let's run our subquery. There you go. So there are 8 employees in our table who have a salary greater than the average salary of all the employees. Alright. Next, let's see another example. Suppose this time you want to find the employees whose salary is greater than John's salary. So we have one employee whose name is John. Let me run the table once again. Okay, if I scroll down, you see we have an employee as John. You see this? Our employee ID 116 is John and his salary is $67,000. I want to display all the employees whose salary is greater than John's salary. So basically all the employees who are earning more than $65,000, I want to print them. So let's see how to do it. I'll write select, I want the employee name, comma, the gender of the employee. I also want the department and salary. From my table name, that is employees, I'll write where salary is greater than, I'll start my opening bracket. Inside the bracket, I'm going to give my inner query, that is select salary from employees where the employee name is John. So within single quotations, I'll give John as my employee. I'll end with a semicolon. So let me first run my inner query. So this will give us the salary that John has, which is $67,000. Now I want the employees who are earning more than $67,000. So let's run our subquery. Okay, so you can see 12 rows returned, which means there are 12 employees in our table who are earning more than $67,000. You see here, all these employees have a salary greater than $67,000. Okay. Now, you can also use subqueries with 2 different tables. So suppose you want to display some information that are present in 2 different tables, you can use subqueries to do that. So for this example, we'll use a database that is called classic models. You can see the first database. So let me use this database called classic models. I'll write use classic models. Now this database was actually downloaded from the internet. There's a very nice website. I'll just show you the website name. So this is the website, that is mysqltutorial.org. You can see here they have very nice articles, blogs from where you can learn MySQL in detail. So we have downloaded the database, that is classic models, from this website. You see here they have a MySQL sample database. If you click on this, it will take you to the link where you can download the database. So they have this download link which says download MySQL sample database, and the name of the database is classic models. Alright, so we are going to use this classic models database throughout our demo session. If I expand the tables section, you can see there are a lot of tables that are present inside this classic models database. We have cricket, customers, there's employees, office, there's orders, order lines, and many more. So for our subquery, we'll be using 2 tables, that is order details and products table. First let me show you the content that is present inside the products table first. If I run this, you see here it says 110 rows returned, which means there are 110 different products that are present in our table, which has the product code, the product name, product line. We have the product vendor, description, quantity in stock, buy price, MSRP. The other table we are going to use is order details, which has the details of all the orders. Let me show you the records order details tables has. Okay, so there are 1000 records present in this table. You have the order number, the product code, quantity ordered, price of each item. You have the order line number as well. Okay, now we want to know the product code, the product name, and the MSRP of the products whose price of each product is less than $100. For this scenario, we are going to use two different tables and we are going to write a subquery. Okay, so if you see here in the order details table, we have a column called price each. I want to display the product code, the product name, and the MSRP of the products which have a price of each product less than $100. So the way I'm going to do is, I'll write select product code, comma, product name. Now one thing to remember, that this product name is actually present inside our products table, and product code is present in both the tables, that is products and order details. Here you can see this is the product code column, comma, MSRP, which is present inside the products table again, from my table, that is products, where I'll write product code. I'm going to use the in operator. Next, I'll write my inner query, that is select product code from my table order details, where my price of each product is less than $100. Let me run this. Okay, so you can see there are total 83 products in our table which have a price less than $100. You can see the price here. Okay, now we learn another advanced concept in SQL which is known as stored procedures. I'll just give a comment saying stored procedure. Okay, so first let's understand what is a stored procedure. A stored procedure is an SQL code that you can save so that the code can be reused over and over again. So if you want to write a query over and over again, save it as a stored procedure and then call it to execute it. So in this example, I want to create a stored procedure that will return the list of players who have scored more than 6 goals in a tournament. So I have a database called SQL_IQ. These are a few databases that I have already created. So this database has a table called players. If I expand the tables option, you see we have a table called players, and you can see the columns player ID, the name of the player, the country to which the player belongs to, and the number of goals each player has scored in a particular tournament. So I'll write a stored procedure that will return the list of top players who have scored more than 6 goals in a tournament. So first of all, let me begin by using my SQL_IQ database. We'll run it. So now we are inside the SQL_IQ database. Let me select star from players to show the values that we have in the players table. You can see there are 6 players in our table. We have the player ID, the names of the players, the country to which these players belong to, and the goals they have scored. So I'll write a stored procedure. So the stored procedure syntax is something like this. It should start with a delimiter. Okay, in the delimiter I'll write ampersand ampersand. Next I'll write create procedure followed by the procedure name. Let's say I want to name my procedure as top_players. Next statement is begin. After begin I'll write my select statement. I want to select the name of the player, the country, and the goals each player has scored from my table, that is players, where I'll write goals is greater than 6. I'll give a semicolon. Then I'll end my procedure with a delimiter that was double ampersand. Next I'll write delimiter and give a semicolon. Now the semicolon suggests this is a default delimiter. And there should be a space. Okay. Now let's run our stored procedure. There you go. So you have successfully created our stored procedure. Now the way to run a stored procedure is you need to use the call method and give the procedure name, that is top_players in our case, with brackets and a semicolon. Let's execute it. Okay, there is some problem here. So we made a mistake while creating a procedure. The name of the column is goals and not goal. Let me create that procedure again. Okay, it says the procedure top_player already exists. Let's just edit the procedure name. Instead of top player, we'll write it as top players, and similarly we'll edit here as well. Now let's create it again. Okay, now to call my procedure, I'll write call space followed by the procedure name, which is top_players. If I run this, you can see we have 2 players in our table who have scored more than 6 goals. So we consider them as the top players in a particular tournament. Alright. Now there are other methods that you can use while creating a stored procedure. One of the methods is by using an in parameter. So when you define an in parameter inside a stored procedure, the calling program has to pass an argument to the stored procedure. So I'll give a comment stored procedure using in parameter. Alright. So for this example, I'll create a procedure that will fetch or display the top records of employees based on their salaries. So we have a table in our SQL_IQ database which is called employee details. I'm going to use this table. You can see we have the name of the employee, the age, sex, then we have the date of join, city and salary. Using this table, I'll create a procedure that will fetch or display the top records of employees based on their salaries, and we'll use the in parameter. So let me show you how to do it. I'll write delimiter. This time I'm going to use /. I'll write create procedure followed by the procedure name. Let's say SP for stored procedure, sort by salary is the name of my procedure, and inside this procedure I'll give my parameter in. I'll create a variable var and assign a data type integer. Then I'll write begin followed by my select statement, where I'll select the name, age, salary from my table name, that is EMP details or employee details. I'm going to order this by salary descending, and I want to display limited number of records. So I'm using this limit keyword and my variable var, which I created here. I'll end my select statement. I'll end my stored procedure with / and I'll go back to my default delimiter, that is semicolon. Alright, so let me run this. There should be a space here. Alright, so let's run this. Okay, you can see we have successfully created our second stored procedure, which is sp_sort by salary. Now you can also check whether the stored procedure was created or not. Here you have an option to see the stored procedures. Let me just refresh this, and you can see we have 3 stored procedures that we have created so far. One is sp_sort by salary, the other two were top_player and top_players. Okay, now let's call our stored procedure. I'll write call space followed by the stored procedure name, which is sp_sort by salary, and inside this I'll give my parameter, which was actually var, and this var we have used in limit. Let's say I want to display only the top 3 records of the employees who have the top 3 highest salaries. Okay, so let me run it. There you go. So Amy, Sarah and Jimmy were the top 3 employees who have the highest salary. So you saw how you could use the in parameter in a stored procedure. We created a variable, and that variable we used in our select statement, and we called our stored procedure and passed in that variable. Okay. Now, instead of a select statement inside a stored procedure, you can also use other statements. Let's say update. So I'll create a stored procedure to update the salary of a particular employee. So in this procedure, instead of select statement, we'll use the update command. In this example, we'll use the in operator twice. So let me show you how to do it. I'll write my delimiter first, which is going to be /. Then I'll write create procedure. My name of the procedure is going to be update salary, and inside the update salary name I'll write in, and then temp underscore name, which will be a temporary name variable, and the type I'll assign is varchar 20. I'll again use my in parameter. I'll write in. Next, my other variable would be new underscore salary, and the data type would be float. I'll write begin and write my update command or update statement. I'll write update table name, that is employee details, set salary equal to new underscore salary, where name is equal to my temporary variable, that is temp underscore name. So this is my update command, and I'll end the delimiter. Alright, so let's run this. Okay, we have successfully created our stored procedure. If I refresh this, you can see I have my stored procedure update underscore salary. Okay, now let's say, first of all, I'll display my records that are present inside employee underscore details table. Okay, so we have 6 rows of information. Let's say you want to update the salary of employee Jimmy, or let's say Mary, from 70,000 to let's say 72,000. or let's say 80,000. So I'll call my stored procedure, that is update underscore salary, and this time I'm going to pass in two parameters. The first parameter will be the employee name, and next with a comma I'll give my new salary that I want to. So my employee name, let's say, is Mary, and the salary I want to be updated is, let's say, $80,000. I'll give a semicolon and I'll run it. You can see it says one row affected. Now let's check our table once again. There you go. If you see this record, for Mary we have successfully updated the salary to $80,000. Now moving ahead, we learn to create a stored procedure using the out parameter. So I'll give a comment, stored procedure using out parameter. Okay, so suppose we want to get the count of total female employees. We will create total employees as an output parameter, and the data type would be an integer. The count of the female employees is assigned to the output variable, which is total underscore EMPs, using the into keyword. Let me show you how to write a stored procedure using the out parameter. So first I'll declare my delimiter, 2// I'll write create procedure followed by the procedure name. It is going to be sp underscore count employees, and inside this I am going to give my out parameter and the variable name, that is total underscore EMPs, which is total employees, and the data type will be integer. Next I am going to write begin followed by my select statement, that is select. I want the count of total employees, and the output I am going to put into my new variable, that is total underscore EMPs. From my table, that is EMP underscore details, where sex is equal to F, which means female, I'll give a semicolon. Next I'll end it with the delimiter, and I'm going to change the delimiter to a default delimiter, that is colon. So let me tell you what I am doing here. I'm creating a new stored procedure, that is sp underscore count employees. Using this stored procedure, I am going to count the total number of female employees that are present in our table EMP underscore details. So I've used my out parameter and I'm creating a new variable called total underscore EMPs. The data type is integer. Here in the select statement, I'm counting the names of the employees, and the result I am storing it in total underscore EMPs. I have used my where condition where the gender or the sex is female. So let's run this. Okay, so we have created our stored procedure. Let's refresh this. Okay, you can see we have our new stored procedure, sp underscore count employees. Now to call it, I'll write call the name of the procedure, that is count underscore sp underscore count employees. Within brackets, I'll pass in the parameter as @f underscore emp. I'll give a semicolon. Then I'll write select @f underscore emp as female employees. Okay, so as is an alias name, let's run this one by one. First I'll call my procedure and then we'll display the total number of female employees. You can see in our table we have 3 female employees. Alright, now with this understanding, let's move on to our next topic in this tutorial on advanced SQL. Now we are going to learn about triggers in SQL. So I'll give a comment here, triggers in SQL. So first, let's understand what is a trigger. So a trigger is a special type of stored procedure that runs automatically when an event occurs in the database server. Now, there are mainly three types of triggers in SQL. We have the data manipulation trigger, we have the data definition trigger, and login triggers. In this example, we will learn how to use a before insert trigger. So we will create a simple students table that will have the student's roll number, the age, the name, and the student's marks. So before inserting the records to our table, we'll check if the marks are less than 0. So in case the marks are less than 0, our trigger will automatically set the marks to a random value, let's say 50. So let's go ahead and create our table, that is students. Alright. So I'll write create table student . Now this table will have the student roll number, the data type is integer, it will have the age of the students, again the data type is integer, we have the names of the students, so the third column would be name, the data type would be variable or varying character, size I am giving it as 30, finally we have the marks as floating type. So let's create this table which is student. So we have created our table. Now I'll write my trigger command. So trigger command will start with delimiter like how our usual stored procedures have. Next, this time I'll write create trigger. Then you need to give the name of the trigger, that is mark underscore, let's say verify. I'm going to use a before insert trigger, so I'll write before insert on my table name, that is student. Next I'll write for each row if new dot marks is less than 0, then we'll set new dot marks equal to 50. So this is my condition. First we'll check before inserting if any student has marks less than 0, we'll assign a value 50 to that student, because usually the marks are not less than 0 in any exam. I'll write end if semicolon and I'll close the delimiter. So this is my trigger command. I'll run it. It says trigger already exists. So in this case we need to update the trigger name. Let's say I'll write marks underscore verify underscore student for ST. Let's run it again. Okay, there is an error here because in our table the column name is mark and not marks. So here we need to change it as mark instead of marks. Alright, let's run it. Okay, so we have created our trigger. Now let me insert a few records to the student table. So I'll write insert into student. I'll write values. I'll give the values as 501, which is the student roll number. The age is, let's say, 10. The name is, let's say, Ruth. And the marks is, let's say, 75.0. Give a comma. We'll insert our second student record. Student roll number is 502. Age is 12. The name is, let's say, Mike. And this time I'm purposely giving a value of minus 20.5. Give another comma. We'll insert the third record. For student, roll number 503, age is 13, the name is Dave, and let's say the marks obtained by Dave is 90. Now we'll insert our final record for student number 504. The age is 10. Name I'll enter as Jacobs. And this time again I'm purposely giving the marks in negative 12 point, let's say 5. I close the bracket and give a semicolon, and I'll run my insert statement. Okay, so we have inserted 4 rows of information to our student table. Now let me run the select query. I'll write select star from student. If I run this, you see the difference. There you go. So originally we had inserted for 502 the marks was minus 20.5, and for 504 for Jacobs the marks was minus 12.5. Our trigger automatically converted the negative marks to 50, because when we created our trigger we had set our marks to 50 in case the marks were less than 0. So this is how a trigger works. Now you can also drop a trigger or delete a trigger. You can just write drop trigger followed by the trigger name. In this case our trigger name is marks underscore verify underscore st. I'll just paste this here, and if you run this it will automatically delete your trigger. I'll give this as a comment. Okay. Now moving on. Now we are going to learn about another crucial concept in SQL which is very widely used. This is known as views. So views are actually virtual tables that do not store any data of their own but display data stored in other tables. Views are created by joining one or more tables. I'll give a comment as views in SQL. Okay. Now to learn views, I am going to use my table which is present inside Classic Models database. Now this database, as I mentioned, we had downloaded it from the internet. So first of all, let me write use Classic Models. So I'll switch my database first. Alright, now we are inside Classic Models. So here let me show you one of the tables which is called customers. So I'll write select star from customers. Okay, I missed S here. Let's run it again. So this is my customer table which is present inside Classic Models database. It has the contact last name, the contact first name, the customer name, customer number, we have the address, state, country, and other information. Now I'll write a basic view command using this customer table. The way to write is I'll write create view followed by the view name which is cust underscore details. Then you write as select. I'm going to select a few column names from my original customer table which is this one. So I need the customer name. Let's say I need the phone number and the city. So you have this information here. You have the phone number and the city. Alright. I'll write from my table that is customers. If I run this, my view that is cust details will be created. Let's run it. There's some error here because the name of the table is customers and not customer. I'll give an S and I'll run it again. Alright, so you can see we have created our view, and to display the contents that are present inside our view, I can write select star from followed by the view name that is cust underscore details. Let's run it. There you go. So we have the customer name, the phone number and the city of the different customers that we have in our table. Alright. Now let's learn how you can create views using joins. So we'll join two different tables and create a view. So for that I'm going to use my products table and the products lines table. I'm talking about the products table and the product lines table present inside classic models database. So before I start, let me display the records that are present inside the products table. Let's run it. So these are the different products you can see here. Now let's see what we have in product lines table. So we have the product line, the text description, and there is some HTML description and image. So I'll create a view by joining these two tables and will fetch specific records that are present in both the tables. So let me first start by writing create view followed by the view name, that is product underscore description, as I'll write select product name, comma, then I'll write quantity in stock. I also want the MSRP. Now these three columns are present inside the products table, and next from the product lines table I want the text description of the products. So I'll write from products table, I'll give an alias as P followed by inner join my other table, that is product lines, as let's say PL on the common column, that is product line. So P dot product line is equal to, I'll give a space, PL dot product line. Okay, so here we have used an inner join to fetch specific columns from both the tables, and our view name is product underscore description. Let us run it. Alright, so we have our view ready. Now let me view or display what is present inside our product underscore description view. I'll write select star from product underscore description. Let's run it. There you go. So we have the product name, the quantity in stock, MSRP, and textual descriptions of the different products in the table. Okay, now there are a few other operations that you can perform. Let's say you want to rename a view. Instead of product underscore description, you want to give some other name. So I'll just give a comment, rename description. So to rename a description, you can use the rename statement. I'll write rename table product underscore description, which is my old name. I want to change this name to, let's say, I'll give vehicle description, since all our products are related to some of the other vehicle. So I'll write vehicle description. Okay, let us run it. Alright, so here you can see I have renamed my view. So here if I just refresh it and I'll expand this, you can see we have the cost details view and we have the vehicle underscore description view. Okay, now either you can view all the views from this panel or you can use a command. Let's say I'll write display views is the comment. Now to show all the views, you can use show full tables, where table underscore type is equal to, within single quote I'll write view. So this is the command that will display all the views that are present inside a database. There is some error here. Let's debug the error. this should be okay. So instead of table types, it should be table type equal to view. Let's run it. You can see the two different views that we have. One is customer details, another is vehicle underscore description. Okay, now you can also go ahead and delete a view. For that you can use the drop command. So I'll write drop view followed by the view name. Let's say I want to delete customer underscore details or cust underscore details view. I'll write drop view cust underscore details. Let's run it. You can see here we don't have the cust underscore details view anymore. Alright. Now moving to our final section in this demo. Here we will learn about Windows functions. Now, Windows functions were incorporated in MySQL in the 8.0 version. So Windows function in MySQL are useful applications in solving analytical problems. So using the employees table present inside my SQL underscore intro database, so we'll find the total combined salary of the employees for each department. So first let me switch my database to SQL underscore intro database. I'll run it. Okay. I'll display my table, that is employee. So here we have 20 employees in our table. Using this table, we are going to find the combined salary of the employees for each department. So we'll partition our table by department and print the total salary. And this we are going to do using some Windows functions in MySQL. So I'll write select. I want the employee name, the age of the employee, and the department of the employee, comma. Next I'll write the sum of salary over. I want to partition it by department. So I'll write partition by department, which is DEPT, and I'll give an alias as total salary, so that it will create a new column with the name total salary from my table, that is employees. The output will be a little different this time. Let's execute it and see the result. There you go. So here we have created another column in our result, that is total salary, and for each of the employees and the respective departments we have the highest salary. So in finance, the highest salary of one of the employees was $155,000. Similarly, if I come down, we have the highest salary from HR. If I scroll further, we have the highest salary from IT, marketing, product, sales, and the tech team. Alright. Now we'll explore a function which is called row number. Now the row number function gives a sequential integer to every row within its partition. So let me show you how to use the row number function. I'll write select row underscore number function over my column would be salary. So I'll write order by salary. I'll give the alias as row num, give a comma, and I want to display the employee name and the salary of the employee from my table, that is employees, and I'll order by salary. So let's see how our row number function will create sequential integers. Okay, you can see here we have a row num column and we have successfully given row numbers to each of the records. You can see it starts from 1 and goes up till 20. Okay. Now this row number function can be used to find duplicate values in a table. To show that, first I'll create a table. I'll write create table. Let's say I'll give a random name, that is demo. And let's say we have in this table the student ID which is of type integer, and we have the student name which is of type varchar. The size is 20. I'll create the small table with a few records. Let's create this table first. Now we are going to insert a few records to our demo table. So I'll write insert into demo values. I'll give 101. The name is Shane. Give a comma. I'll insert the second student name 102. The name is Bradley. I'll give a comma. This time for 103 we have two records. Let's say the name of the student is Herath. I'll give a comma. I'll copy this and we'll paste it again. So we have duplicated 103. Next we have 104. The name of the student, let's say, is Nathan. Then again, let's say for the fifth student, which is Kevin, we have two records. I'll copy this and I'll paste it here. Let me give a semicolon and we'll insert these records to our table demo. Alright. Now let me just run this table for you. I'll write select star from demo. If you see this, we have a few information that are duplicated in our table, that is for student ID 103 and student ID 105. Now I am going to use my row number function to find the duplicate records present in my table. I'll write select student underscore ID comma student underscore name. I'll give another comma and write row underscore number over within brackets. I'll write partition by st underscore id comma st underscore name. Okay, then I'll write order by st underscore id, close the bracket. I'll give an alias as row num from my table, that is demo. Let's just run it. You can see here, okay, let me just delete n from here and do it again. Alright, now if you see here, there is just one student in the name Shane. We have one student in the name Bradley. But here if you see for Herath, the second record it says 2, which means there are two records for Herath. And if I scroll down, there is one record for Nathan and there are two records for Kevin, which means Kevin is also repeated. Okay, now we are going to see another Windows function that is called rank function in MySQL. So the rank function assigns a rank to a particular column. Now there are gaps in the sequence of ranked values when two or more rows have the same rank. So first of all, let me create a table, and the name of the table would be a random name. We'll give it as, let's say, demo1, and it will have only one column, let's say variable a of type integer. We'll create this table first. Okay, now let's go ahead and insert a few records to our table, which is demo1. So I'll write value 101, 102, let's say 103 is repeated. I'm doing this purposely so that in the output you can clearly distinguish what the rank function does. Next we have 104, 105, we have 106, and let's say 106 is also repeated. Finally we have 107. Okay, Let me insert these values to my table, that is demo1. Okay, this is done. Now if I write select var underscore a and use my rank function, I'll write rank over, then I'll order by my variable, that is var underscore a, as an alias name, let's say test rank, from my table, that is demo1. Let me execute this and show you how the rank function works. Now if I run this, there you go. So here if you mark, so for variable a101 the test rank is 1, for 102 the test rank is 2, but for this value which is 103 the test rank is repeated because there was a repetition for 103. So we have skipped the rank 4 here. For 104 the rank is 5 now, for 105 the rank is 6 now. For 106 again, since the record was repeated twice, we have skipped the 8th rank and our rank function has assigned the same value which is 7 for 106, and for the last value 107 the rank is 9. Alright. Now moving ahead, we'll see our final Windows function which is called first value. So first value is another important function in MySQL. So this function returns the value of the specified expression with respect to the first row in the window frame. Alright. So what I'm going to do is, I'm going to select the employee name, the age and salary, and I'll write first underscore value, which is my function, and pass in my employee name, and then I'll write over order by my column, that is salary descending. I'll give an alias as highest underscore salary from my table, that is employees. So let me run this and see how the first underscore value function works. Alright, so in our table Joseph was the employee who had the highest salary, which was $115,000. So the first value function populated the same employee name throughout the table. You can see it here. Now you can also use the first underscore value function over the partition. So let's say you want to display the employee name who has the highest salary in each department. So for that you can use the partition. I'll write select emp underscore name, comma, I want the department and the salary, comma, I'll use my function, that is first underscore value, followed by the name of the employee inside my first value parameter. I'll write over, here I'm going to use partition. I'm going to partition it by department, since I want to know the employee name who has the highest salary in each department. And I'm going to order by salary descending, and I'll give my alias again as highest salary from my table, that is employees. So let's run this and see the difference in the output. Okay, so as you can see here, we have the employee who had the highest salary from each department. So for finance, Jack had the highest salary. From HR it was Marcus. Similarly in IT it was William. If I scroll down, for marketing it was John. For product it was Alice who had the highest salary. Similarly in sales we had Joseph, and in tech we had Angela. So this is how you can use the first underscore value function using partition. Alright, So that brings us to the end of this demo session on our tutorial. So let me just scroll through and show you what we did from the beginning. First, we learned about subqueries in SQL. So we initially wrote a simple subquery, and then we used our classic models database, which was downloaded from the internet. I'd also shown you the link from where you can download this database. Here we used two different tables and we performed a subquery operation. We learned how to create stored procedures. So we learned how you can use the in operator or the in parameter as well as the out parameter in stored procedure. After stored procedure, we learned another crucial concept in SQL, which is called triggers. Now triggers are also a special kind of stored procedures. So we saw how to write a before insert trigger. You can see it here. Next, we learned how to delete a trigger. We also saw how to work with views in SQL. So views are basically virtual tables that you can create from existing tables. We also saw how you can use views using two different tables and an inner join. And we learned how to display views, how to rename view names, how to delete a view, and finally we explored a few Windows functions.
So let's discuss what's in it for us today. Now, we will first talk about why Power BI, why it's a popular tool and what problem it solves, what is Power BI, and what are the primary features of Power BI, which you can use in your day-to-day data analytics, visualizations, creating fancy reports, creating meaningful, intelligent reports for your organization, for your personal use, for crunching numbers, for generating reports real time, etc. Now, the most popular tool for Power BI is the Power BI desktop. I'll show you certain aspects of Power BI desktop, and then I'll show you the steps how to install Power BI desktop on your machine. And then definitely Power BI desktop is a free tool provided by Microsoft, but then you can also subscribe for an enterprise version, which is primarily used by enterprises for publishing their data. So we'll see the difference, and then overview of dashboards which can be created. What kind of dashboards can be created in Power BI. So this is the agenda for us today. Now, why Power BI? So generally, visualization tools, reporting tools are required in order to create and prepare and analyze meaningful data. It could be a data for an organization. It could be a social media platform data. It could be a data from IoT devices, but something which needs to be analyzed, and some intelligent inferences and data mining has to be done on top of it. Now imagine today we are in a world where terabytes of data and information is getting generated on an instantaneous basis, on minute by minute basis. So it becomes very essential to churn out something meaningful, something intelligent out of it. In the market, there are a lot of other tools which are available like Killix, Alteryx, Tableau, and Power BI. So Power BI is a Microsoft product, which is one of the most popular products, and it comes as a free to download product, Microsoft Power BI desktop, which is available, and I'll show you a couple of ways how you can install it on your machine. But why Power BI is popular is because it provides a lot of out-of-the-box features, drag and drop features, which we will talk about in our subsequent sessions and classes. But today's session is primarily focused on giving you guys an introduction on what is the purpose of Power BI and what all problems it solves in the real world. So Power BI allows you to view, analyze, and visualize huge quantities of data, and the data could be in any format: Excel, CSV, text, or it could be a direct connection to a database like SQL, MySQL, Azure, Oracle, anyone, IBM DB2. So it supports n number of data types or data sets, and it's very powerful in terms of data connectivity. So it uses powerful compression algorithms to import and cache the data within the .pbix file. So it's as convenient as a simple software. If suppose you import a data and then you prepare a report, and then you can easily share the reports with your peers or someone who's co-developing with you, either through Power BI cloud services, or even you can share the PBIX file in an email or through any other means, and you can share the data set with the concerned, and they can then work on the report independently. So there are different ways. There is no kind of a limitation for working on Power BI. There are multiple ways, and it is very fast. It is the most fast tool to work with Excel, because definitely Excel is also a Microsoft technology, so it works very fast on Excel based data and gives you numbers and reporting at a very high speed. So now once you have imported the data, Power BI allows you to model the data, allows you to work intelligently on the data. It allows you to model the data in a way that if you are importing data from multiple Excel sheets, importing data from multiple tables, you can easily create a relationship between those tables or data sets in Power BI, and then create visually appealing reports, meaningful reports, as I've been emphasizing, and make sense out of that data. No data in silos is of any use. Data in silo means a single worksheet or a single data set will not churn out any meaningful information until and unless you basically join it, club it, merge it, union it, append it with some other data sets, because a single data set will never be able to hold that much amount of information which is generally required for a important report. So it has easy drag and drop functionality with features that allow you to copy all formatting across similar visualizations. So just like in Microsoft Excel we use Format Painter to copy the format of one cell to another, similar features, very similar to Excel products or Microsoft products, they have provided that if you have applied a particular theme on a report, you can easily replicate that on any other report. The font, the header size, the background color, you don't need to do it again and again. So there's a lot of reusable features which are also available. Okay, now as I said, Excel is a Microsoft product, Power BI is a Microsoft product, so they have intercompatibility. You can publish data from Excel to Power BI. Now with the latest developments and enhancements, as of today, Excel has also plugged in a new feature called Power Pivot, which I'll show you later down the line. But that also allows you to do a quick analysis. You can't create, of course, complex reports or fancy reports like Power BI, but Power Pivot allows you to create, quick measures, quick functions, quick calculations on your data quickly only in Excel. So it's an Excel plugin. But whereas, Power BI is also compatible with Excel. So when you create a report in Power BI, it gives you inbuilt feature to export your Power BI report into Excel format directly. You don't need to do any programming for it. Also, you can easily publish, when you publish your Power BI reports, it allows you to give some inbuilt intelligence of analyzing your reports in Excel, and it gives you all those features of exporting your Power BI reports into Excel, which is not available in any other tool, or otherwise those tools have to create plugins, create add-ins, and probably they might charge for it. But Power BI comes with a lot of out-of-the-box features which are very, very helpful for analyzing data in Excel, and vice versa. Azure Cloud. Now Azure itself again is a Microsoft Cloud tech stack. So using Power BI with Azure allows you to analyze and share large volumes of data. So Azure, basically Azure database or Azure cloud servers are meant to hold huge amount of data, and Power BI allows you to have seamless connection. You can easily connect to Azure Data Lake. You can reduce the time it takes to get insights and increase collaboration between business analysts, data engineers, and data scientists. So Azure Data Lake becomes the central focal point where all your analysts, engineers can keep working on the centralized piece of data and churn out their reports. Data scientists' primarily job is to keep the data in a structured way, optimized way, optimize the input-output operations, disk operations, and memory utilization so that the reports also get churned out in a faster manner. So every person has their own role in order to give a quick refreshable report, a quick rendered report. Any report which is taking huge amount of time to get rendered will not eventually be used by the business users, because then it does not solve the purpose. The report should be fast. Report should have appropriate filters, slices and dices. You should be able to create the reports or dynamically, or you should be able to visualize the data dynamically. So all those visualization features are available in Power BI, and it works seamlessly. Either it is small data or huge data. It allows that you to work on those kind of data in a seamless fashion. Right. So this is just a very quick example of how a typical dashboard looks like. Dashboard is nothing but, you have clubbed a couple of multiple reports on a single page, and if you change a filter, a single filter on the page, all the reports will honor that filter and the numbers will change accordingly. So if you see in this example, there is a filter or a drop down of product ID, product name, employee name, or supervisor, or a date range. So whatever date range or filter you will apply, all the reports on this dashboard will get changed based on the filter you have selected. So Power BI allows you to get insights from data and turn insights into action to take data-driven business decision. And that is the ultimate goal of any visualization tool. That is the purpose for which visualization tools are bought and purchased by the organizations, and data is fed into them. Now, Power BI fetches data from factory sensors, social media sources to get access to real-time analytics, so that you are always ready to make timely business decisions. So basically, there is a feature of live connection or cutoff data connection. So either you can work on data which is residing on a machine and you can just work on the cutoff data. Like for example, there's a data which is available for sales 2017, 2018, and you're just working on a historical data. It's a cutoff data. Or it could be possible that you want to be connected live to a real-time IoT based, sensor based data, or social media data like Twitter, Facebook feeds, or you're connected to live Google worksheets. That is also possible. You just need to publish your Google sheet for a public domain, embed the URL into Power BI, and then whoever updates that Google sheet, automatically the Power BI report will also start honoring and consuming the new data which is added in the Google Sheet. So all those kind of real-time streaming analytics is also possible, and that is one big feature and very important feature of Power BI, which is widely used and has a very huge market acceptance and market utilization. Now, what is Power BI? Power BI is a business analytics service provided by Microsoft that lets you visualize your data and share insights, right? So earlier, Microsoft used to have a technology called SSAS. Now they have replaced actually SSAS and SSRS with Power BI. So basically you can use Power BI on the data which is there in your Excel or any other data source, and the Power BI service or Power BI desktop basically creates a connection to those data sets and import it, cache it, and give you a handle to it in order to work with it. So you can create these fancy, meaningful visualizations. Like for example, there is a geographical map. If you are importing data for a country or a continent or a region, Power BI will automatically detect that it's a geographical information and give you a map with latitude, longitude information, and you just need to plot your numbers on the map Either you can use bubbles or either you can use triangles or whatever data structure you want to use, but all the mapping will be available geographically. Then you can create pie charts, which is shown in this visualization. You can create tree maps. You can create cards where you can highlight the most important numbers like sales, total sales of your company across all the regions, or the growth chart, or the month on month sales of your organization, or total number of products or units sold. So whatever is important and to be highlighted for the management to take any meaningful decision or any insights you want to share, Power BI visualization tool, the Power BI visualization chart allows you to drag and drop and create wonderful reports. Okay. So what are the features of Power BI? So Power BI Desktop is something, a standalone tool which you need to install on your machine. It allows you to build reports by accessing data easily. You do not need advanced report designing or query skills to build a report. Though yes, it is beneficial that if you know some SQL programming, analytical programming, or you are aware of advanced features of any analytical tool, that might help you, but that's not a showstopper. You can easily build reports in quick turnaround time without needing any technical background. You just need to have some analytical mindset, and you can create savvy visualization and analytical reports. Stream analytics, as I mentioned, you can create a live connection with any kind of data. It could be IoT, it could be media, social media, it could be Google Docs, it could be any other kind of live connection. It could be a live database connection itself. So any insertions or updations or deletions happening will automatically reflect in your report. Yes, multiple data sources, and that has to be the primary criteria for any tool to be popular. If any visualization tool is limited to certain data sets, then it will not be highly acceptable in the market. And custom visualizations, right? So as I showed you certain examples in the past, in the previous presentation, that feature is very important because someone might want to look at the KPIs from a different perspective. Some management might want to look at the KPIs from a different perspective. So you need to have that capability to create different visualization from the same data set. Now let's take a look at how to install Power BI Desktop on your machine. So basically what you need to do is you need to go to this URL, powerbi.microsoft.com ENUS desktop. Okay, and you need to just enter this. Now you can download it for free. So just click over here and it will open Microsoft Store. So basically now what Microsoft have done in the latest operating systems is that when you are trying to download, you can actually directly go to the Microsoft Store and search for Power BI. So let's wait for a couple of seconds. Right here. So Power BI Desktop in Microsoft Store. For me, it's already installed, so it's asking me to open it. I'll open it in a while, but for anyone who is not installed, he will see the button of install over here, and it will automatically install in your machine, and then you can easily go and open Power BI Desktop. Now if I click open over here, now this is the UI of the Power BI Desktop. I'm not going to go right now in creating reports right away. We will talk about that in a subsequent session with sample data sets, and we will cover the features of Power BI Desktop one by one. But this is what it is. This is the whole tool of Power BI, which is having the visualization pane. All the different visualizations are, can be created from this pane. Then this is the pane which allows you to select the data fields. Then there is a report view, data view, and relationship view, the data model view, where multiple relationships you can create. You can view the data in the grid of the tables which you will create, and the reports. So you can create multiple reports on multiple pages. You can keep adding pages. Either you can create multiple reports on a single page and it will become a dashboard, or you can create separate independent reports on the single page. And these are the menu options which we will talk about. How you can change color scheming, you can do data modeling, you can create new reports, and you can also transform data, which is the biggest feature. Extract, transform, and load the data, apply different logic, changing data types, massaging the information, creating new joins, appending the data, adding new columns, etc., etc. That is what you can do in transform data. So this itself is a whole different world. It's a dedicated topic. So we will talk about that in our subsequent sessions. So what's in it for us today? We will be learning how to connect to data, different data types, data files like Excel, PDF. Then what are the different data importing modes? And then I will also show you practically different sets, how to import them in Power BI and use it for your visualization purpose. Now, what are the steps to connect to data? So now we will go directly into Power BI and try to import one by one few most commonly and popularly used data sets which are most commonly used in a day-to-day activity. Rest, of course, there are Power BI supports n number of data sources, but we will do something practical on the most popular ones. So let's open our Power BI. Now this is my Power BI, and first I want to show you that how can I import data directly from a web page and import the data. Now it is asking for a URL in order to import data. So what I have done is I have created a Google Excel sheet with simple data with rows and columns, and what I have done is I have shared this sheet as publish to web. Okay, so you just need to say publish to the web, the link as web page, and say done. It's automatically published, and say link. So copy the link which you have published on the web, copy this link, and then go back to your Tableau, paste that link over here and click OK. Now Power BI will try to establish a connection with this Google Doc sheet because it's published on the web. You need to wait for a while it is reading. Okay, now it has read one of the HTML tables, so I'll select this one. Now you can see it is showing me a preview of the table which is there on my Google sheet, right? It has 11 rows, so it has all showed all the 11 rows. So now I can go and transform this data because I can see my headers are there starting from the second row. So there is an opportunity for me to transform the data. So I'll go and transform it so that it looks clean. Okay, so first is I need to remove the first row, which is the null row. Remove the top rows. Okay, and then I need to use the first row now as a header. So you just click this option, use first row as headers. That's it. So now if you see my row ID, order date, ship date, all my data is now ready. So I can say close and apply. Click apply changes. Now this is an example of web data import. You can go and preview your data, right? Now, the biggest advantage of this data connection is that it's a live data. So for example, I insert another row. Let me change the order ID. I've changed some basic stuff, and it's auto saved. Control S. Now I'll go to my Tableau and I'll refresh. Now you can see as I refreshed my Power Query editor, I clicked refresh all and I got my new row which is there in the live data. I got that fetched from my, okay, I got that row, the row ID number 12. So I have to say close and apply. Now you can see the new row, the row number 12 is now available in my new data set, in the data set, because it's a live connection. It's a live connection with the web-based Google Sheet. Okay, so this is one important way in which you can import data. Now let's try to import data from a text file. Now I have already prepared a text file called subcategories.txt. Now let me just open it in a notepad. Now it's a very plain simple file, tab separated file in which you have product subcategory ID, subcategory name and product category key. So basically to which product category this particular subproduct belongs to, right? So what I'm going to do is I'm going to go back to my get data option and I'm going to select text/CSV option and I'm going to select option mod product subcategories.txt. Okay, so now Power BI has identified that it's a tab delimited file, it has recognized the headers, etc., right? And I can now directly load this file. Okay, so now once the data is imported in Power BI, it is like irrelevant to me. It's a composite data import I am doing, right? So in my presentation, when I am talking about importing data, there are different importing modes, right? Data import can happen through different ways. Okay, one is direct query mode, in which I create a live connection to the database, which I'll also show you using MySQL and MS SQL Server. And also you can do a composite mode in which you can have data imported from Excel, plus you can have direct query modes. So you can have multiple modes to connect and create a composite data model, and that's what we are doing right now in our practical. So what we are doing over here is, one, we have imported data from the web. Second, we have imported data from a text table. Now after doing text, now our next task is to import from CSV. Let's try another one. So now I have imported product subcategory. Now I'll import a CSV file. So again I'll choose the option text/CSV, and now in this CSV file, let me open this CSV file and show you what is it. So this is a list of all my products, product key, product subcategory key, products, stock keeping unit, etc. A simple CSV file, and I'm going to import that. Okay, so now it is identified the delimiter is comma rather than a tab, and it has already recognized the headers correctly, so I'll load it. Okay, so now my products are there, product subcategories are there. For product categories, now what I have done is I have created a Excel mode now. So now Excel I am using to import my product category. So now I have to click on the option of import data from Excel, and I'll say product categories. Select the sheet, load, and now, so my products, product categories, product subcategories, though with different data storage types, but still now the data is imported into Power BI. It is a composite data model. Now another very important data type which you can import is the PDF also, right? So what I have done is I have created a PDF called customers. My customers data is lying in a PDF. So what I have done is I have created a PDF which has data for some columns are there, like customer key, prefix, first name, last name, birth date, marital status, gender, email address, annual income, total children, etc., etc. So this is the data set which I have created in PDF. So what I'm going to do is I'm going to select PDF now and import customers.pdf, and see it has recognized my table on page 1 which I'm going to load. Okay, you can rename this as PDF table. So this basically, these are the different type of data types we have imported: PDF, Excel, text, CSV, and web page. Now let's take a look at another interesting data set which we want to import, is the MySQL Server data set. So what I have done is I've already installed MySQL Server on my local instance, and there's already a schema of SQL Live tutorial over there, and I have certain tables already prepared over there like department, employee, etc. So my goal is now to import this data or create a live connection with this data set. Now in order to import my SQL database connection in Power BI, you need to first download a connector, MySQL Power BI connector. So you need to go to this link and then click on download and install the MySQL connector. Based on the operating system you have, you click on download and install it. After you have done this, go back to Power BI and then give the IP address of the database. In my case, it's there in this local machine, and the schema which I want to import is SQL Live tutorial. So I'll give the name, click connect. Okay, now it's connected. So now it is asking me which particular tables you want to create a connection with. I'm choosing department and employee, and I'm just loading them. Okay, so now this is the exact data which is there in the employee and department in MySQL. Okay, so this is one example of how to create connectivity between Power BI and MySQL. Now I want to do the same thing using SQL Server, Microsoft SQL Server. So I have also installed Microsoft SQL Server on my machine, and I have used the SQL Express. So this is the name of my server, so which I'll copy the server name and go to get data, select SQL Server, and for now database is optional. I can say direct query, click OK. Okay, now it is showing me what all tables I can import. So in my SQL Server tutorial, in my SQL Server, I have these three tables: customers, employee attrition, Olympic events. So I can use probably the customers one, which is now you can see this is the data, the customer's data, which is lying in my SQL server. Okay, so I can preview it and load it. So now you can preview the data in Power BI. That is, this is the data. So I can rename as customers from MS SQL, and this is from MySQL, and okay. So now this is not the only data sets you can import. Now if you take a look at the options which Power BI gave, of what different type and variations of data it can it has compatibility to import from. Okay, so we can just take a look at the categorization on the left hand side first. There are file based like Excel, text, XML, JSON is also possible. You can evenly directly import an entire folder, and within the folder whatever data types of files are there, it will detect it. PDF, Parquet, or even SharePoint folder, which is itself a Microsoft technology. Then different kind of databases, SQL Server and MySQL we just saw, but it's not only limited to this. You can connect to Microsoft Access, SSAS, Oracle database, IBM DB2, Postgres, Sybase, Teradata, and then SAP databases, Amazon, Redshift, Impala, Vertica, Snowflake, and n number of databases which are there in the market today, Amazon, etc. Then it also allows you to connect with its own Power platforms, Power BI platforms, data marts, Power BI data flows, Dataverse, etc. Azure, there are different kind of storage mechanisms in Azure, and Azure itself is a Microsoft technology, so it has a compatibility with a lot of Azure based data storages like Azure SQL database, blob storage, Azure Databricks, right, Azure HD Insight Spark. So if you have those kind of services running on your Azure cloud services, you can even import them over here. Now online services, like you have ERPs running or some data which is shared on the internet. If you want to import it, that is also possible through certain products. Dynamics 365, Microsoft Exchange Online, Salesforce, Google Analytics, Adobe Analytics, GitHub, LinkedIn Sales. If you want to do some analysis of some social networking, feeds, that also you can import. Then other miscellaneous are also there, web-based, Hive, R script, Python script, if there's something to import, get data from. Google Sheets, like we saw one example in our video right now. So there are multiple options available. Now, once you have imported the data which is relevant to you, in our subsequent sessions, we will see how to create relationships, but just giving you a glimpse that whatever data you are importing, Power BI auto detects certain relationships and it will create for you, but then you can go and manually also change. So this is the composite data model which is getting created in the backend while you are importing the data. You can easily go and manage these relationships, either keep them as is, you can delete and create new ones manually. So there is no limitation in that. So this is what we have witnessed. We have imported data from different files types, data types, and then we have tried to, once it is imported into Power BI, then there is no limitation of how you use it. You can create visualizations across different data sets and then create your standard reports. So this is the example of importing data from web, importing data from a database, from a PDF, and then once you have data, you can shape and combine data. You can basically do whatever transformation you want to do. You want to make joins, merge the data. So for example, if we go back to our Power BI, and if I go back to my transform data section, now as I have now different data sets available with me, I can do any kind of operation, transformation on the data, right? So like I showed you, I upgraded the header row because one of the imported data was not showing the header correctly, or this column, like this exact one column is extra, I can remove the column, right? All those transformations, whatever I do in the backend gets captured in the applied steps section, right? This is the customer data. You can create, you can merge it, you can append it, with other data sets, right? Let's, for example, I want to create a merge data set of my categories and subcategories. So I can say select these two data sets and say merge queries as new, and I can select product categories and product subcategories, select product category key on both the sides, and then they do a left auto join. So whatever product categories are there, I'll get the subcategories associated with it, and I'll create a new table which will have, now I have the table which has the category and the subcategory and subcategory in one table itself. So I can rename it now to as category subcategory table. It's a merge. Basically, it's a join between category and subcategory, and now I have a common table, right? And I can close and apply. So imagine I have created a new table which is created from one data set which is Excel based, and another data set which is text based. See this category subcategory table. So now I can use it the way I want in my visualization reports. So that's what the presentation says, right? That once you have the imported data, you can shape, you can combine, you can adjust, you can do whatever transformation you want to do and create your visualization. Okay, so what topics we are going to cover today? We are going to talk about different types of data modeling, and the most important part and aspect of data modeling is the cardinality. The cardinality which you basically decide after reviewing the nature of data, and after you imported it, what kind of cardinality you have to basically highlight, right? And there are different type of cardinalities which you might have heard earlier also if you are from PL SQL background, like 1:1, 1:many, etc. We will talk about that. Now, what are the different types of data modeling? Now, dimensional data modeling is one of the most popular and most widely used modeling. In dimensional data modeling, you have master data, like for example customer data, date, store data, product data. So these are like less frequently changing data sets. So there is an organization, right, and you have set of customers, their email ID, phone numbers, etc. that will change less frequently as compared to the sales transactions, because transactions are happening every day, every minute. So sales is a more fast changing data set in dimensional modeling, which is in the terminology of data is also called as a fact, and customer, store, product, which are like more of static data and less changeable data, is sometimes called a dimension. So this is a typical dimensional data model which is typically used sometimes, right? And then there is another model which is relational model. This is a typical model which we have been using in database design, like primary key, foreign key relationships. So for example, you have a customer who has purchased a product. So probably the customer might have the details of the product which he has purchased, and you will make a join between customer and product table. And even you can make a join between product or product type or customer or product type. So customer table will also have a key to the product type. So this is less conducive for reporting, but it is more of a transactional relational model. But of course, this is also feasible. But from the Power BI perspective, when we talk about reporting and visualization, this is the most extensively used dimensional data model. And this is what we are going to see in our example now. So what I'm going to do is I'm going to show you certain data sets. First, we will prepare and create certain of our data sets, and then we will import in our sample Power BI file, and then slowly we will create the relationships. Now, one important thing which you need to understand, that in Power BI, if you go to Power BI, there is an option that Power BI auto detect new relationships after data is loaded and import relations from the data source on first load. So for example, if you are importing the data from a database where you have already defined the primary keys and the foreign key relationships, so that is the first option which Power BI will auto detect. And secondly, if suppose you are importing two different kind of data sets, one is Excel, one is CSV, and if Power BI detects a common column, key columns, it will auto detect a relationship which you can go and later change, modify, manage in your relationship menu, manage relationship menu in Power BI, which I'm going to show you. Okay, so if I open a Power BI, and this is where the option lies, go to File, go to Options and Setting, Options, Data Load, and these are the two options which are by default checked. You can uncheck it and manually prepare relationships. There's no limitation to that, but if you keep it checked, then Power BI will do its job to detect the relationships. Okay. Now coming to the next important factor, cardinality. Now before I start playing around with my data and start showing you certain relationships, it's very important to understand these four types of cardinalities. One is many to one, right? So basically many to one means that many orders contain data of one customer. So per order, one customer is there. So from customer to order or product or delivery address, it's a one-to-many relationship. And from the other side, from order to customer perspective, it's a many-to-one relationship. Okay. Second, other cardinality is 1:1. 1:1 relationship is only applicable when you are saying it's an extension of the current table. So for example, in one table you have employee details and you are extending the details of the employee in another table like employee address, employee ID. So that is like 1:1. There is no multiple records of a single employee. In the address table, only one employee ID exists, right? Now 1:many, as I said, is the reverse side of many:1. So in customer table, only one customer record exists per customer, and one customer can place many orders for multiple products and can also have multiple delivery addresses. So that way, this is a typical 1:many relationship. We will be seeing this example also in our sample data set. And last is the many-to-many relationship. Now, many-to-many is a very typical example, so which I'm going to show you practically. And in our case, we will see that, like for example, you have placed an order for a particular product, but there are multiple fulfillments which has happened. So suppose you made order for 10 products, but at the back end, when the company is fulfilling, it is first fulfilling the first 2 products, then the rest 3. So basically the fulfillment is happening in batches. So one order ID might have multiple fulfillments for the same order ID. So there will be a many to many relationship, which I'll show you practically. So now with this background, let's start importing our data. Now the first important thing which we need to import is the master data. So first I'll import all my master dimensions which I'm going to use in my example. So first is the customers table, customers data. So this is the customer details, like customer key, prefix, first name, last name, birth date, marital status and gender. Some redundant columns are also present, but we'll remove it. Now my customer data is loaded. Now today's session is all about this section of modeling. So we will keep our focus over here. Okay. Now some columns, probably some blank columns are there. I can select them and say delete from model. Yes. Okay. So now this is my customers data with the relevant columns and the key per customer, customer key. Now there's no relationship in this model right now, right? Because only single table is there and the associate data is only imported. Now let me also import my another important master table is the products. Select the product data, product key, product subcategory, product SKU, product name, model name, product description, color, size. So just see all the relevant information only specific to the product is available. So I'll import it. Okay. Now see, there's no relationship between product and customers directly, because until and unless a customer makes an order, places an order for a particular product, there is no join, right? So now between these two tables, the most important, now another table which will now make sense is the sales order table, sales table. Now I am assuming that Power BI have auto detected the relationship. Now you can see that because I've already ticked that checkbox. Now let's see what relations Power BI has auto detected. Let's first check the relation between customer and sales. I'll double click this join. Now what it has done is it has created a join of many to one between sales and customer. So what does that mean is that one customer can place many orders, right? And that it has detected by the quality of the data and the data sampling which Power BI has done. You can also reverse this relationship. Here I can select customers and I can select sales. Now it has become one to many. So that you can also do manually. So that is what I said. Whatever Power BI is detected, it is up to the discretion of Power BI internal configuration and algorithm, but you can go and change it. So this is now you can make, this is by default active. So we want to keep it active. One customer, many sales orders. Cross filter direction means that only from customers to sales is the filter applicable, not reverse. I'll come to this with my another example, but first let's change the relationship. So 1:many means from one customer and many sales orders. Similarly, let's see what has happened at the product side of the relationship. Similarly, Power BI, many sales orders for one product. You can, for simplicity's sake, you can say products, sales, product key is the join. Now just focus one more thing. Please also see the column on which the join is the grade column, grade out column. Product key is also here and product key is also there, and it is what we wanted. So 1:many relationship from product to sales table and active. Now looks fine. This is something which is looking logical, and probably now we can proceed further to create a report. Now let me explain the cross filtering with an example. Now, for example, I want to check in a report that what is the count of products which a particular customer has ordered. Okay, so what I'll do is I'll select the product count of product name. Now if you see, and for each customer, in front of each customer name, the count is coming as 293, 293. It is getting repetitive because there is a one-way filter between customers and sales and products, right? So this join is single-sided. It means that from customer to product, you can't find a relationship because it's a single side cross filter, right? What does this, if I change it to both, it means that it is equal to a join between product and sales, and every product detail now is appended to the sales table. So if I want to make you visualize this, you need to go here. I'll first open my sales table. We can also open it here. Let's click this OK. Now if I click OK, you can see the single arrow is changed to double arrow. It means it's a both side filter. So when you say a both side filter, it means that implicitly within Power BI, you can imagine that all the product columns now will get appended because of both ways filter you have applied. And if you go to your report now, see the change of the numbers now, 40, 20. So the total count of products across all my customers come out to be 293. Now the report looks correct. If I change the relationship from back to single between product and sales, then you can't make a join between customers and product. Basically, you can't derive the product count from the product table. See this. If you have to live with it, then you would have to go to the sales table, get the product key and get the value of count of product key, but that is not correct. Okay. So if you want a report in which you want the count of product name, and even if you want a count of distinct product name, so this will not come correctly. You would have to go and change the direction of the filter, which is from single to both. So this is a typical example there where you want to use a two-directional filter. Now let's proceed further and import other data set in order to show you another example. Now I want to show you an example of 1:1. So I have another table which is called customer details. So the key in this table is again customer key, but only email address, annual income, total children, education level, etc. Other details of the customer is there. So I'm loading the customer details. Now you see it has auto detected a 1:1 relationship. Now what is the meaning of 1:1? Means one customer key only has one entry in customer details. There is no multiple entry. So if you click this button, it's a 1:1 and the cross filter can be both or single, doesn't matter, because one customer will have only one value. You can make this as active. Okay. And if you go to the customer report table, you can now easily associate a email address with the first name. You will get 1:1 record. So now you can see that with 1:1 relationship, with the first name, I have associated the email ID, and for each email ID, there is a associated first name with that. So this is an example of 1:1 relationship. So in this example, what we have explained is that for each customer, there is an associated customer detail, right? So you have the first name, email address, education level, homeowner, occupation, and total children count. So in this report, what we have done is, if you click over here, so the first name and the email address, okay? So there's a 1:1 relationship, and if you drag the customer key, report takes time to render, and even if you can, so this is the reporting output. You have the customer key, first name, associated email address, and the count of product names which the customer has ordered. Now this is an example of 1:1. Now I want to show you an example of many to many. Now for that, I'll import my fulfillment data set. Okay, now in my fulfillment data set, there is a column for order number. So basically what I'll do is I'll drag order number from here to here. Okay, so now what has Power BI detected? I'll do one thing. I'll select sales over here, fulfillment over here, and order number to order number. Okay, so it's a many to many relationship. So it means that per order I have created multiple batches to fulfill that particular order. Now many to many relationship is definitely a candidate for both ways cross filter detection direction, but you can check that. But definitely Power BI shows a warning that this relationship has cardinality to many, and this should only be used if it is expected that neither column contains unique values. Okay, so we know that fact. That's why we are accepting this relationship as many to many, because we know there are multiple order numbers over here in the sales table which are mapped to the multiple order numbers in the fulfillment table. We'll click OK. Now you want to keep the direction as both ways or one direction. That is up to you, the way you want to map the report. So I can double click over here, and you can even click. So now you can select from which way single filter you want, from fulfillment to sales or sales to fulfillment. I'll prefer sales to fulfillment and click OK. Okay, now we have all our different kind of relationships over here, which we have tried to shortlist. One to many, many to one, 1:1, which is this example, and many to many. Now if I show you further relationships which you can keep on adding, like for example I have the example of territories. Now in which particular territory the sales was done, so I can map it over here. Okay, so now it's a typical 1:many relationship, because territory is my master table where I have a static list of continent, country, region, and it is mapped to the territories which are in which my orders have been placed. So it's a typical 1:many. So that way, you can keep on adding data. Then you have details of returns. Now this is another transactional table which is about the orders which have been returned rather than being, returned by the customers. So you have a product key. So automatically Power BI has detected a relationship between the product key and the product table, right? And even if you can join the territory key, in which territory the return has happened, right? So mostly the most common relationship which you will observe is the 1:many, because as I told earlier, the most common relational model is the dimensional model. The static data, the slow changing dimensions, the SCDs are the master tables, and the most frequent changing are the fact tables. So if I talk about a typical dimensional model, the fulfillment table, sales table, and the territories table, the fulfillment table, sales table, and my returns table are the fact tables of my data model. Now, so far, what we have done as per our last session is that we did data modeling on the different data sets which we had imported in Power BI, like products, sales data, returns, fulfillment, customer details, and customer master data, calendar details, etc. So in the last session, we prepared a data model and established the relationships between these different data sets, like 1:1, 1:many, many to 1, 1:1, etc. And we saw the examples. Now, once our relational model is prepared, our data model is prepared, now our next activity is to create certain additional columns which we want to derive basis the data which we have imported. So for example, I'll start with my product data set. Now in my product data set, I want to introduce a column which basically categorizes that if any product which has a color red, black or gray, I am going to tag it as a colored product. Rest I'm going to say not a colored product, right? So all these are like example of byte type product SKUs. So for that, now in order to introduce a new column, you just need to do what? You need to select the table in the data grid, go to the table tools and say new column. Okay, so column will get appended to the rightmost part and you will start seeing a formula section typical to like you get in your Excel. Now I'm going to say that the name of my column is going to be byte type color. Okay, and I'm just creating a if condition. If product color is equal to black, okay, or if it is equal to red, or if it is equal to gray, then say yes, it's a colored product, else say no. Okay, so now you can see basis the product color red and black, they are saying byte type color yes, blue is no, multi is no, etc, etc. So this is a classic example of an if and else condition based conditional column. Okay, so you can create such columns. Now second column, custom column, which I want to create is I'm going to call as discount. Now basis the pricing of my products, I want to associate certain discounts which I am ready to give to my customers basis the product category, like what is the pricing of the category. Again I'm going to make use of if else, but in a nested way. So if I am saying if my product price is less than 100, then I will give 0% of 0% of discount. So 0 into product price.
just to keep it consistent. Now I'm saying else, if less than 100 then 0, else I'll check again that if the price is less than 500, then I'm ready to give 1% discount on the product price. Else I'll move further. So like this, I have created a formula. So what I'm saying is, if product price is less than 100, give 0%. If it is less than 500, then give 1%. Less than 2000, then 1.5%. Less than 3000, then 2%. And otherwise, else less than 3000, if it 2%, else 3%, right? Now, after this column is created, now you can check, right? So this, see, the product price for this particular product, it is less than 100, so that's why there is no discount. It is between 100 to 200, then this has been given a 1% discount. So like this, all the discount column is now calculated. Now this column is available just like a regular column in my product table. Now after this, I'll go to my sales table. Now in sales table, I want to identify, create a column called as cost. There is no product cost column over here, so that will be derived. So let's create a column called as cost, and it is derived by order quantity into, now the cost of the product is in the product table, and I know I've already created a relationship between product and sales table. So I just need to select the product cost column. Now only keyword which I have to use in Power BI is the related keyword. So this will pick up the relation, and now for this particular sale order, the cost has already been derived. So this order number, this is the cost for which the product is the costing of the product for this particular order. Okay. Now I'm going to create another conditional column over here called as order status. I'm saying if any order whose order quantity is greater than 2, then for my organization it's an urgent order, else it is a normal order. Oh, sorry, I lost it. So this is my order status column, and I have my order quantity, urgent or normal. So any order which has order quantity 1 is normal. Any order which is having order quantity as greater than 2 is urgent. You can see this. So there's this whole Power BI tabs and sheets allow you to also review the data, what you're doing. So it's very convenient. Now I have my sales data. Now what I want to bring within the sales is my discount column. So here also I want to bring the discount which I have created. So I'll say discount. Discount will be order quantity into related product discount, right? So the discount calculated column which I had created under products, I'll bring over here. Now I am creating the order level discount. So if you see, for this particular order, there's a 25 for 25 rupee discount at the cost is 100,000 rupees. Okay. And what is the order price now? So I have taken the order cost, the discount. Now I have to create a column called as price, order price. So that will be again order quantity into related price, which is per product price, enter. Okay, so now I have the cost, the discount and the price, right, available with me. Now I want to calculate the total revenue, total profit and loss, right? Per order, how much? So first I'll calculate per order how much revenue I am generating. So now I have to generate a column called as revenue. Revenue is price minus discount so 1700 minus 25, 1700 minus 25, 2071 minus 42. And if I want to calculate the profit per order, then it is revenue minus cost. Okay, so now you can see, typical custom columns, calculated columns which we have created are all playing around with the numeric values, numeric data primarily, and trying to give inferences into per order cost, discount, per order price, revenue and profit. So typical calculation columns which I have prepared in front of you. Now let's take a look at other different variations of custom columns. I'll create certain columns for text-based custom columns, calculated columns using text-based data. So I'm now moving towards my customer table, in which I have customer key, prefix, first name, last name, birth date, marital status and gender. Now I want to create a new column in which I want to derive the age of each customer as of today, right? So I'll use another function, a date function called as date diff. Now date diff, so I want the difference between the birth date of the customer and as of today in years. Okay, so this customer as of today is 68-year-old, one is 74, 68, 57, etc. So this is one derivation of a calculated column of age. Let's take another example. Now this is a text based column where I want to derive the full name of the customer. Now here I'll say first lowercase, in lowercase I'll concatenate the prefix, then ampersand, space, ampersand, first name, ampersand, space, ampersand, last name, and closing brackets, etc. Full name. Okay, so this is an example of full name in lower cases. Now another calculated column, conditional column at the customer level. I want to identify a flag which says who is my target customer basis the demographics shared over here. Target customer. So I'll say if the marital status is equal to M and total children, and total children annual income. So okay, so let me change the logic a bit. So marital status is M and age is less than 50. These customers are my target customers. Okay, so I would say yes, else no. See this. His marital status is married, Logan Diaz, and age is less than 50, else everyone. So if I try to filter, so these are my target customers. 69 out of 1178. So this is just a conditional column, but a logical condition, an example which I'm trying to highlight over here. Okay, now let's look at certain calendar date oriented columns, calculated columns. Very typical, like now I have a simple date column. Now I'll keep adding certain columns which which will help you understand how we can do some calculations on the dates. So like for example, I want a date which is 12 days after the current date, the date in the column. So just simple 12 days after, select the date and add 12. Now if you see the date format, you can go and change the format at the top, and if whatever you feel like this. Now see, 12 days after 1st Jan 2015 is 13 Jan 2005. You can go and change the format and other details. Let me also show you, if I go to my cost and other columns, I can go and change the format. This is like a currency, cost is currency. So I can go and select the change the currency type, and you can even show the dollar value or whatever currency type it is. So for numbers you can do currency, or text or dates you can select the format. So this is available at the column tools level. Now in customers, like we had our column of full name. So now what all things are available? Format as text, okay, data type text. So very minimal options are there. With date you have options of the date format. Now next, I want a column which defines the expiry date. Okay, so 8 months prior to the expiry date which is coming up in 8 months. So I'll create a column called as 8 months expiry, and then there is a edate function. I'll use that. I'll use my date in the data set, comma, I'll say 8. So now this date column will append 8 months to my actual date, and again I can go and change the format. Correct. Now another important column, like I want to know the date name. So I'll use a function called as format, and I'll select my calendar date column, and I'll say give me the DDDD format of it. So it will give me the day name, the day name of on that particular date. Next, years in between. So I want the years in between the today's date and the date of my calendar. So equal to date diff, the calendar date, comma today, comma year, end. 7 years, 2015 to 2022. Then last date of the month. So if I want what is the last date of this particular calendar month, I will use a function EO month, which is there available in the Power BI. So I'll say last date of the month equal to EO month. Then just select the calendar CSV date, comma 0 in months, and enter. Change the format. Then similarly, start of the month, so I'll use a function called start of month. So for all January dates, end of the month is 31st Jan and start of the month will remain 1st of Jan. Change the format. Next, I want to know what is the week number of that particular date. So now there is an inbuilt function called week number, week num, and just pass the date and you will get the week number. first week of the year, second week of the year, etc. Now another very good example is whether the week day is a weekday or a weekend, right? So what is it? It's a week type. Okay. So I'll put a if condition, and there is a function called weekday, and I'll pass the calendar. If it is less than 6, it means it's a weekday, else it's a weekend. So all Saturday and Sunday day names will come as weekends, and else everything else will come as weekday. So these are very different variations of different column types, calculated columns, which is a very important utility, and any Power BI project you will definitely be ending up creating n number of calculated columns to derive your numbers, to prepare your reports. But it's important to understand what all things we can do. Yes, there are n number of functions available in Power BI, but what I have tried to showcase over here is some important functions. But basis your utility, basis your problem statement, you can look up for a relevant function in the Power BI dictionary. Now with this introduction to calculated column, this is the base for us to now get into our next session, where we will be talking about creating DAX measures and DAX functions. We will be using Power BI DAX functions, which is much more powerful than simple calculated columns, where you can do more complex calculations. You can calculate totals and then use them in the reports. So for that we will look up into our next session.
Feeling inspired already? Not one, but we have multiple success stories to share if you are inspired. Consider checking the Simplilearn's postgraduate program in data analytics offered by Purdue University. For more details, use the link in the description box below. The link should redirect you to the official course landing page that will give you a complete overview of the course being offered. Also, if you are a complete beginner and an aspiring data analyst looking for online training and certifications in collaboration with leading experts, then search no more. Simplilearn's Data Analysis Master's program should be your right choice. For more details, use the link in the description box below.
In this session, we will start with certain exercises which we will perform in Tableau in order to understand some basic concepts. Now, in order to learn Tableau, the basic first step is to import a sample data. So in our case, what we have done is we have imported a sample superstore, which is in Excel format, a sample superstore.excel, which has 3 worksheets in it: orders, people, and returns. So by importing this data into Tableau, first of all, we will create relationships between these sheets in order to identify who all have placed orders and how many people have returned the orders. We will do some analysis on the orders placed by a certain set of people and order returned by a certain set of people. Now, as we have imported the sheet, we will make certain joins. So the first step is to drag the orders table, the order sheet, on the relationship canvas here. Okay, and you can see the data, sample data, the first 100 rows over here. Okay, then now we need to create an inner join with people's table between order and people. Okay, so if you see, it has automatically detected the field names on which the inner join has to be created. So on the order side, you have region, and on the right hand side, which is the people data, you have also a region. Okay, so both these columns are common, and that's how we have made a join between orders and people data. So if I close this box and go and check the people's data, open, so see the region and the person, these two columns from the people table have now been joined with the orders table, right? So it means that these are the orders in a particular region which has been placed by in this region. Let me show you the sample superstore Excel file. Now this is the structure of the file. You have a sample list of transactions, basically the orders which are placed by customers across multiple regions, south, west of USA, south region, west region. Then you have a list of order IDs which have been returned. So basically the order ID in the returns sheet matches with those orders in the orders table. And then you have the people sheet in which you have region and a person associated with that region, the salesperson associated with that region. Okay, so basically when we are joining orders with people, we are joining that which orders belongs to which region and who's the salesperson associated with it. So what we have done over here is we have made an inner join, means all the orders should belong to particular region, and that region is in the people's sheet. And then in the second step, now we will make a left join between returns and orders, not inner join. We'll make a left join between returns and orders, and we will make a join using the order ID. Okay, so just edit this, click on left and select order ID as the join column. Now what does left join means? Left join means is that consider all the orders from the orders table and only consider the orders from the returns table which have data, means which are returned. Otherwise show null for the order IDs which are not returned. So if you see, these are the two columns from the returns table, and these are null because this is relevant to the order IDs which are not returned, okay, which has been accepted by the customer. But these are the orders for which you see data in the returned and order ID column. It means that these have been returned. Now with these joins in place, please save your book, and now we have our relations created in the Tableau. Now we are ready to create certain reports and extract certain KPIs using this relationship model. Now we'll move to sheet 1. Okay, and first we will place state and person on the rows sheet. Okay, then I'll go to my numbers and put the profit or the, so per state, per person, how much profit I am making as a company. Okay, this is my goal to check. now sort by highest to lowest. So California is giving me the maximum profit of 76,381, then New York, then Washington. So this is the sorted order in which I have listed my profit in descending order. Now I can also check what are the number of orders placed and check the distinct count. So out of 120, out of the total orders of 127, okay, so this is the total number of orders which have been returned for California is 127. It's 16, 29. So the sorted order is as per the revenue, as per the profit, and this is the details of the orders which have been returned per state. So if you see for Connecticut, for Kansas, there are 0 returns. So you can also extract data. Table to refresh is orders and identify new rows using order date. So as and when new data is being added, you can refresh it. Now say extract, and now you can save this information, profit by state, and click save. So this is the extraction of this particular report which is possible in Tableau. So this is the first exercise which we have completed for reviewing and analyzing the profit per state, highest to lowest, and within that per state, what are the number of orders which have been returned by all the customers, the distinct count of order IDs which have been returned. Now let's start our second exercise on creating calculated fields in Tableau. Now in this exercise, we will be doing certain activities, like we will be creating a set to show the states which have more than 100 customers. Then we will be creating a calculated field to show an average sales per customer. Okay. Then we will create a calculated field to show the sales goals, and then show emerging and developing stage. So these are the 4 KPIs which we have to derive. Now, the first thing, we have our sample superstore data already imported and the relationships created, inner join with people and left join with returns. Now we have our sheet 2 in which we will create the states, a list of states which has more than 100 customers. So what we have to do is we have to right click on the customer name and click create set. Okay. Now we have to give the name as states with 100 plus customers, and then go to the condition tab, select by field, and then apply condition as count of customer name greater than equal to 100 and click OK. Now we have this set created, states with 100 plus customers. Now to determine average sales by customer, we have to now create a calculated field. So go to the analysis and click on create calculate field. Okay. Now name it as average sales per customer, and now we will say average we will use a okay, so we are saying that per customer we are using a level of definition function include, which means that per customer what is my average sales, right? We've already used a function, aggregated function called average. So we are saying per customer give me the total and then give me the average per customer. So we're going to click OK. Now create another calculated field. You can also create from here and name it as sales goal. Now in this we are going to type the formula if minimum states with 100 plus customers equal to true, then sum of sales into 1.3, else average sales per customer into 100. So we are saying that if the customer belongs to the set of states with 100 plus customers, then the sales target should be 1.3 times the actual sales as of today, else it should be 100% of the average sales per customer. Now let's create another calculated field which we call as emerging or developing state. If distinct count of customer name is greater than equal to 100, then the state is tagged as developing state, else it is called as emerging state. Okay, so we have now 3 calculated fields: average sales per customer, emerging or developing state, and sales goals. Now we will use this in our reporting. So we will drag sales goal under the columns and then I'll drop my state. So now this is the state wise sales goal, depending whether the state has 100 plus customers or not. Then add your customer name. Make the measure as count distinct and make it as discrete. Okay, so if you see this, we have the count of customers per state and the sales goal for that particular state. And now I'll put my sum of sales, the total sales which I want per, which is there per state. Now go to show me and select this particular chart, bullet graph. Now to bring sales goals to column, right click on the sales axis and select swap reference line fields. Now from your left hand panel, drag and drop emerging or developing state on the color panel. Okay, so emerging state is the orange one and the developing state is the blue one. And save the sheet as developing and the emerging states. So if you see this, it's an emerging state because its count is less than, the customer count is less than 100. Its sales goal is 57384, but the actual sales is 19511. Okay. So now this is a developing state. Its count is greater than equal to 100 and its sales goal and its sales is exactly the same. It matches. So that's why you are seeing the bar and the blue bar is ending exactly where the vertical bar is. So what we are trying to depict is that whether the state is going beyond its target sales goal or it's behind it, and you can see that using this particular vertical bar. Like for example, Michigan, its sales goal is 71,952, but its actual sales is 76,270 average sales. So that's why it is above its target and it's a developing state because it has more than 100 customers. So you can even sort by the count of the customers higher to lower. So all your developing state will group from at the top and the emerging states will group at the bottom. Or you can sort by the sales goal. So the orange bar is the sales goal or the blue bar. So depending what sales goal is being derived for each state. We are going to take example of the Netflix database which we have, and we will prepare certain reports in order to identify what kind of reports we can generate from such a data set. So currently on my screen what you can see is the Tableau, the Netflix data sheets, the data sources, where you have the Netflix shows, movies, their associated duration, what kind of shows or movies are there, their release year, the associated rating, description, and a key which is the show ID. Now this is the unique identifier for each show in this Netflix title sheet, and with this show ID all other sheets are related, like who are the directors of the show, in which country the show was released, what is the cast of each show, all that information is in this sheet, and to which particular category, basically the listed in category is being listed in this particular sheets. So what we are going to do is first we are going to import this sheet into Tableau. Okay, and then create relationship between them using the Tableau relationship canvas. So first the primary transactional table, the sheet in which all the information related to movies is there or shows is there, is in Netflix titles, and then we will drag sheet like Netflix cast, titles cast. Now Tableau has automatically identified the relationship between the show ID of titles and show ID of titles cast, and it has made a join. So if you double click this, you can see this relationship, cardinality, and the related fields. Similarly, I'll drag titles category, countries, and directors. Now, by virtue of this, all the sheets have now been joined with Netflix titles, and with this relationship ready, we can start preparing our reports. Now let's create a basic report where we can just glance the data, like whatever we were seeing in the Excel, how it looks in Tableau. So you have all the types of movies. Then, for example, I drag the release year. Now, first, I do not want to consider it as a dimension. So I'll just release year. Per category, per type, there is a release year. And then I'll drop the listed in. So now these are the categories. So per year, the details of the categories, right? And then you can drag the title and the associated rating. So this is just a view of your data. We can name it as shows listing report. Now let's try to create some report for some measures, some numbers, etc. So now let's check in which country how many movies or titles were released. What is the count? So first let's drag the country. So as soon as we drag the country field, it has identified that it has the geographical names and identified the latitude and longitude details. So Tableau internally does that automatically, and it has identified the spots across the globe of the relevant country. Now let's drag the listed in on the color section. Now what it is doing is it is showing in which country what different kind of category wise movies are or shows are being released. Like in Sri Lanka, documentaries have been released. In India, action and adventure. United States, action and adventure, like this. Now let's put a count of the titles, right? So if you see 247 action and adventure movies or shows have been released in United States. Okay, so this is one inference by this particular report you can identify. So let's save this report as listed in by country. Okay, now let's create another report. We will call it as the per year statistical report. In this, first I'll put the release years in the column. Now count of Netflix titles. So this is the count of Netflix titles per year, 2017, 2016, 14. And then count of Netflix titles in the countries. This is the second bar chart. Okay. Now what I'll do is I'll combine it into one. So one report we are moving in the bar, creating the bar, and one in the line. And now I just have to, so we will click on the count of Netflix titles by country, right click, mark it dual axis. So now as soon as you click this, both the charts have been combined, and right click over here and say synchronize access. Okay. Okay, so now if you can see right, in 2017 you had 2303 Netflix releases across all categories and 1159 titles, right? 1063 titles in 2017. So this is a descending representation of the count of titles released per year across category and across titles. So let's call this as per year stats. Now let's create another report. Number of shows per title. Okay. So, or sorry, per rating. So we will drag the rating column and we will count of titles and unique count of titles and unique count of show IDs. Okay. One is bar and one is line. Okay. So this is a report which shows rating wise titles and the show IDs. So in the tooltip, you can see the distinct count of titles and show ID per rating. Okay, so let's call it shows per rating. Now let's create another sheet, call it as shows by cast. So in this, what we're going to do is first drag the cast column on the rows section. You have name of all the cast, and then we drag the show ID on the column section and put a count D and sort it. Okay. You can remove the null cast, and this is your sorted order. And on the labels section, you can say show mark labels, and you will see the count that Anupam Kher has done the maximum, then Shah Rukh Khan, Om Puri, Nasruddin Shah. So this is the details on the sorted order, that who has done how many shows. Okay. Then next is shows by director, similar to shows by cast. Drag director into rows, or differently if you want to prepare, into columns, and then count of show ID Okay, sort it. And you can actually filter out the null director value. And this is the account. Put the label. So you can see Jan's sweater has the maximum shows. Okay. Then create another report, shows by category. Now similarly drag the listed in the rows and show ID count. Remove the null category and sort. Labels, show mark labels. So international movies are the highest category, dramas the next, comedy, international TV shows. This way you have your category. Now let's create a dashboard in which we want to combine all these reports and take a common view. So first let's drag listed in by country, then shows by director. Also please let's set the size as automatic. Then let's drag shows by category and shows by cast. Now these 4 reports are on a single dashboard. We will link them to each other. So go to worksheet, actions, add action, filter, select dashboard 1. Only select shows by category here. And in target dashboard 1, except shows by category, keep everything else. And in the source sheet, just select, click OK. OK. Now, whatever category you will select over here, that related category data will automatically be shown in other reports, like see international movies across the globe, across the countries, directors of only international movies, who has done the maximum, Johnny Toe, and shows by cast, right, that who has done the maximum international movies or dramas or comedies. See, Paresh Rawal has the maximum number of comedies. And then if you see the comedy movies, these are the count of comedy movies released across the countries and who is the director. Another very interesting report which you can prepare is that, for example, you want to check in which country maximum duration of your maximum duration of movies have been released. So first let's create convert to measure, remove this. Okay. So if you see, maximum duration of the movies or the entire Netflix content is maximum United States, then in India these many minutes, next is United Kingdom, and you can also change the colors. Whatever you feel is as per your standards or as per the convention, you can change the color combination. So there are multiple ways you can generate reports, and hope you have
understood how you can leverage such a data to create your reports.
We have reached the end of this session on the Data Analytics Crash Course. Should you need any assistance, PPT, project code, and other resources used in this session, please let us know in the comment section below. And our team of experts will be happy to help you as soon as possible. Until next time, thank you and keep.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.